Taranga has always served as a platform where innovation, learning, research, and academia interaction come together under one roof. May we request Ms. Riyanka Das and Ms. Shohini Kundu to kindly come up onto the stage and deliver the welcome address.
Respected dignitaries, honored guests, faculty members, industry expert participants, and also the Indian Ceramic Society faculty members, dear friends, a very warm and energetic good morning to everyone present here today. Together, we warmly welcome you all to Taranga'26, proudly organized by the InCerS Students Chapter of Government College of Engineering and Ceramic Technology. Today is truly a very special and proud moment for all of us because Taranga'26 marks the second edition of the incredible journey that began with a dream, a vision, and the determination to create a platform for innovation, learning, and collaboration. Last year, on 13 January 2025, we organized Taranga for the very first time with immense enthusiasm, excitement, and dedications. What started as a small initiative soon became a memorable success beyond our expectations. That success became even more meaningful when our InCerS student chapter received the prestigious Best Student Chapter Award in its very first year. This achievement inspired us to dream bigger, work harder, and return this year with even greater passion and confidence. The appreciations and encouragement we received from our respected teachers, mentors, guides, guests, and participants motivated us to make Taranga 2026 even more innovative, impactful, and inspiring. This year, Taranga 26 proudly presents the theme Traditional and Advanced Ceramic Research in AI enabled next generation green advancement. And our tagline beautifully reflects the spirit of this vision, where tradition meets intelligence for sustainable ceramics. Also, we have included plant seeds in our registration kit. We sincerely request everyone to plant at least one seed at your home and become a part of this dream initiative. You will notice that the Taranga installation at the registration area, it has been creatively made using broken waste tiles, showing how discarded ceramic materials can be transformed into something meaningful and beautiful through sustainable thinking. Taranga serves as a platform where young minds, researchers, academicians, and industry professionals come together to exchange ideas, explore innovations, and discuss sustainable solutions for the next generation. Taranga is not just an event, it is a celebration of talent, innovation, teamwork, and learning. The Taranga means waves. Waves of ideas, creativity, dreams, inspiration, and also the progress. Just like waves never stop moving forward, Taranga inspires all of us to continue learning, improving, and growing together. It encourages students to showcase their talent and discover their true potential. Winning is important, but the courage to participate, express yourself, and learn from every experience is even more valuable. We also extend our heartfelt gratitude to our respected guests and speakers for joining us today. Your presence adds immense value, inspirations, and encouragement to these occasions. We hope today's session, discussion, interaction create meaningful learning experience, inspire innovative thinking, and strengthen the connection between academia and industry. As we begin Taranga 26, let us celebrate creativity, innovation, sustainability, and unity together. Once again, welcome everyone to Taranga 26. We hope you all have a wonderful, inspiring, and truly unforgettable experience. Thank you so much.
Thank you for those warm and gracious words.
With that beautiful beginning, we now move towards the ceremonial inauguration of Taranga'26.
Knowledge enlightens minds and removes darkness.
To mark the auspicious beginning of today's event, we now proceed with the ceremonial lamp lighting and felicitation of our esteemed guests.
May we respectfully invite Professor Dr. Krishnendu Chakraborty, our Principal Sir, Professor Dr. Rituparna Sen Sir, Dr. Shitendu Mondal Sir, and Dr. Saumin Sinha Sir, our Chief Guest for today, to kindly come onto the stage. I would also like to request Dr. Partho Haldar to come up on the stage.
And we would also like to invite all our core team members, Chairperson Mr. Diganta Ghosh, Vice Chairperson Mr. Ayanava Maji, Treasurer Mr. Pishdush Nandi, Student Coordinator Ms. Riyanka Das, and Secretary Mr. Shubhankar Roy to kindly join us on the stage.
Let us welcome them with a huge round of applause.
This is our Bluetooth-enabled first time a lamp lighting ceremony. Our chief guest, Dr. Saumin Sinha Sir, lighting the ceremonial lamp. Dr. Shitendu Mondal Sir, the Honorary President of Secretary of Indian Ceramic Society. Our HOD, Dr. Rituparna Sen Sir. Dr. Partho Haldar Sir, a professor. And together, the core team of InCerS SC GCECT lighting the lamp. Can we have a huge round of applause? Thank you.
Thank you to our respected dignitaries and core members. The ceremonial lamp lighting symbolizes the illumination of knowledge and spirit of learning that Taranga stands for.
I would now like to call upon the chairperson of InCerS SC GCECT, Mr. Diganta Ghosh, to felicitate our principal sir.
GCECT Mr. Ayanava Maji to felicitate Mr. Saumin Sinha Sir.
I would now like to call upon the treasurer of InCerS SC GCECT, Mr. Piyush Nandi, to felicitate our very own RS sir.
I would now like to call the Secretary of InCerS SCGC Mr. Shubhankar Roy to felicitate Sitondu Mondal Sir, Honorary Secretary of InCerS SCGC.
Shubhankar felicitating Dr. Shitendu Mondal sir. I would now like to call upon the student student coordinator, Ms. Riyanka Das, to felicitate our Partho Haldar sir. Riyankati felicitating Partho sir. As we continue this auspicious beginning, let us come together to express our pride and respect for our nation.
May we request everyone present here to kindly rise for the national anthem.
Thank you so much, everyone. Please take your seats. We now request our respected Principal Sir and Chief Patron of Taranga 2026, Professor Dr. Krishnendu Chakraborty, to kindly address the gathering.
Good morning, respected members on the dais, speakers, guests, my colleague, and my dear student. It is indeed a very happy occasion for me when I see that our students are much more brilliant than we are. We feel pride. Today's event, the way you have arranged it, the way you have decorated it, it is extremely well. Now this Ceramic Society student chapter in this college, it is very new. Maybe it is age wise, it is the third year probably, as I can recall. Third year, second year. Now in these 2 years, you had many activities and with innovation. One day when student called me to a seminar in a Friday, I was surprised that the way they are delivering a technical topic to the full understanding of layman like me. Why I am calling myself layman? Because I am not from the ceramic. So many, on all Fridays, I have attended your seminar. I have seen how lucid you are in explaining your topics. Why I am mentioning this? I am mentioning this that you have initiative to spread your message to all fraternity in the society. And it is another matter of pride that in this young age of your society, you got Best Center Award. Probably last year you have got it. So this cannot happen unless and until you are sincere, you are innovative, and you are putting your best effort to this. Now in this college, since it is an engineering college, it is a professional institute, we give importance to professionalism. Now today, everybody will appreciate that the way you are presenting yourself with wearing t-shirt, with badges, it brings a different color to the institute. And this makes us memorable that, as I was mentioning, that our future are in safe hand like you students are there in the institution. So in future also, we will accept, we want that this type of activity should continue, and I hope that it will continue because probably I met you in last Friday. On that day I was telling that Monday, Tuesday I won't be here. Always I was afraid that if I am not here, if you face any problem, how do you solve it? So I had some anxiety in me. Now last Friday probably I met you. Incidentally, the holiday has changed. Previously Tuesday and Wednesday was the holiday. Now this holiday has changed. It is changed to today is the holiday. On that day, I commented that how you will manage it, and I gave few instructions also. I never thought that the way you will do it, and the banner you have put, it was an extremely difficult task to put the banner in that height. That also you did it. So everything is fine. I hope that today's deliberation also will be fine, and it is a gathering. Always I believe that since we are professional, there must be a professional society in institution. The way Ceramic Society have a professional association, similarly IT, Computer Science also should have their professional association. I believe that we survive in our professional association, we develop some brotherhood in our association, we share our idea, then only we can grow in the profession. Now we have many identity. In my house I have an identity. In the society also, in the professional society also, I have my own identity, and this identity to be preserved, then only I will feel myself happy everywhere. Happiness is the very, very important part. Every one of us, we want to be happy, and the activity, it can be attained through many activities. I will not linger my talk. Today, really I am very, very happy. Morning I thought that I will not come, but if I wouldn't have come, I have lost many things. And it is a great memory for me that I have seen how expert our students are, how active our students are. That makes us proud, that makes whole institute proud, and this will continue in future also. As a teacher, we survive in a reflected glory of our student, and in future also you will make us proud in all the activity of the institution. With this, I wish this particular event a grand success. Thank you very much.
I would now like to invite Professor Dr. Rituparna Sen, our HOD sir, for a talk.
Good morning, revered Professor Krishnendu Chakraborty, our principal sir, Dr. Soumen Sinha, our chief guest, Dr. Shitendu Mondal, Secretary, Indian Ceramic Society, the executive members of Indian Ceramic Society, everyone is there. My student who are executive committee members of the students chapter of Indian Ceramic Society, and all my student friends. This is an occasion, really I am very proud of seeing you all here on this holiday, particularly when I heard that 28th would be declared a holiday. I was very much shaky as how it would be possible to gather students just after the examinations, when everybody wants to go home and relax a little bit, because after third year students are again they are to be ready for going towards training. So this is just a 4 or 5 days gap, and fulfilling this thing in a befitting manner like this, what I am seeing today, it's just like I am really astonished and also very, very glad to see this. Now, when this particular program was planned, not even 1 month ago, I think when Digonto and Piyush Nandi came to me to write to people, and they are thinking to organize it on 28th of May, not even in first week of May, I think it was in first week of May. So I was really taken aback, how it would be possible for inviting people, so many people, like so busy people from Nagpur. Dr. Sinha has come. Dipankar Banerjee would be delivering lecture from, he was in USA the just day before yesterday. He came back. People like Nandan Santra, Ashish Kundu, all they are my students. So I wrote to them. Even President Indian Ceramic Society, Dr. Ratanuranjan Pal, was to come also. Till the other day, just day before yesterday, he expressed grief that it may not be possible for him because of one very important thing that has come up. He is not able to make it. So I was very sad. Anyway, you are having also stalwarts from the industries, from your alumni brothers. That is another very, very important thing, that we are organizing so many lectures, so many technical talks. Earlier also you have seen every Friday or Thursday we had been organizing lectures, followed by some quiz contest, and also with the advice of our principal sir. So we are offering prizes, first, second, third, amongst the contestants who are taking part in the quiz contest, just followed by the technical talk given by our distinguished alumni. So that practice will go on continuing. So this year it has started, and I will try to maintain till I am here to continue this thing every Friday. I have made provision in the routine also. So you will immensely get benefited if you actually want to learn something. So this is a time for you for learning. Once you enter into the professional life just after final year, you would not be able to enjoy your life like you are having now in this college life. So much of fun, frolic, so much of co-curricular activities and all that. And then during the profession, you will have to concentrate only on your profession. You have to interact with people who are very competitive, and you have to show your worth. Whatever you have gathered from the institution, that will have to be proved in a very meaningful manner, otherwise you can't sustain. So that is the simple advice. Nowadays, the guardians or parents don't give advice. You are friends. Shoroshe borshe putte putro mitram badacharet. So you are like friends. So I am just sharing my thoughts with you. So whatever you learn from your core of your heart, so that you can apply it to the fullest extent when you go to the professional life. Now today I want to lengthen my discussion. It's a proud moment for us, for the institution, to have with us Dr. Soumen Sinha. Ashish will come, Nandan Santra will come, from Vesuvius we will be having one expert, and we will be having Dipankar Banerjee also. So who has travelled so much of distance, and being such a busy person, he has come to interact with you. So I will expect everybody of you will interact, will try to learn something from him. Due to my ill health, it may not be possible for me to continue till the end of the thing. Actually, it is not advisable for me to go out in this health condition. See, I am wearing a mask, I am not opening it. I would not be able to take any food also, any outside food. But till I am here, I want to see your faces gleaming with delight to enjoy this occasion and take the benefit of it to the fullest extent. Thank you very much for organizing these things nicely. Whatever I have seen, the tunnel kiln you have made out of the tiles, broken tiles, you have made the Taranga. The name also was proposed by me, I think, amongst many names. So I am very proud, and I am also very proud to see so many of you being present today on a holiday. So enjoy your day. I wish the program to be a full success. Even in my absence, when I will depart midway, I hope everybody will be there till the end, because Dr. Sinha would interact with you in the afternoon session. It may not be possible for me to stay till that time because my health would not permit me. But I will expect every one of you would join till the end and stay till the end. Take something positive from this. Have a nice day. I wish the program full success. Thank you very much.
Thank you so much, sir, for your continuous guidance and encouragement. Also, can we have a huge round of applause for sir, because he came even after having such a sick health, and he is here to support all of us. So thank you so much, sir. I would now like to request our professor, Dr. Partho Haldar, to share a few words of encouragement with us.
A very good morning to all the students, respected principal sir, Dr. Sinha sir, Dr. Mondal sir, and our HOD Ceramic Technology, Professor Rituporno Sen sir. Today it is indeed a matter of pride and glory for the Institute, Government College of Engineering and Ceramic Technology, that TARANGA' 2.0 edition, TARANGA' 26 is occurring in this grand manner. The success, the credit goes to all the students working, making this happen, and obviously the persons who are supporting it from the behind. Now, Principal sir has told the background, RS sir also told, but today, in spite of this holiday, I will request each and everyone that what we do during a holiday actually. So we, after getting a tiresome week, we wish to have some fun of our mind, right? And this is the platform where you will get some fun for your mind. And these ideas, these innovative ideas that will be talked throughout the day, this will give you the motivation to work for maybe 6 or 1 year, upcoming 1 year. With these ideas, if you nurture those ideas in the college, that will in turn give you more joy and fun. Obviously, I can assure you that in spite of you are attending this program on a holiday, it will give you more joy and fun. Now, since industry nowadays, this word academy, industry academia interaction. So these interaction, these are some buzzwords nowadays. So it is our privilege that a person, the director innovation technology from Calderys, is having with us. So it is a matter of it is a great opportunity and privilege for all of our students and us that during his talk on the dais and off the dais during our interaction, so we can directly talk with him, we can get some genuine industrial problem, and after solving those problems in association, in guidance, in close guidance of him, the standard of research in Government College of Engineering and Ceramic Technology will be higher. So this will in turn again enhance the teaching learning process. So it's a closed loop. So since it's an institution of higher education, so until research is done in a great way, the teaching, if the research reaches to a greater height, then obviously the teaching learning process will enhance. So I am taking this event in this professional direction, and so I hope this event a great success, and thank you to all.
Now comes a moment we eagerly looked forward to.
It is our privilege to invite our esteemed chief guest, Dr. Somin Sinha sir, to address the gathering.
Can we have a huge round of applause?
So respected Professor Chakraborty, Professor Sen, Professor Haldar, and then Dr. Mondal, and brothers and sisters, because I am also alumni of this college from 1990 batch. So I will not just I think as a brothers and sisters, okay. So a hearty welcome to all of you from my organization is Calories, and good morning to all of you. So, and I am feeling very privileged to be here today. Maybe I came college maybe few years before one campus interview, and afterwards I could not make it, but then this agenda, I think it brought me back in the college among with you, and I would love to be here for the day, so that we can have lot of interaction and learning. Learning is mutual, as Professor Shen was also mentioning. I would also look forward to learn something, and the beautiful thing message what I got from Professor Chakraborty's message is the happiness, because today I think the world is searching the real happiness, how it is, I mean money, other things, as you will grow in the career. So gradually that will also, you will find your own way to be happy. So that is also good interesting topic today he was discussing. Now coming back to specific to this program. So from the morning I have seen that lot of vigor, energy and enthusiasm with which I think you are organizing this event, even after all the odds, meaning the holiday, your exam and other things. So I think that brings me to the actual theme, that Tarang. So is to me is a symbol of progression as well as a symbol of challenges. And if you see the industrial environment today, everybody we know, the lot of challenges are there in the surrounding environment, okay. But I think if we progress collectively, and maybe the young generation, if you take the lead and then go forward, definitely challenge, every challenges can be overcome. Okay. So Tarang that way is a very meaningful word for me. And second motivation was, as Professor Sen was mentioning, that Tarang the way it was, mentioned in the reception backdrop. So with the waste material, so that means the sustainability. Because today the world is hovering around development, sustainability, whatever you call environmental friendliness, or maybe carbon footprint reduction. So definitely I think this Tarang and then the participation or the enthusiasm, what I could see from the morning or even before that, the way they were corresponding with me, and then so definitely it gives lot of encouragement for people like us, and all the very best, and I look forward for a meaningful discussion and a lot of learning opportunities together. Thank you.
Thank you so much, sir, for your kind words. I would now like to call upon Dr. Shitendra Mondal, the Honorary Secretary of Indian Ceramic Society, to give a speech.
Very energetic good morning. This I learned from the students this morning. Respected Professor Chakraborty, Professor Rituparna Sen, Dr. Somen Sinha, Dr. Partho Haldar, my dear students, namely Riyanka, Sohini Kundu, Digant, Ayanava Majhi, Piyush Nandi, and Subhankar Roy. My dear students, industrial representatives, dignitaries, and my colleagues from Indian Ceramic Society headquarters of Indian Ceramic Society CGCRI, very good morning. So I will speak about 2 minutes about GCECT and 2 minutes, 2.5 minutes for Indian Ceramic Society. The Government College of Engineering and Ceramic Technology Student Chapter was founded last year on 6 January 2025, and they have organized many such innovative events, seminars, workshops, and other things. So they made themselves proud, not only in organizing the things, but showing the tremendous amount of organizing capability. And that's why they have bagged the highest student chapter, best student chapter excellence award from the Indian Ceramic Society 2025. It was awarded in the form of a citation, always as a memento. So it was the past. The present student chapter of GCECT is that they have utilized the creativity, they have used the innovation technique, and they have shown their pathway for sustainability. So that is why they have made the Tarang board with an waste materials that shows an innovation initiative which is the real fuel to drive. At the same time, they have made the tunnel clean, utilizing the waste materials and making it a good wealth product. I think the present innovation, the present mindset of the GCECT student chapter is good enough, and they are the leading pathway for the future generation and the next generation for the greener future. That is the most important way. In future, the GCECT, I have seen that within a very short period of time, the way they have conducted this Tarang 2.026, particularly on this holiday, and they have been able to drag all the students to come over here to make this program a grand success. I think they will be continuing in the near future for sustainability. Their association, their student chapter will remain alive, will remain vibrant, and they will be very dynamic in nature in doing so for the future leaders of the students, because many of the students are coming out and they are leaving their examples to the juniors so that the juniors can follow the seniors' pathway, so that one day they will also take the things and give the things to the further junior students for sustainability, for continuing of this activity. The Ceramics Society chapter of this college was really blessed by the dynamic vision and mission shown by Professor Chakraborty as a principal of this college, well backed by Professor Divakar Das, so many faculties also there, Professor Rituparna Sen, and also Dr. Partho Haldar. And today's attraction, which is the main instrumental tool for all of you, is the gracious presence of Dr. Somen Sinha, who is the director, Galleries, and who has taken all the troubles to come over from Nagpur, I believe so. So therefore, the college chapters of this Indian Ceramic Society should continue, and they should receive much more awards from the Indian Ceramic Society, not only, but also from other associated professional societies like Indian Ceramic Society. The Indian Ceramic Society, as you know, that I will speak for 2 minutes time for the Indian Ceramic Society. The Indian Ceramic Society is growing very fast. We have already 14 chapters, including 1 chapter at the GCC Gulf Cooperation Center at Dubai. And we have the 9 chapters, 9 student chapters, and it has been growing very fast. Already we are having more than 2,500 students across India and abroad. We have well connected globally, but only problem is that the Indian Ceramic Society is growing technically, scientifically, and administratively, but only thing that the Indian Ceramic Society's journal, Transactions of the Indian Ceramic Society. This is a TICS journal, is a tailor-made Francis publication. The present impact factor is 1.5. I request all the dignitaries to come forward with a paper, and nowadays the evaluation process and the verification processes are very fast, and it is getting published in the journal. I request all the students, such a small write-up, you can have what materials you have used for the making of Tarang Clean, what materials you have used for making the Tarang 26 board, and many other things you can put from the Google, and then apply with the knowledge of the scientific principle. Make a 2 pages write-up or 2.5 pages write-up. Dr. Sucharita Manna is here, Assistant Executive Secretary and who is taking the leading role for publication of the any papers and any event news or any other review paper also. So that if you can come forward, it will be immediately published, because from the students' corner, it will be given a strong importance and attention as well. Therefore, all the students are hereby requested to come forward with a brief write-up for possible publications in the journal, and I request all the dignitaries here to come over to come up with a publication so that the impact factor of the journal can be increased from 1.5 to 2. At least we can reach to a height of impact factor 2. So that's the point of the Indian Ceramic Society is little bit. It's not so far rapid development, but it is our moral responsibility to make it a rapid development in terms of the publications of the Transactions of the Indian Ceramic Society journal. With this, I once again congratulate you people, so that within a very short period of time, you have taken all the untiring efforts, painstaking drive to make this Tarang 26 a grand success. Thank you so much, and it has given me an immense pleasure to be with you, to be associated with you, and whenever any such things, I will be coming over here to inspire. And because these inspiring words are very much important, as you have as you came to know from our principal sir, Professor Chakraborty, Dr. Rituparna, Dr. Somen Sinha, and Dr. Partho Haldar. Thank you so much. Jai Hind, Jai Bharat.
Chairperson Mr. Diganta Ghosh and Vice Chairperson Mr. Oyanova Maji to give a speech.
Good morning everyone. Myself Diganta Ghosh, Chairperson of Indian Ceramic Society Student Chapter of GCECT. Along with me, Oyanova Maji, our Vice Chairperson, is standing beside me. Today we all are here to welcome you. It is truly an honor and privilege for us to witness such an inspiring gathering of academicians, industrial experts, researchers and students under one roof. Your gracious presence has made this event even more meaningful and memorable for all of us. The theme of this year's seminar is Traditional and Advanced Ceramic Research in AI-enabled Next Generation Application. Through this platform, we aim to bridge traditional ceramic knowledge with modern technological advancement and create meaningful discussions for the future of the ceramic and refractory industry.
Good morning everyone. So basically I will discuss about our today's agenda. Today's program will begin with the inaugural sessions, followed by the 5 technical sessions featuring distinguished speakers from renowned industries and organizations. Our first keynote lecture will be delivered by Dr. Somen Sinha sir from Cambridge. After that, the following speakers are there: Mr. Nandan Sadra from RHI Magnesita, Mr. Ashish Kumar Kundu from Satabdi Monolithics, Mr. Sayan Bose from Vesuvius, and Mr. Divango Banerjee from Phosphate. Apart from the technical session, we will also have a student interaction session with the industry leaders, followed by Voices of Legacy and our cultural program, and finally the valedictory session. We sincerely hope that every participant gets knowledge, inspiration and valuable industry insights throughout this day.
Outside this auditorium, the temperature may belong to the weather, but inside the hall, the atmosphere is carrying the heat of innovation, research, passion, and the spirit of the ceramics. Just like a kiln furnace transforms raw materials into the something stronger and more valuable, institution like GCECT shape students into engineers, researchers, and future industry leaders. And today, TARANGA'26 becomes that furnace of ideas. In ceramics, we learn that true strength is never achieved instantly. A refractory survives because it withstands extreme temperatures. A ceramic gains toughness through controlled firing, and annealing teaches us that something gradual cooling is necessary to remove internal stresses and create stability. You may consider the outside temperature is like the tunnel kiln, and you may consider this auditorium is as an annealing furnace. Please reduce your stress as much as possible through this conference. Today is not just a seminar, it is the fusion of tradition and technology. It is the meeting point of science and imagination. It is where the legacy of ceramic engineering meets the future of AI-enabled green applications. As we stand here today representing the current core team of the InCerS student chapter GCECT, we also realize that this event marks one of the final chapter of our tenure. For us, InCerS student chapter GCECT has never been just an organization. It has been a family, a journey of learning, responsibility, friendship and unforgettable memories. From organizing meetings every Sunday, planning event together, facing challenges, managing responsibilities, celebrating achievement, every moment has shaped us into the better individuals. As today, while hosting TARANGA'26, we feel emotional as we prepare to pass this legacy forward.
For our beloved juniors, we have only one humble request. Please continue this legacy. Keep the spirit of InCerS student chapter GCECT alive with the same passion, dedication and unity. Organize Taranga every year with even greater success, greater innovation and greater enthusiasm. May this platform continue to inspire future ceramic engineers, researchers and industry leaders for many years to come. The chapter belongs to all of us, and now the future of this beautiful journey will be in your hand. We truly believe that you all will take this legacy to even greater heights. Once again, we extend our heartfelt gratitude to all our respected guests, faculty members, sponsors, volunteers, and the participants and students for being part of TARANGA'26. Thank you for your support, encouragement, and blessings. Thank you all. Thank you.
And special thanks to the staff member of the Indian Ceramic Society for continuous support and help. Thank you very much.
Thank you.
Thank you both of them, for giving us a glimpse into the vision and dedication and hard work behind TARANGA'26. The passion and efforts of the organizing team truly reflect the spirit of collaboration and excellence that this event stands for. And personally, I love the furnace reference. As we approach the conclusion of this inaugural session, we invite Mr. Piyush Nandi, Treasurer of InCerS SCGCT, and Mr. Shubhankar Roy, Secretary of InCerS SCGCT, to deliver the vote of thanks.
I am Piyush Nandi, Treasurer of InCerS Student Chapter of GCECT. Along with me, our beloved Secretary, Mr. Shubhankar Roy. Good morning all. So, let's start our talk with a verse taken from Srimad Bhagavad Gita. Uddhade Datmanatmanang Natma Namo Vasayate Atmaiva Hatmano Bandhu Ratmaiva Ripu Ratmanaha, which means elevate yourself if through the power of your own mind and do not allow yourself to be degraded by it. For the mind can be the best of friends or the greatest of enemies.
The man who has confidence in himself gains the confidence of others. Leadership is not about being in charge. It is about taking care of those in your charge.
Respected chief guest, honored dignitaries on the dais, our beloved faculty members, distinguished experts, and our extraordinary students, a very warm and heartfelt welcome to each and every one of you. Today, as we draw the curtain on the inaugural session of Taranga, the National Conference of InCerS Student Chapter of GCECT, as we stand before you not merely to offer words of gratitude, but to offer a dedication, a declaration that we, the InCerS Student Chapter of GCECT, Kolkata, are here. We are thriving and we are proving every single day that we are among the first student bodies that the nation has offer.
There are those who said, perhaps whispers, perhaps outright, that the chapter would amount to nothing, that the student community in the Ceramic Technology College had little to offer. The academic courses were the only currency of excellence. To those voices, we say, look around you today. We are not here to dismiss the importance of academic, but we stand firmly, unshakably on this truth. CJP is not there selling the students out. It is merely the floor. The real measure of the students lies in the leadership, their resilience, and their communications. Their courage to stand the national stage and present ideas that matter.
At InCerS Student Chapter of GCECT, we have built a platform where students are not just taught ceramic science, they are sculptured into confident, self-aware, articulate, and visionary human beings. We believe in the wholeness of education, not just in grades.
Today, they have organized Taranga, a national conference. Something that, as one of your own members articulated, was nothing less than a dream. And yet, here we stand, dream made real.
Organizing a national conference requires vision, discipline, collaboration, negotiation, marketing, technical expertise, time management, and above all, the burning belief that what you are doing matters. Every student on this organizing team has demonstrated all of this and more. Taranga did not happen in a vacuum. It was built on the shoulders of many. We express our deepest gratitude to the Indian Ceramic Society, founded in 1928, with the blessings of Pandit Madan Mohan Malavya for providing us a platform that connects student minds to one of India's oldest and most prestigious scientific societies. We thank the faculty members of Department of Ceramic Technology, Government College of Engineering Ceramic Technology, a NAC A-grade, NBA accredited institution for their unwavering guidance and the trust they have placed in the students. Your belief in us has been our greatest fuel. We extended our profound thanks to the chief guests and distinguished speakers who graced this conference with their wisdom, their expertise, and the time. Your presence has elevated every moment of Taranga.
To our sponsors, well-wishers, and industry partners, Taranga stands tall because you stood behind us. Your trust, generosity have made this event a landmark in our journey. To every participant, the researchers, the delegates who travel from near and far to be the part of Taranga, you have not just attended a conference, you have become a part of your story. And finally, most powerfully, to our InCerS family, to every student who gave their nights, their weekends, their energy, and their passion to bring Taranga to life, you are the reason this chapter is the best chapter of India.
We are the InCerS Student Chapter of GCECT. We are not defined by numbers. We are defined by what we build, what we lead, what we leave behind for those who come after us.
A student with fire in their heart and the courage to lead, they will change the world. And it is the second kind of student the InCerS grows, nurtures, and sends forth in the nation. From the first clay pot of the most advanced aerospace ceramics, we understand better than anyone that the most things are shaped under pressure, heat and time just like us. The strongest steel is forced in the hottest fire. Taranga has been that fire and we have emerged stronger.
Thank you,
Thank you
on the entire GCECT family for being a part of the extraordinary wave.
Joy Hind, Joy GCECT, Joy InCerS.
Thank you so much, Shubhankar and Pijusda. With this, we come to the end of the inaugural session. Now we will be moving on to the high tea. We invite everyone, the delegates, to stay in the ground floor while the students will be going to the first floor. So we will join back shortly in a while. Thank you. Segments of TARANGA' 2026 are technical sessions where knowledge meets experience and ideas transform into inspiration.
We begin with a speaker who hardly needs an introduction. Currently serving as Director Innovation and Technology Asia Pacific at Calderys, Dr. Soumen Sinha sir has made a remarkable contribution in the field of refractory technology, research and innovation through his extensive experience and leadership. It is our privilege to have him with us today for the keynote lecture on steel plant refractories. Please join me in extending a warm welcome to sir with a huge round of applause.
My sincere apology, I could not make dedicated presentation for today's session. What I try to do is basically collating few slides which were there with me, and I think this will give us some platform to interact, and it will be good that if you want to interrupt anytime, you can interrupt and then you can ask question. So from refractory perspective, because from 1991 until today, so basically my background is I have worked in refractory throughout, and so initially I was there in quality control, bricks and monolithics, and then I went to IFGL, so there I was in technical service as well as product development, and so basically purging refractories and other things. So I had an opportunity to work closely with the steel plant, and then after from 2011 to till now I am in Calderys in R&D. So I have an opportunity to visit so many steel plants or other sectors also, cement and aluminium. But basically what I have tried to do is collect the information and try to present in front of you. And many of you may be knowing something or maybe knew something. So, I mean, you can interact, and at any point of time you can interrupt me and then ask question, because I do not want to keep it monologue, because that way it may be boring. Okay. So there is some time limit. So I mean, we can cover a few slides, but most importantly, if we can have a forum of discussion, maybe now or maybe after, that is also okay. Now, whatever experience I have, what I understand basically, is basically we need to understand the process, because refractory is a product or a solution. We are there in all sectors: steel, iron, aluminium, cement, petrochemical, power. All these sectors we are supplying our solution. I am calling it solution, meaning it's not only product. Okay, maybe you will be appreciating that now people are talking about solution. They will have some challenge. We need to give some solution to overcome that challenge, or maybe to mitigate that challenge. Now, so until unless, as a refractory technologist, that is my personal opinion. I mean, you may differ also. What I have learned that we need to understand the process, because if we cannot appreciate the process or maybe understand the process, then it will be difficult to work for a solution. Okay. So I would try to present in that perspective only. Steel plant refractories, different equipments. It will be difficult to cover all the sectors, maybe 45 minutes or maybe 1 hour. But then I will try to touch the basic process there, and maybe there are some challenges and how refractory we are trying to overcome the challenges. Okay. So if you see, there will be primary steel making process, okay, then secondary steel making, and then steel ladle, and then obviously magnesia carbon. This is the brick solution, mostly predominant in the steel sectors, and some ready shape. PCPA means is precast prefired, because today's scenario again there are refractory, there are something in situ casting, meaning you we supply the product, and then the installation is done at site. Okay, but then that requires some amount of time. So customer wants some precast prefired or maybe ready shape, so that they can reduce the installation time. So something I will also discuss that related to steel plant, and some Tandis refractories, and some, because I think from the organizing committee they requested me to put something on automation and AI, but I think I will not make a justice here. Whatever information I have tried to put, but maybe other people they can give you better information about this one, who is dedicatedly worked in the service line. Okay, but then I have few slides I will try to touch there. Now first slide, if you see, there we have tried to give you a brief overview. These are different route of steel production. Okay, and today's scenario, carbon footprint is very important. So if we see this, basically the remelting shop, that is your scrap remelting in EAF, there we have minimum carbon effect on the environment, because you are taking the scrap and only arcing and melting and then doing the recasting with some treatment or some alloy treatment. Okay, so this is a remelting shop, and where it is totally dependent on the scrap. But India, as we have steel consumption may not be that high, so our per capita steel consumption is not that level like Europe and other countries. So maybe this kind of scenario may not be very popular, or may not be very frequently available, or very often we cannot see this thing. So this is the most least environmental effect steel route of production. And this is the most critical thing, and mostly if we see, some of the maybe 40% of our Indian steel production is basically this route. DRI, maybe some of you have visited, that is a direct reduced iron making process, where you have a rotary kiln, and India we do the coal fired direct reduced iron making, and also gas. So this is for coal based. And in Africa also we have this kind of route, where we have coal based DRI, we have a rotary kiln, and we make the DRI, that is basically 91-92% Fe, and we have lot of impurities also, be it form of.
Is this the sponge iron production by DRI?
Yeah, we call it as a sponge iron because of spongy nature of the iron, and because but then this this liberates lot of carbon dioxide in the system because of coal burning. No, induction furnace, I could not find. But
that DRI route is to induction furnace also, or only return?
Yeah, the induction furnace route is different. DRI is different. DRI is different. So then second is, this is the most popular route in India, and mostly integrated plant we have this one, blast furnace and converter, that is basic oxygen furnace there. So this is the most popular route, integrated furnace, we are following this one. Third one is DRI, again with gas. So here we have ArcelorMittal, and we have JSPL Angul also, they have mixed gas or syngas. So this is that route of production. Here as we are eliminating coal, so we have a carbon footprint, lower amount of carbon footprint there, right? And this is having natural gas, this is syngas, so this is for JSPL Angul, and then BOF. So this is even lower thing, and then this is having your natural gas based one, and then electric arc furnace route, that is the EAF one, even lower 1.6. So just to give you a glimpse of this thing, but then having said that, but if you see the 2030 projection also, there also India will have this route of production is the majority one, BF and BF, because 60% will be in this route, and all the big players, be it JSW, be it Tata Steel, and other players, they are coming in this route only, though they are trying to put some hydrogen in the BF system. That is a research, and then Tata Steel, they have done something, ArcelorMittal, they have done. So that is a question of research. So if I then go, this is your iron making, here the blast furnace, okay, and pig iron, it is we are generating, and then finally it is being put in basic oxygen furnace. If you have to put the scrap in the system, then it will be routed through electric arc furnace, where we are doing the 3-phase arcing, and then finally the ladle, that is the steel ladle we are talking about, and then finally all this process, and then finally the casting, different shape. If you have a long products or flat products, depending upon your final output, rods, bars, sections, whatever final shape, accordingly chemistry and shape of the ingots or this thing will be changed. Okay, semi-finished products, blooms, billets, different. This is this again specific to a caster. If caster is designed for blooms, then it will be manufacturing blooms only, like Relive BSP, SMS2, that is the blooms, and billet, if the caster is designed for billets, like Tata Steel LD1 is a billet caster, and so this is also, it will produce billets through and through. And slab, this is the most I think popular, and lot of slab caster is there in India, thin slab and this thing, Tata Steel LD2, LD3, all those are the slab caster. Now if I see the process here, so electric arc furnace, that is one thing already we have discussed, that is electric oxygen furnace there, EOF, okay, Konark furnace. These are all the equipments which normally in the steel melting shop we do come across. AOD is specifically for the stainless steel. In our alloy steel plant also AOD is there, and then steel ladles, vacuum degasser. This will come in case of your other beneficiation, secondary steel making, it will come. Okay, and this is for sulfur reduction and the tundis and lances. So now this is little bit busy slide, where again I have put different route of production. So more or less we have discussed, and this is the different chemistry, carbon percentage, because less than 2% normally we talk about steel. Okay, so where the mostly popular, that is the automotive grade, that is the interstitial free steel, that is the lower ultra low carbon steel, that is the most critical one. Okay, and then we have mild steel, different carbon level, and then finally alloy steel, where we have different ingredients, chromium, nickel, molybdenum, these are the things are put, and then some of the higher carbon containing steel also, tool steel, that is for the wear resistance thing. Okay. Now if I see the process, the primary steel making process, here what we are doing, because pig iron we are taking with a higher carbon, so first step in the primary steel making will be decarbonization, meaning we have to reduce the carbon to keep it, bring it to the steel level. Okay. Dephosphorylation, India now we have lot of impurities in the form of phosphorus also. So phosphorylation, phosphorus level also we need to reduce. So this is basically dephosphorylation. And then silicon, this is also one gauge material we need to control there. So that is, these are all being done in primary steel making unit, be it BOF, EAF, UAF and Konark. Secondary steel making, if you see, because this carbon reduction obviously will bring some amount of oxygen in the system. So secondary steel making will start from the deoxidation. We need to reduce the oxygen level, then oxygen ppm. Then some bit of decarbonization, sometimes it being done in RH also. Degassing, this is the major role. We need to remove the inclusions or whatever the gaseous bubbles there, we need to minimize this thing. So this is one role of secondary steel making. And then control of liquid steel temperature, because all this casting, this will have a specific temperature where you can cast. So we need to maintain that temperature, because normally they maintain, we call it a superheat, maybe 10, 15 degree or 20 degree. Above that casting temperature, they make the melt temperature, final steel melt temperature, so that it can be cast easily, because that entire little quantity, maybe 150 ton, maybe 300 ton, that need to be cast. And so we need to maintain some superheat there. As a metallurgist, they maintain that thing. And then homogeneous composition, because this is a continuous process. So homogeneity also is one of the criteria for the secondary steel making. And here we have ladle furnace, vacuum degassing, vacuum arc degassing, and this is vacuum oxygen degassing, RH, and then inert gas purging. These are all the routes where we can do that. Okay. So I'll skip because I think BF already we have discussed. This is basically converter. Here we put around lime and other things to reduce this one, and then we put some gaseous oxygen purging there. We use some hot metal from the blast furnace, and then steel scrap, and then some flux, lime, dolomite, this thing, and oxygen. These are the inputs, and then finally charging, blowing, and then sample is taken, and then slag. First of all, we remove the metal, and then we take out the slag there. And as we are mentioning, around 60% in this route of production is there. So here more or less the same thing. Basically, we use lot of lime here. So the important thing is high lance operation, that is oxygen lance. They are purging the oxygen, and a lot of CO formation there. And then high lance operation is continued, and then finally FEO is required because that will help lime dissolution, and that will improve your slag formation. That is required. So in the converter, normally they they do these things, CO, and then finally FEO formation, and then that thing they for a lime stabilization, and then finally this FEO also reduced to molten iron. So that is the thing mostly in the converter we do. And if you see the different oxide level, because one is carbon reduction, and second is as you go on the treatment evaluation time, that basically lime content marginally, it increases. Rest of the things more or less it is within control, and all these reactions normally proceed as per the Elecgram diagram, which you know that about the Gibbs free energy, and this is the trigger behind the reactivity of all the elements to finally oxides. And if you see the slag, this is more or less the slag chemistry, and then from plant to plant it may vary, and we will talk about basicity and other things. And if we have a converter temperature normally around 1700, but then for silicon steel maybe sometimes it even go up to 17, 20, 30 like JSW and other places. So now here what is the challenge? We have, as we have seen the process, so we are doing some oxygen blowing, we are putting some scrap, we are putting hot metal, and then lime and other things in the system. Okay. So one is that major thing is that is a corrosion, because oxygen we are putting, lime is getting generated, so we need to work on the corrosion resistance of the material. And if you see that basicity, what we have shown in the previous slide, so basicity meaning, simple term it is lime by silica, but then we have other definitions also, but it is more than 1, 36 by 37 more than 1. So that means it is marginally higher, more than 1. So compatibility of the refractories is magnesia carbon. Normally they prefer for the magnesia carbon bricks, and that magnesia carbon here also, why it is required? Because carbon improves the spalling behavior, and carbon also as a very critical topic. So, we are talking about carbon, but it may be carbon black, it may be graphite, there may be several form of carbon, but for this purpose normally we use some flaky graphite, because that is the most high quality graphite, maybe purity around say 95-96% purity level graphite, to improve the corrosion resistance property of the brick, and that improve your spalling behavior, because magnesia as it has a higher amount of thermal expansion. So that if we give carbon, then conductivity improves, so that improves the spalling behavior, thermal spalling behavior, as well as the corrosion behavior. Here also looking at different locations, the challenges are different. If we talk about the bottom portion, okay, so there bottom zone and bottom cone, this area, okay, so bottom cone and bottom zone, this portion, we need to have impact resistance, because we are putting scrap, okay, and then so that has some impact, because if overhead crane we are putting some scrap. So bricks need to have good impact resistance property. Okay. So how to improve that impact? We need to optimize the carbon there. See, simple theory is we need to improve the strength, we need to optimize the carbon content, and then we need to improve the spalling behavior also. But if you see the slag zone, okay, their corrosion is more important. So we need to have magnesia also. If you per se, if you see in literature, you have three forms of broader category of magnesia. One is your normal dead band magnesia, that is magnesite, calcined or rotary clean, and then at a higher temperature, maybe 1800 or so or plus, that is your dead band magnesia. And then second quality is that magnesia from seawater also, that you have seen that seawater magnesia, that is also sintered at a higher temperature. But for this purpose, for converter bricks, normally people prefer, that is basically fused magnesia. There is a third category of magnesia. Fused magnesia also you will have different purity. Okay, it may be starting from 95, but then it even go up to 98. Okay, if you can pay more cost, then we can have good quality magnesite with a higher crystal size. That is normally higher crystal size mean it is less your reactivity, it is more inert. So those kind of properties also normally we look into, and converter bricks are basically most critical bricks as far as the slag zone is concerned. Better corrosion resistance, and we use normally higher quality flake graphite, and then we use higher quality fused magnesite, some part of it, and then but then in the bottom we need to have a different thing, because fused magnesia, it is a good crystal structure. We have gain bound, distribution of impurities. If you see microstructure, it will be controlled gain boundary distribution. But then the challenge is, if you have a thermal spalling because of bigger crystal, then it has a challenge. So in case of say where we have a thermal spalling more, there maybe we need to optimize with some dead band magnesia, and that way refractory technologies blending the things and then do the thing. So this is, so that's what I am telling again and again. That is my learning till now. We need to understand the process, because a single solution will not work in refractory for all the things. Okay, we need to, and this converter also, maybe one steel plant they have one behavior, other steel plant that is another behavior. Their slag basicity may be more. So if the slag basicity is more, then it is friendly. I will discuss also, if time permits, the different nature of the slag, and then how we can treat the slag, because slag is our good friend. That way we will look from the refractory perspective also. If you have aggressive slag, then we need to work in a different manner. Okay. Yes.
How this scrap is loaded inside the furnace?
That is basically top. From top, they put the crane and then dump. Simply dump. Simply dump.
So if there are sharp corners of the scrap,
that can yeah, that can be. So normally it is preferred that we need to have some, we call it a what is they call is a basically residual metal and slag in the converter, so that acts as a cushioning, and that also helps. We call it a that helps for your early slag formation, early melting also, because that
from the last branch.
Yeah, so that will give you better. No, that is for your process, metal and slag.
That portion bricks are magnesia carbon?
Yes, all these magnesia carbon. And then top portion, this was, you have lower quality magnesite, and then we can optimize the carbon also. And so that is easy. But then most critical is this one. And normally in converter, they go for a slag splashing also, because once your initially slag, they will dump, and then basically the metal will come, then residual slag they will dump in other direction. And
any idea about the size? Rough idea about the size of the
converter? It depends upon your plant, because basically if you see your ladle size, if it is around 150 tons, so it will be 150 tons around, because mostly India we have converted up around 100 to 150 tons. But in Bokaro, we have a bigger converter also, around 250 or 300 tons also, there is a bigger converter. So India maybe 300 is the maximum one, and then maybe minimum 100, 150 tons this way, because it should be again compatible with the downstream also. Okay. So just I am trying to touch upon. So if we see the different route of primary steel making, what we have discussed, BOF, Konark, EOF and EAF. So if we discuss this thing, BOF already we have mentioned. So we are doing some oxygen lancing. So it is a reaction, is the chemical one. And then we do not have any electrodes, and everything we have discussed. That is your carbon dioxide formation, and then it is OPEX is obviously low, meaning we need to have a high capex to install a converter, but then once it is done, then OPEX is regular cost maybe minimum here, and then steel grade suitability, so any carbon grade we can use, and scrap we can use up to 30%. And similarly, if we see in the different route, Konark route, that is there in ArcelorMittal, there we have electrical as well as chemical, because we have electrodes for arcing as well as we have some supersonic oxygen lamps, the oxygen purging, okay. And then so as we go, so this will be the thing, and then here we can increase the scrap also, since we have both the things, we have electrodes, and because oxygen, I mean this, if you have to increase that scrap percentage, we need to have some arcing there, so electrodes is there. EOF, energy optimizing furnace, so this is only oxygen blow through the tires, and India, this is your Jairaj Ispat, and then SLR, south side there are few plants where they have EOF only, where they have this oxygen blowing through the tires, and then here we can use 30 to 50% scrap as well as some amount of DRI, some amount of hot metal also. Arc furnace, mostly you will see this arc furnace here, and there also in some of the arc furnace, as you have seen, totally you can melt the scrap. So again, looking from refractory perspective, so BOF we have discussed that your corrosion resistance, and then in the slag area we need to have a higher quality magnesia carbon, and the bigs, I mean the bricks are also bigger, maybe 800 millimeter length and something like that, bigger bricks. So we need to have a press, maybe say 1600 ton, and I have seen in US also they go for a 2000 tons of hydraulic press, pressing single cavity mode. Single cavity meaning one brick at a time you can press. So that's the thing for BAF. But then EAF, that will not call for that I mean length of bricks, because EAF lining thickness also will be less compared to BOF. Okay, EOF is mostly EOF India. We have normally seen around 60 tons, 50 to 60 tons, smaller size. And Konark furnace, it is around 100 ton this furnace. So brick dimension and other things also will vary. And EAF, of course, corrosion behavior and other things are same, but then EAF we have basicity more than normally in the BOF case. So here refractory, I mean life or performance should be better compared to BOF if the same quality if we supply here. So different process, different steel chemistry. And then I will not touch here details, because already EAF, just a picture you can see three phase electrode we have shown. And then if I see UAF, there is no electrodes, only the towers, there is some oxygen purging there. So there is the scenario. And this is for the Konark, it is basically the single phase portion, and then that is the Konark furnace there. And so charging, melting and refining, these are the things normally in the primary steel making we are talking about. And if I go to little bit on the EAF side, here we have scrap and DRI, both the things, okay. And charge mix density, and then hot hill. This is the hot hill, residual metal and slag, what I was talking about, hot hill volume. And so if I see there EAF, we have recycled scrap, DRI and pig iron, some bit of BF liquid, and we put some lime and dolo. And alloys we can give different thing, like ferrosilicon, we can give silicomanganese, we can give aluminium bar, just to aggravate the slag formation and make it purer. I will not go details because it's a heavy slide. And so basically essence is that if we do EAF, we need to have a arcing, and then sometimes if required they should do some oxygen lancing also there. And initially we need melt the scrap, and also in presence of some hot metal and DRI, all those things. And then slag, if you see, sometimes they go for a double slag process also, meaning first time they will put some, and what is the definition of the oxidizing slag? Because that slag will have some capacity to oxidize the thing. So it normally FeO, this kind of MNO, these are the if they are present in the slag as an ingredient, these are the oxidizing slag, because FeO will go to Fe2O3 and then finally go into the slag. So this is the oxidizing slag normally, and then we do the normal first time, we put some material and then prepare the slag, we drain the slag, then second time also we put some addition, and then we did the double stage, this slagging process. And then so dephosphorylation, sometimes it is done in case of your, it may be in converter also, it may be sometimes they would do it in the electric arc furnace also. There in your lime, it absorbs phosphorus because of phosphorus oxide and lime other nature of the thing, and then phosphate formation takes place, and this actually requires lower temperature in oxidizing condition. And another impurity is the sulfur, which requires reducing slag, and then is a high temperature. So this situation is little different, dephosphorylation and desulfurization, though these two are equally important for your final steel chemistry. And if I see this oxidation reaction, so these are the oxidation reactions. So if I see the EAF treatment, there are oxidation reactions, then slag forming reactions, and then your third one is the reduction reactions, final thing. So first is oxidation. So carbon, it will oxidize because we will be doing some oxygen purging, oxidize to carbon monoxide. Same silicon, we are putting silicon, manganese, Fe. I mean these we put as a ingredients, or maybe in case of some alloys we can put that thing, and finally it will oxidize, and then it will form some amount of slag in presence of calcium oxide. So that is in the slag forming reaction, second stage. And finally reduction, that is for metal, that basically FeO will conform into Fe, and finally your FeO also will reduce to Fe. So this is the process normally in EAF. And again if we see here the basicity of the slag, that is a calcium silica ratio, and it is basic in nature. So here also the EAF normally magnesia carbon, this is normally we use in case of electric arc furnace there. Hot hill already we have talked about, basically residual metal and slag to improve your this one. And then if I see the EAF lining for refractory per se, this has also different zone. Hot zone meaning it is near to the electrode, so it is a high temperature area. Okay, so we need to have a critical like fused magnesia, FM meaning fused magnesia, we have 97% more purity, and then we have more carbon, and this carbon is essentially graphite. Slag door, so there also it is premium of standard quality. The slag door meaning this is the slag zone and slag door through which your slag is getting discharged after the arcing, then melt formation, then slag discharge, and then metal discharge, and then residually you have some slag there, always that will be some residual slag. So looking at the location, we have different quality of magnesia carbon and different content of carbon content in the bricks that is required for this kind of operation. Okay. So if we understand the process, then only we can visualize, and then we can work out what will be the final property of the bricks and other things. So this is the different type of lining there, magnesia carbon, and there are two kind of tapping here. One is eccentric tapping through bottom hole, and then another one is a sideward through the spout. So this is basically two kind of metal draining system from the electric arc furnace. Here also the challenge, if we have a more DRI, direct reduced iron, as Professor Sen was mentioning about, that is a sponge iron. Now the sponge iron is easy to make because we have lot of sponge iron clean, but then the challenge is it has Fe content around 91% maximum. Rest are basically silica, SiO, maybe some bit of FeO. So those kind of oxides will be remaining there. Okay. So that actually is creating a challenge for refractory. If we see simply from the slide, the meaning is, if we have a scrap melting shop, there if we have a total refractory consumption, so this is annual average specific refractory consumption figure scrap recharge. So this is scrap melting electric arc furnace. Your specific refractory consumption is 1.38, meaning 1.38 kg of refractory per ton of steel production. Okay. But if I produce with the DRI, then the consumption increases because of more wear, or maybe the gauge material, or whatever the impurities we already discussed. So to take care of those things, obviously it has an impact on the magnesia carbon brick also. So accordingly, we need to use more high quality magnesia carbon for in case of if you are dealing with this kind of scenario. Now this another thing is that normally in case of this electric arc furnace, normal refractory life, in between they do some repair, because what will happen? Because normally what is the phenomenon here? Because every melt is has some saturation limit with respect to one oxide. Suppose a melt, as chemistry we have shown, maybe magnesia is having say 1 or 2%, maybe magnesium oxide, but then magnesium oxide, that melt can take more. It has a, depending upon the chemistry, we can theoretically calculate up to what level of magnesium oxide it can be dissolved in that melt. So we call it a saturation limit. In the thermodynamic tool, we do it with fact stage. So in the same chemistry, we can work out that if we play around theoretically, suppose magnesia, we go on adding, replacing, suppose keeping the basicity same, replacing your, overall lime silica if you reduce, keeping the basicity same, put magnesia, what is the saturation limit in the slag, okay? That actually triggers all this corrosion phenomenon, because steel is very, slag is very aggressive, it will be saturated. And how it will saturate? It will take the saturation meaning with respect to the, say in our case magnesia carbon we are lining, it is in contact with the slag, okay? So it will take magnesia from the bricks and then it will gradually dissolve and then saturate it with respect to magnesia. Till it is saturated, then after saturation is done, then your dissolution will be minimized. But before that, there will be continuous dissolution, you will have lot of aggression there. And here one thing normally in the electric arc furnace we do use, and the steel plant they also follow, that normally they go for a gunning in the different location in the wall and other things, they do for a gunning. This is basically magnesite containing gunning material. There are some different bond system there, and then this can be done manually or even with the shooter. That is the automatic thing we can do. We can evaluate the lining condition with some scanner, and then we can do some repair. And what will happen, that it will act as a sacrificing layer, that when you will have a corrosion, then that gunning layer will be dissolved in the slag melt, keeping your brick at the back surface intact. That will increase the brick life, okay? So this kind of repair, semi-automatic machine or shooter machine, it is more predominant, and essentially here we do not use any carbon here. It is basically magnesite system, and here the essence is little different. Here we need to have a material which will be easily sintered to your lining phase. So we need to go for a higher sintering material as well as with a controlled corrosion. So that is one kind of material. So this is the sum of the video, I will skip. So this is another thing, gunning they do in the side wall, but in the bottom we have some kind of, we call it a dry vibrating mass. Okay, dry vibrating mass means there is a monolithic material, okay? In the dry form we can install, and normally we put it in the hearth or maybe in the bank portion. Bank meaning where your vertical wall is meeting your horizontal wall. That area, then that is basically the direction change, and that is the most critical area for corrosion, because metal and slag, it try to penetrate into there. So there, as a protective thing, we put this kind of DBM. DBM basically it is a dry vibrating mass. So here it is a dry mass. It may be magnesite dolomite based one, okay, and then it may be magnesite also, but essentially we need to have some amount of iron there, because then iron will give either oosterite, that is magnesia iron MgO FeO formation, or if I have dolomite, then we have calcium ferrite or calcium diferrite formation. That will give you some surface sintering, and that will give initial mechanical or impact resistance of the mass, and that will be sacrificing layer. So maybe once, maybe after say few hits, they will put the DBM, dry vibrating mass, and then the lining will be intact. They will take the lining may go up to say 800 hits, but in between it may be 2-3 times we need to put this DBM to protect the hearth. We call it a sacrificing layer to protect the hearth, okay. And here also there may be two kind of operation. One is the electric arc furnace, it is drained, it is little cooled, and then we have a cold operation.
And there may be another thing, that there is some residual metal and slag, but you need to put it, repair it then and there. We need to have a hot application also. So hot application we call is a fettling, and cold application is called normally DBM application. And there are customer like ArcelorMittal, they want a material which will perform in both scenario, hot and cold, both the things. So there we need to adjust your sintering behavior of the mass so that it can withstand. If they want to have a cold operation, same product they will be using. If they want to have a hot operation, same product it should perform. So that's what I am again and again telling, that understand the customer philosophy, what process demands, and accordingly we need to have some amount of understanding what actually we need to work upon and then develop the solution. This is dry because it has a cold and hot, both the things, okay. And previous slide I have talked about basic gunning, okay. This is basically water system. So anyone can answer, because till now I think it is monologue already, I think 40 minutes. So why basic, if you have a magnesite system in presence of water, what is expected? What is expected? What kind of compound formation you can expect? Yes. Yes. So magnesium hydroxide, yeah, so it is basically, we call it brucite. That is the phase, okay. Now, brucite is not stable beyond 380. If you see the thermogravimetric analysis of brucite, it will go away, okay. So here you can use water, because all these furnaces, when we do the gunning, the application temperature will be say 900, 1000 and so, okay. So here the brucite will not be stable, but if you go for a magnesite in cold application, then we have cases where you have lot of cracking due to the brucite formation, and we need to take precaution, different kind of bond system and other things we talk about, okay. So I already mentioned this one, DBM and different kind of mechanism. And again, secondary steel making, if I go, so secondary steel making, primary steel making already we have discussed. So any question on primary steel making? Any impact or no? I am just speaking to the wall. Any impact? Any question? I will have to answer so that it is a discussion, otherwise it is a monologue. Was it helpful or, yes sir?
You are talking about the refractory and slag mostly, but the steel itself in the molten condition is there inside the chamber. So is there any reaction with the steel between the refractory material and the steel, or the slag is the major cause of concern?
Slag is the major area of concern, because out there may be your metal slag interface, because any three-phase interaction is the most critical. So metal slag, the transition zone, that is the most critical area. And it is a very good question, sir. Normally what we do in laboratory condition, we can do some simulative study either by induction furnace. You can take metal slag, induction furnace by eddy current, we can melt and see the wear in the refractories. We have that kind of thing. We have rotary drum test also, where we have rotary kind of equipment lined with the refractory metal and slag. We have crucible test, simple laboratory, we make the crucible and do the things. And thermodynamically also now we can use fact stage. That is very useful tool. And from metallurgy side, we do lot of calculation where we consider metal slag and refractory combination. So maybe 70% refractory, 9% maybe, if it is a slag rich environment, we will take say 9% as a metal, 21% maybe slag. All these three oxides, okay, will interact. We have a same thermodynamic tool, and then we do the interaction at different temperature. That is called fact stage, and then through that we try to visualize that what will be the liquid formation, that is the slag formation. Not only that, what will be the slag chemistry, and more so is the viscosity. Because aggressive nature of the slag depends upon is the type of melt which is forming. If it is thicker, or maybe viscosity is more, less aggressive, okay. But if it is more fluid, like FUO enrich and other things where we have a more fluid, then it's more aggressive. So that way also we can now visualize and then do the things.
Is there one thing that is it
Yes.
So that if it forms a obtuse angle,
Yes.
then it's less tendency
Yes,
to
yes,
corrosion.
yes. Basically, idea of putting magal spinel is that only. In your secondary steel making, we normally what we do, because in primary steel making, we are going with this magnesia carbon only. But secondary steel making, some of the portion like purging plug, okay, where we cannot use carbon, and without carbon, magnesia is also difficult with spalling. There we go for a alumina space system. There we go for a alumina spinel. And as you are telling, with the alumina spinel, your contact angle we can make it around 110, and alumina it will be less than 90. So there we can improve the contact angle. Another thing also, in this kind of scenario also, we can put some synthetic slag. Knowing fully well this is the process generation, we cannot do. But if we can add something, okay, and after doing the calculation, suppose this is the thing is going to be generated, if we add something synthetic slag like calcium aluminate, okay, some calcium aluminate silicate, and then collectively all those things will have a basicity, and then that will be friendly to our refractory. So that way I think we can do, and then it is possible.
This is the contact angle part. And another way, when particularly the refractory formation, the dihedral angle part also play a important role in forming the liquids at the corners of the grains or will penetrate. So that will be the refractory part. So we have a product which is the dihedral angle, that those value, ratio of the dihedral angles, those things, the normal energies should be more than 120 degrees. So they will form only liquids.
Limited infiltration or limited foothold that way, and also surface tension, that is also important due to the capillary action. Refractory also have some lot of pores that brings capillary into the system. So, and there you can have pore size and other things, other dimension. Okay, so I don't know whether it is impactful or it is no impact. So okay, moving ahead. So steel. So steel, basically secondary steel making, if you see, again we are giving some, I mean here you have to remove the oxygen, because enough oxygen we have done in case of converter, UF, other places. So now we have to control that oxygen. So we need to give some amount of deoxidation reagents. Okay. So your metal power, normally metal we put calcium, aluminium, or maybe silicon, manganese. So these are different I mean this condition, so that you can react with oxygen and reduce the oxygen in the steel material. Desulfurization, this is also very much important, because sulfur actually it is poison to the steel, and today's scenario, high quality steel, we need to control the sulfur. And in like Tata Steel, they have desulfurization station only. Okay, they put some lamps, or in JSW they reduce the sulfur by using care impeller. That is also another way of reducing the sulfur. And each and every process you have certain amount of requirement. Like desulfurization, they will use some amount of reactants. Magnesium is good, because magnesium oxide, magnesium sulfide it can form, but magnesium sulfide again it takes oxygen and then liberates sulfur. So to stabilize magnesium sulfide also we need to have some lime in the system. So normally they go in combination, either they go calcium carbide, magnesium as the ingredient for desulfurization, or they put some lime or magnesium as a desulfurization compound. And essentially this reaction is important. This is basically this is calcium sulfide formation, and then that way we can reduce the sulfur in the system. And by tools what they use is basically desulfurization lamps or maybe the care impeller. Decarbonization, already some part we have talked about. Degassing is also one important thing, because all these VAD vacuum, why we are giving this vacuum? Basically to liberate the gas as per this Siebert equation, that if we can reduce the partial pressure, then entrapped gases will be liberated. So this philosophy we are using there in this process. And that vacuum level also, I think it has a challenge on the magnesia carbon, because again carbon also form carbon monoxide and then it can go away. So their corrosion is also more. In case of VL, the whoever the visit steel plant, they have this information, and then in your contractual process also they define that if you have VD hits, this many amount, then this will be the performance warranty. No, VD actually it is a chamber. We are putting the ladle, so abuse is happening in the ladle only, ladle refractories only, and top of it there is a cover, there is a VD cover, okay. That is produced with some ultra low cement based castable, and then that more or less, I mean, if there is any slag splashing, then only it will come in contact with metal and slag. Otherwise, more or less, it is more or less okay. I mean, that is not, I mean, it's not a huge challenge. As far as the lining is concerned, hot metal and slag, that is the most critical thing. So purging, I will not discuss much here, because here bottom purging I am talking about. Here if you see, there are different kind of purge plug just to remove the inclusions, and then so we do it with argon or sometimes with nitrogen also. And here the smaller the bubbles and then maximum number of bubbles, then it is effective purging with respect to your inclusions removal. And there is the equation normally we follow. This is the equation where if you have different Reynolds number and then inclusion concentration, number of bubbles, so all these things are interrelated. That is your critical entrapment radius, because there is some size up to which the inclusions can float, above which mostly it will be entrapped in the slag. So that is the normal thumb rule normally we follow in case of this purging theory, purging theory. And so I will not go here details, because here what I was talking about, normally 25 micron and were predicted to mainly remove to the slag, and then that is the larger than 25, mostly entrapped in the slag, and then our role of purging is just to float this size or maybe to make the agglomerate, so that is from a bigger size, and then finally it can absorb in the slag. And coming back to Rituda's question, so this is the different station, VD, VOD, and ladle is same, and this is for your RH. Ladle is same refractory, and RH case actually we are putting some suction there and then vacuum, and sometimes this is your alloy chute, we are putting some alloy element there, and then there, I mean, there just there is a suction and hot metal or steel, it is going upside and then finally it is coming through this one. So this circulation is there, and then RH basically they use to reduce hydrogen, nitrogen, those kind of gaseous ppm, because now we are in the purer form of steel. Okay, here RH normally they use magnesia chrome, this kind of thing, and here also if you see that criticality is different. The snorkel part, it is the most critical one, bottom one, where we have a to have a more corrosion resistance material, that is basically reaction bonded or maybe rebonded magnesia chrome we talk about, where we start with a magnesia chrome, ferrochrome, that is with around 16% or maybe 20% chrome level. Additionally, we dose chromium oxide and we use some amount of magnesia there also. No, chromium toxic, but then we need to have some disposal, because hexavalent or that level is toxic. As you are using, it is basically trivalent, because Cr2O3. But then disposal, we need to be very much cautious. So that is there, but then in China, they have already using majority max spinel there. So they have come out of, but then performance is not similar your macrome. But then okay, if environment is there like Europe and other places, chrome ban, so we need to have max spinel, alternate solution. Okay. And but if we go to the lower vessel, again the criticality is there because it is in contact with molten slag and metal. But in upper vessel, I mean severity is less, so we can have even some compromised quality there also, like direct bonded magnesia chrome, it can work there. And coming to this chamber, VD and this thing, ladle is the most critical area where again magnesia carbon normally they use, but then normally cover we use some ultra low cement castable. Depending upon the criticality, we can even use some spinel based material also there. So this is the ladle furnace. Here basically we normal treatment is there, and this is your ladle bottom purging. So this is the purge plug and other things. Okay, so I think I should close with the secondary steel making only. And so this is the different route of secondary steel making. And if I see, mostly we have discussed deoxidation, desulfurization, carbonization and degassing and other things. And And so this is the induction furnace or injection metallurgy. So this is not so predominant. This mostly we work in these 5 areas only. So more or less. Alumina spinel brick they use in case of ladle, steel ladle, metal zone, because that is also required, because alumina spinel if we use, because ultra low carbon steel, aluminum kill steel, where we can use aluminum kill steel, actually you have less severe because your magnesia saturation limit is also lower. Their metal zone like Tata Steel, some part of JSW, they are using alumina spinel brick in the metal zone and some part of bottom also. Bottom sometimes they use. No, castable also is being used, like in POSCO. POSCO, I have seen we are supplying also in China. We used to supply 100-ton ladle. Your slag zone was with magnesia carbon, and your metal and bottom was with magnesia alumina spinel castable. But then essentially it is a spinel forming one, because spinel castable also you can have two kind, either spinel bearing or forming. But here corrosion is more important and your thermal expansion. So that way spinel forming normally we use for steel ladle. In situ formation of the spinel, and then that is metal, and the bottom part we use spinel forming castable. But then slag zone, still now we use magnesia carbon bricks only. Though we have a product with the magnesia carbon, in fact, we have a patent also, and I worked in that project also. Magnesia carbon castable without water. So we developed the thing with resin, but then we could not commercialize it. But there is a patent on it, slag zone. So that is the thing. Okay, so. So RH degasser already I have talked about. I will not go to detail. AOD is basically for the chromium or maybe the stainless steel thing. Here you have limited oxygen of chromium, so we put some argon and oxygen, and then you can see in ASP also there. And then this is something interesting. Maybe you will be finding India only one place, that is your CASOB. CASOB meaning it is composition adjustment by sealed argon bubbling. So what they do basically, this is the CASOB chamber. In the ladle again it will come, and then this chamber will come down, okay. And then there is oxygen purging here, and then they put aluminium also, metal, that will actually create the exothermic thing, because aluminium it will be more reactive, and then oxidation will give you liberate lot of energy. And so it is a unique process where they can increase the temperature, okay, and then they will put some alloying element there. And they have a bottom purging system also in the ladle. So that will be there. But if it fails, there is another kind of lance also. We call it a J lance. So this J lance, we can put argon through this J lance also. Okay. And this is a system where we can use, chemical heating as well as other things, oxygen purging, all those things is there. And this is basically a chemical way increasing the temperature. And then after that they can, if it is purging is there, after that they can put it in caster. So this is Tata KPO, they have a unique process of CASOB there. We have some simulation that can be also done. This is also interesting in today's world, because all this monolithic part, the previous slide I have shown, this is basically, I have shown this unit, okay. This is basically is a monolithic, is a castable, as you are talking about alumina spinel castable only. But then since it will be in a hanging condition, there is some reinforcement. So what they do, normally this kind of reinforcement is there. We have some metal reinforcement is there, okay. So now, as maybe Professor you will be knowing, maybe mechanical engineering, you have a lot of ANSYS or simulation study. So refractory, this also being studied now, where there is a refractory and metal combination, hybrid system. There, what will be the stress? Because ultimately the performance depends upon the, performance of both the entities, the metal and the slag, metal and the refractory, okay. So we can, with the ANSYS, we can do a thermomechanical simulation, that if we say if we put this thing and then to a heat, I mean temperature, then what will be your temperature at different location? Okay, red means it has a lot of stress, and then this one is more critical. And normally in the thermomechanical system, if you have some U formation there, straight edge, we have a sharp stress concentration there. We need to have some amount of blunt and this thing. So different solution we can work, and this is ANSYS software. This is a thermomechanical simulation, because I think they asked me to give some amount of insight about your automation and simulation. So these are the things normally in, I mean, refractory. This is one is ANSYS, another one is FactStage. These two are now being extensively being used to minimize your experiment, to minimize customer dissatisfaction, because previously we used to blindly supply. We used to put some plate, we used to do the casting, but it's not like that. At the high temperature, how the metal will expand, because metal expansion is more. Refractory, what will be a differential thermal expansion, and then modulus of elasticity. That is the most critical part, and then stress. So all those things we can calculate, and it is a thermomechanical system. Similarly, CFD, that is your fluid dynamic system also, normally we use for your Tundis furniture design. May not be time, may not permit, so more or less I will stop here. Maybe already 1 hour I have taken in place of 45 minutes. If you have any question, you can ask, and I mean, then we can interact also if you want. Okay.
There was one thing in your first slide, that is wear mechanism of MGO carbon bricks.
Yes. So if you,
Any pictures?
yeah, that is the wear mechanism. If you see, I have put it there. So essentially, I have talked about carbon oxidation, and also this is also interesting topic about slag, and then after that I came about your wear mechanism. So if I see here, if we see this direct oxidation, this is actually ladle preheating time. We have oxygen presence, and then our carbon may get oxidized. Okay. So if we use some mixed gas and other things, it is okay. But then 48 hours heating, normally some part of carbon, surface carbon is getting oxidized. This is one challenge. So if you have excess heating, even normally preferred is you need to have a flame which is reducing flame. So maybe that will help you to control that oxidation. We cannot avoid it, but we can minimize it. That is one. And secondly, if we see FeO, MnO, SiO, this is again, this is if we it will be there, and this indirectly, I mean, oxidize the carbon, because Fe will go into the metal. Again, electron diagram if we consider, so it will go carbon monoxide, it will go away. So again, our big carbon will be getting reduced, right? And then this is another very catastrophic reaction, self-destructive reaction. Magnesia with the carbon, this is, and then it will form a carbon monoxide and magnesium gas. So these actually, with respect to your Siebert's law, what we have mentioned, these type of reactions, that time it is more predominant. So in the VD case, in the VOD case, lining life getting deteriorated. So that is the reactions, the wear mechanism that is being followed. Now once the carbon is oxidized, then it is easy to penetrate. Your slag infiltration is just a capillary action, and then reactions with the slag. So that is the thing is happening. So primarily we need to control the oxidation, or maybe the impurity in the magnesite, what we are talking about. And dissolution. Dissolution actually it controls on the saturation limit. So here also with the FactStage we can calculate. Suppose the aluminium kills steel, where we have a magnesium saturation level, so 3.9 to 5.1. But in case of silicon kill, there we have a more magnesium saturation limit. That means more amount of magnesia it can dissolve in the slag. So that's the reason mostly like Tata Steel LD1, they go for a dolo bricks here just to address this kind of challenge. So this is the normal wear mechanism of magnesia carbon, oxidation, penetration, and then finally dissolution. So so basically I try to put one paper also, because I did not, okay, I do not have net, I cannot okay. So they are basically what they have mentioned in that paper, if we have different slag chemistry, then how the magnesia saturation limit will change. So there is a paper, a good paper, so I try to put it there. So this is the thing, sir, wire mechanism. Okay. Okay, so thank you for your understanding. Thank you.
Thank you so much, sir, for your valuable insight. I would now call upon our principal, sir, and our sir to felicitate Dr. Somin Sinha, sir.
Our HOD felicitating Dr. Somin Sinha, sir. Our next speaker is also a proud alumnus of GCECT, currently serving as Head of Marketing and Solution, RHI Magnesita India Private Limited. He possesses extensive experience in refractory solutions and product management. Please welcome Mr. Nandan Chhatra, sir, for his session on integrated solutions of refractories for steel industry.
Okay, good afternoon once again. Actually, Somenda has actually reduced my job. At least you reduced my tenure 25 minutes than the actual schedule. I will not go into more details about refractory. I mean, morning I know many people are just talking about refractory. Now, I will talk upon something which is emerging to the industry, which is integrated solutions of refractory for steel industry. So, we cannot completely eliminate refractory because that is the core area, and that is without refractory no metal can be produced. So, refractory always be in the center, and then the auxiliary as an associated service which is linked to the refractory, because when any failure analysis happen, just a second. Hello. So, if in case any failure happens, now the refractory responsible only for the 20-25% of the total cost. The rest 75%, or precisely, I mean there is no precise, approximately 60 to 70% responsible the other things. So, we will talk about what are those other things apart from the refractory. And before that, I will tell upon that how refractory industry as a whole getting paradigm shift from refractory producer come supplier to solution provider. And today it is not only for the refractory, this solution concept, because if you take up the example of any industries, it is computer, it is automobile, it is even space industries, everywhere it is solution, because nobody put focus only on the refractory. So, when refractory started, so there is an objective from both the aspect. Both the aspect means the customers or the consumer aspects, and the manufacturer and the producer aspects. So, from the consumer aspects, they expect the reliability. The product which you are buying somewhere, that has to be prudent, that has to be authentic, that has to be consistent, that has to be as per expectations. So, that is the expectation from the all user, whether steel, glass, cement, non-ferrous metals, any user industries. But from the producer point of view, also there is a requirement, there should be a non-disruptive production, so that they can fulfill the requirements of the industries. And primarily that time, approximately 40-45 years ago, used to focus on this 6 slab or 6 bullet point: the producibility, the refractory which can be produced, because many things which cannot produce, we do it through maybe precast method. You have seen many complex design in even coke oven, some of the portions, even hot Brussels main in blast furnace cannot be produced just by pressing method. Those cases we do cast either by using monolithics or by precast method. So, those cases the producibility is one of the important aspect. Then comes into productivity, because producing is not just important. So, many company produce just let us say 10 tons in a shift, but the same other company for the same product line they produced 100 tons in a shift. How do they produce? because they apply something different techniques. So, productivity is an important factor, then cost effectiveness and the quality of course and the supply reliability. So, that was the model 40 years ago for the refractory industries. Now, 20 years ago or 15-20 years ago, another model came when service model was included in the whole refractory business, that is the we call service providers, no more just refractory provider. So, that time that whole TRM and TRS concept came. I mean, the users are thinking refractory manufacturer not just for refractory, they also think for design capability, they also thought of giving or uploading their part of the jobs at site for total refractory management concept, which includes all the 4-5 points, faster delivery, so that they need to keep the bare minimum amount of stock at site, because inventory also plays a vital role for any user industry when they keep 6 months or 9 months stock. And if anyone aware of some modern science of stock management, the M. Goldratt one theory, I mean one book has written, where one of the plan in India, that is JSPLs, they run with bare minimum almost 15 days inventory stock. That is their theory, but sometimes it is not possible. So, the inventory is also an important factor that they upload to the refractory users, refractory supplier as a part of the package. So, you bring your material, you keep at stock whatever material you like, you install with your peoples, you design and just apply. So, I only look at that my all these objectivity gets reduced. Objectivity in two aspects, the cost aspects, that is the expectations from users. My refractory cost to produce part ton steel will be will be logical. It cannot be that some months we produce, let us say thousands rupees to produce 1 ton of steel, and next month we will bear 200 rupees to produce 1 ton of steel. But that inconsistencies to become a uniformity, so define a defined number, so that amount can be reduced. So, that is the cost effectiveness, and that model works perfectly at least last 10-15 years. Now, the last model which is emerging or coming slowly, maybe next 15-20 years, that model will work, that is solution model. And solution model, when I talk about, that is the add-on service, means that column 1 plus column 2 plus column 3, this all 3, it is not just alone perform the solution, the column 3. So, that expectation from the user industry is for the predictability. Now, they are saying, okay, I know you are using your resources, your engineers, your raw material, your design stuff, your everything, but still I need the predictability when where we can avoid the failure, where we can, there should be 0 failure cases, there will be no ladle puncture, there will be no hot metal leakage, because each and every failure cost at least more than 10 times of the refractory cost. So, that is the cost of the failure, and if you add on the other calculations, for that reasons, and the plant gets stuck for next 10 days or 7 days to clean it up, that will even much more expensive than the refractory cost. So, that is why now expectation from all refractory users to have the predictability on the failure, and that is why we run a campaign called failure prevention. Now, they are saying, for example, one steel ladle giving 90 hits. So, does not matter even it gives 5 plus minus, even it is 75 or 85 or 95, that is your call. But for any reasons, there should not be puncture or red spot or failure. So, by that my production gets stuck for next 2-3 days. So, that is the expectations, and along with that, everybody knows the steel and refractory is one of the I would say largest polluting industries in terms of carbon emission, So, we now focus more and more carbon decarbonizations and carbon footprint. And the carbon footprints then comes, definitely it comes to circular economy. That means you are using your all used material again in the main recipe, and this way circularity goes on, so that the carbon emissions in the atmosphere can be reduced. Then, as you also know, all the users industry runs at severe conditions, mostly more than 1400-1500 degrees Celsius, and also the nature of the operation is very critical. So, lot of safety concerns are there. Many steel plant, if you take example, every year lost 4 to 5 casualty, at least I am talking about. Once upon a time, Tata Steel itself used to have more than 10-12 casualty in a year, apart from the abnormal some blastings and others. So, that is now concern for the nations. When you compare with the global company vis-a-vis Indian company, so these two things, one is the safety, second is the quality inconsistency. When I talking about the quality inconsistency, not just refractory, also the finished good quality. So, these two parts globally it's challenge for India. Whoever the global players started the manufacturing setup in India through Make in India, these are the two concerns came out. So, then we started investing money, then focus. So, that part optimized by campaigning of safety. At the same time, we started using machine instead of man, means part of the man's activity being replaced by the machines, automations, and that is why today topics I think AI and automation. So, many cases where we have been using that automations, digitalizations instead of direct installation by the human. So, that in that process, throughout the whole process, we can eliminate the error part, because any days the machines, if you design such a that the eliminate the error part which is happened by the man. Then second, as I mentioned, the safety part. Third part, the accuracy of the linings. Many times if you do sometimes by inexperienced workforce, because if you take if you go to any steel plant, the worker who is lining, they are not experts so called, because that is also challenge for India, because the same workforce sometimes when there is no job, then the same workforce being utilized in other job like normal constructions, agriculture and others. Because except Tata Steel and JSW, because they produce hardly what out of today 200 million ton of steel, they produced 40% of the steel, but rest 60% still challenges. So, those cases the resource is one where the same workforce are engaged in multiple activities. So, that the skill level of the employee is not generating. So, that is why we decided to have the machine instead of using the man in this case. So, this in short, that is the future or the emerging trend where the most of the company are thoughts about the solution provider, that includes the green technology, that includes robotic solutions, robotic applications, digitalizations, then circular economy, then artificial intelligence and simulations, and some value added services including heat management, because on a steel industry, one of the energy intense industry, if you could save some heat, that will save directly money to the company. So, what we do today as a part of AI and automations, I take there are many cases, but the broader cases I take 4 examples. The robotic slag shroud handling, which is ongoing practice today. So, few particularly JSW steel plant, we install one robot that removes that shroud and automatically again apply the shroud in the bottom of the steel ladle. That is ongoing practice. Automation in slide gate control, you know slide gate, there are many mechanisms, LG concept, LS concept, there are many mechanisms. So, now it is being done automatically. Then automations in repair lining. So, here automation process, automations are done still in trial stage, few cases. I mean, robot can do the lining of the steel ladle, and also robot can line the arc furnace and wherever the lining takes place, including BOF. So, here for the lining part and automation not only for the lining, also for the data capturing, because in AI is fully driven data driven process. Sometimes when we take the data, real time data, and put it in registers, there is many it gives malfunctions, means people manipulates the data, people sometimes forget to put data, sometimes there is any audit, just to manage audit they manipulate the data. So, data which are feeding into the systems are wrong. So, now there is a process where the machine can input the data. So, that process is on. Now, the slack detection is a real time monitoring. So, Somendra was talking about the slag is definitely slag is one of the important aspect of the both refractory and the steel making process, because if you two aspect, if you carry more amount of slag from ladle to converter, converter to furnace, furnace to even casters, then it carries lot of impurities. That impurity goes into the steel, and finally the steel quality gets deteriorated, because when the slag carries iron oxides and manganese oxides and other oxide, Mg oxides, then it has always tendency to have oxidations, and during oxidation process it is definitely the impurity, particularly for steels, many impurities, hydrogen is impurity, nitrogen pickup, hydrogen pickup, carbon pickup, and also he talked about phosphorus and sulfur pickup. These are the inclusions of the steel. At the same time, there are some refractory inclusions which goes into the finished goods of the steel, that can be detected, because if you stop or optimize the slag carryover to the next stage of the steel process, you can automatically control the quality of steel. So, we have the slag detector machines. The job of the slag detector machines, it collect the real time data and automatically detects what is the chemistry of the slag, and accordingly they ask you to readjust the better quality of slags to produce, either by synthetic slag or by adding limes or dolomites or whatever the input material based on that steel grade properties. So, that machines today we have almost 6-7 customers we have already implemented. So, that we have. And then the slag chemistry is the other aspect. If you see that I am not going into details, again for the E-Tech is one of the solutions which we provide to customers, that gives the slag analysis, or we call ladle slag ladle modeling. So, that says the slag chemistry, accordingly you can adjust your slag property. At the same time, you can do the mass balance of the steel ladle or BOI for any other equipments, and at the same time you can have the cell temperatures of the equipments, because that is the primary indications whether the equipments are going to be punctured or some failures and other things. For example, the humans have the fever, then you have the symptoms to have the other disease whether you have or not. Same thing, you have the cell temperature detector machine. There is a two kind of, one is the E-Techs by which you can measure, and the very conventional way of measuring the temperature gun. So, you can see for example, for steel ladle normal cell temperature is below always 300 degrees Celsius. For any reason it exceed 500 degrees Celsius, that indicates something is garbad is there. So, that something is fishy or something mistakes is there, then you can immediately put it down and you can visually cross checks and then see whether something is error or not, then you can rectify those things. So, that is the primary things to detect whether any defects or flaws available in the systems. So, that the mechanisms in 3Ds and data capturings, all those the machine learnings today we have been using. The only reason is that, as I mentioned, mostly we take the data based on experience. We send some expert to the site and he gives his own version. So, I am expert, I am taking this care of since last 30 years, 40 years. So, according to me it should be happen, but many times it proves wrong. So, today we do not believe just expertise view. Today of course, their expertise view is important. Today we take the decision based on the data. because the data does not say wrong, and that is the strengthening area I would say for not only for one company, for every company in India, is to have or to take the decisions on database. So, solutions today we provide the value added solutions for the metallic yield improvements. Metallic yield improvements for each step of the value chain, starting from I am not coming into the iron making area blast furnace, but in the particularly in the steel making process in both in primary and secondary steel metallurgy, then ladle to BOF to then RH or KR impeller to caster to mold. Those steps we have the process to have to produce maximum amount of hot metal, because we have the process we have optimized particularly for the steel ladle IBOS. So, this is integrated bottom optimization solution, where we cast so drainage systems, it is basically at 5° angle, so that the leftover material at the steel ladle bottom would be hardly 1.2 ton, not more than that. So, you can carry over most of the hot metal to the next process. So, that is the yield improvement that we do today. At the same time, as I mentioned, the improve the iron oxides from the taking out from the slags and others and put it in the main steel. So, this way we can do the metallic yield. And then the clean steel, as I mentioned, there are the flaws in the steel, hydrogen pickup, nitrogen pickup, sulfur pickup, and every stage we have the solutions, and again it is simulation, it is done by simulations. So, it is by better quality of refractory, because as I mentioned, not just refractory gives every solution, it is refractory along with the metallurgical solutions. Its metallurgical solution means including your turn discovering compounds, your synthetic slags, your better purging systems, and now the purging is different kind in that hybrid purgings or direct flow purging. So, many way of purgings are there. So, in short, that the clean steels today produced from the refractory, good quality of refractory, additional of metallurgical solution, then the design of the refractory, and then of course the purging system. So, combinations of all 4 5s we do the process today. And one of the example I can give today, I mean traditionally we have been using magnesia carbon for steel ladle. So, today the producer who are producing the low carbon steel, and magnesia carbon is detrimental for them, because for magnesia carbons many cases, although it has any other property to have better life, but it at the same time it has high tendency of carbon pickup from the magnesia carbon. The customers who are the producing the low carbon steel, particularly less than 50 ppm level. So, those cases today no more use the magnesia carbon, it is completely switched from magnesia carbon to alumina systems. So, today at the bottom and the metal zones we are using the alumina based material we call alumina spinel, and few cases little bit of fired spinels, hardly 2-3% carbon enrichment in the systems, but slag zones remains its magnesia carbon because of the slag behaviors and the corrosions properties with the slag. So, that is why magnesia carbon bricks today use many cases just as slag zone, but no more are using bottom and the metal zone. So, that shift had got changed.
Because in that slag zone, that carbon offers better resistance to corrosion.
Yes, yes. So, safety I am not taking, so many equipment you can see is the no manual interventions is required, we do with the help of machine, and today we have gunners, shooters, robotic gunner, then we have TBD machines, because the Sobendra was mentioning about the converter, how the converter operates. Just one small clarification, Sobendra, when the charge pad exactly is not the bottom of the converter, charge pad, because when you converter always rotates 360° angles, there is a provisions. So, when you charge the input material, that is basically 30 to 40° angles, you tilt that way, then you put all the charging element. So, the charging material does not goes into the top back, I mean top charge of the bottom of the converter, that always in the side well. It's mostly in the lower cone of the vessel and few cases near to in between. So that is the charge pad that we need to take care. That is of course one of the erosions area where it is controlled by, now it is today we are doing by pad brick. It is called kind of magnesium carbon bricks, inferior quality, and then you put it and then gunned or locked by some gunning machine, gunning material. So that is the practice today that gives the better result. So that machines today you can see mostly we do with the help of machines. So the manual interventions is not required, because you know when suddenly one tundis or ladle comes into the applications, many times customers has huge pressure, particularly production has huge pressures to have the refractory lining immediately. Even they do not get sufficient times to cool it down. So they just operate the normal fans and ask labor to work in there. So what we did today, we no more use any workforce to digging those material out. We use machines to dig it down, keep it separate, then cool it down, then immediately apply material. So today even the downtimes of the refractory linings got reduced by 50%, completely replaced by machines, so that you can take care both the production objectivity, at the same time the safety objectivity, and of course the quality. I discussed already, I just skip this slide. Slag carryover I discussed in the primary metallurgy. This is one of the CFD solutions we did, and the BOF, this is one just purposefully I kept it. You can see the percentage, hardly many time we take the decision of the refractory material cost on the BOF purchase, but the material cost does not gives your 100% cost. The other costs are different. You can see our hardly 30 to 35%, 35 to 45% the lining material cost. The other around 60% cost are coming from different aspects. It's a downtime cost, then emergency downtime, then monitoring and technical service, then solutions, all other costs put together. Because the one BOF gives live, let's say 6,000 hits. It's not just refractory. I mean, suddenly there is a puncture or there are some issues, and it takes another 10-12 days. Then it erodes all your steels productions, margins, and so other. That is why steel plants, they somehow can take care if there is a ladle failure, but they cannot take or they cannot digest if there is a failure in the converter. So this is one of the stringent area. That is why there are very limited player coming into these areas, and 4 or 5 hardly in India, they are doing the service for the converter. So here again the predictability. So this is one chart that we are talking about. We have the simulations which we do with the machines, and for each and every problems we have software control solution process. Just for example, and every we call aggregate, it's whether it is hot metal runner, DRI, blast furnace, RSD gasser, mold, reheating furnace, anywhere. If we put into 3 parts, the refractory and additives part, advanced technology or systems, and the consultants and the simulations. So just for one example, we want to do that hot metal losses, that is one problem we have. That the amount of hot metal losses to be reduced. So now from the refractory solutions we have improved bottom optimization solution, that is called IBOS. We did one project in Tata KPO that gives satisfactory results, and now we got 4 orders from JSW. So JSW also running, and at the same times we have control from the ladle purging side, that infrared systems, ladle slag detections machines, by which we can detect the slag chemistries and others, and accordingly we can readjust, and at the end that the CFD simulations. So that computerized fluid dynamic simulations are done often for ladle, for both for all the objectivity, mass balance, slag chemistry, then heat transfer. So all those things are done by CFD simulations. So these are the process we maintain. At the same time, if you give the problem, let's say high slag carryover, or maybe high nitrogen pickup, high carbon pickup. So, every cases we have the solutions. So, like this way in the simulation process we do. So, thank you. This is all about today what we do. I think I am on time or exceeding time? On time. Thank you. Another point that RH today it's mag chrome bricks. We are using mag and chromiums. So, spinel bricks not mostly in okay. So, for the most of it is mag chrome mostly.
So, Nandan, is it mag chrome or chrome mag?
It's mag chrome. Mag chrome. Magnesia portion is, I mean, that is the.
Is it a mag chrome chemically bonded steel clad?
Chemically bonded.
Steel clad.
For RH degasser, snorkel area. For only for the snorkel, not for the RH degasser upper vessel, lower vessel. Only at the snorkel area.
Set and then they fire.
No, it's completely fire bricks. It's fire even high temperature. It's fire.
I'm talking about when used. Is it a fire brick or a steel clad?
It's a fired bricks done in reducing atmosphere, not in even oxidizing atmosphere. It's the kiln process inside the kiln is reducing, and it's mag chrome. Chromium percentage at approximately 30 to 40% range for depending upon the product quality, and then the magnesium. It's FM.
How the steel cladding is done? Is it steel clad?
Yes, it's always prefabricated steel cell is there. I mean there are two processes. Then normally you use the imported versions of the steel cell, where the snorkel prefabricated design is already there, because snorkel is in two kind of, one is the vertical and one is the conical design, just to give the better pressure. So, that the snorkel designs, then we use the snorkels, the ring formations are done inside, and few of the portions it is done by precast, where particularly groove area you cannot reach, you do with the castables. So, that the snorkel part is done, and then snorkel again then climb adjust, added with the RH degasser. Yes. And now in every operating process, snorkel is one of the corrosive area. So, then we do manage with the gunning, that is called RH gunning material, that is purely again DBM and FM based material, that snorkel gunning, and that is also dangerous area just for application, because that is the hot conditions and people are using just by gunning this area, and there is high chance to throw it all the small flake of iron and others into the body. Even you wear some fire protective jacket, it will not happen. That is why nowadays many companies started using manipulator, means the human to go, they will just the manipulator go inside the snorkel and then the gunning it. That is the practice. Okay, thank you. I think any questions?
I would now like to invite RS sir and Parthu sir for felicitation of Nandan Satra sir. Next up, entrepreneurship and innovation creates opportunity that shapes industries. Our next speaker, Mr. Ashish Kumar Kundu sir, is the founder and chief technical director of Satabdi Monolithics Industry Private Limited. Please welcome him for his talk on monolithics, the advanced refractory and opportunities in the refractory field, with a huge round of applause.
Good afternoon, everybody. So we are already late, so it is lunch time. Still I will request all the students to give attention, because I have prepared this slide, this presentation for you only. Already two big company, they are big player in refractory field. But before going to that, I have prepared this presentation as a for student, So just you follow this, and before starting I will pay my respect to all the professors in this institution and all my seniors, juniors, and my love to all the students. And also at this moment I will remember my technical father, Sri Khonish Chaudhary. She is also from this institution in the year of 1959. He is NRI staying at German, but very unfortunate she has left. I am really unfortunate. I always remember him because what I have learned from him. He was pioneer in monolithics field. So my exposure is also in monolithic refractories. I have 2 refractory units at Borjora and 1 paint industry at Borjora. So my presentation is for you student, so please follow. I am starting here. It is advanced refractory and opportunities in the refractory field, which is most important for you student, because you are thinking about your future and there is a scope in refractory field. So I will discuss all these points. So next you will get a clear picture. I have prepared this slide to understand from ceramics, the concept, it is inorganic, non-metallic articles, substance shaped by drying or firing. And there are 2 classifications: traditional ceramics, that is primarily made from clay, pottery, earthenware, bricks, tiles, so on. And next, advanced ceramics, which is called also technical ceramics, high purity, based on synthetic materials also, artificial teeth, artificial bone, joints, optical fibers, electronic circuits, ceramic balls, so on. Different in ceramic fields: earthenware, sanitary ware, refractory, cement, glass, advanced ceramics. Next, in different field, refractory is very important, which is essential for iron and steel making, and also need for any high temperature application. Now refractory. Refractory is a non-metallic, inorganic, high fusion mineral based substance which is resistant to heat, can withstand at high temperature without degrading and softening. All this word is very important for refractory. Next, classification of refractory. Refractory are 2 types. One shaped in the form of shaped, that is called bricks, and unshaped powder refractory, that is called monolithics. So it has classified on the basis of chemistry 3 types, that is acidic refractory, basic refractory, neutral refractory. monolithics, the term monolithics, that is monolithic refractory. The monolithic refractory, monolithics, the term has come, the word monolith, which is a big stone. A monolithic product is mixture of aggregates, binders and additives in a definite ratio. Next, the use of monolithic refractory over safe refractory. Globally, monolithic refractory is used much more than Indian. In outside, almost 70% refractory is monolithic refractory and 30% almost is safe refractory. And India, it is almost reverse, but now it has gradually increasing, and there is a large of scope to increase to use monolithic refractory. So why we are using more monolithic refractory? So there is some advantages. One, it is very shortcut process. It is semi-mixed finished product. When we make bricks, it will take much more time because so many steps are there: molding, shaping, drying, firing, so many. But monolithic is a very mixed product, ready mixed product. The raw materials already processed before, so very instantly we can supply this product. And also advantage, flexibility of shaping during installation. We can give any type of shape through monolithic product. Quick installation and easy installation, no joint in structure, better chemical corrosion and abrasion resistance, and it has good thermal shock resistance. Next, now on the basis of application method, again monolithic product has classified like this. The application method, that is casting method, ramming method, gunning method, spraying method, patching, toweling, pouring. With these type of methods, the products has classified. The very common product is castable, and castables are also in different types. Generally conventional castable, it contains much more cement, refractory cement, that is around 15 to 20%. On lime content basis, it has classified, it is near about 4.5%, 5% CaO. And next, low cement castable, it contains near about 5 to 6% cement, and CO content up to 1.5%. And ultra low cement, it contains 2% refractory cement, CO content is 0.2%. And no cement castable, it is very new generation castable. It is salt bonded, gel bonded castable, and is being used in critical area in steel plant also. And then cell flow and insulating castable. Insulating castable, it is high porosity, it contains, and it resists heat transfer. And then ramming mass. Ramming mass is also three types generally. One is acidic ramming mass, that is based on quartzite base, and that is used in induction furnace. And next is alumina based ramming mass. Alumina, silicon carbide, carbon based ramming mass is very common, that is used in blast furnace area. And next is basic ramming mass, that is used in commonly arc furnace. And next, gunning mass, Basic gunning mass is very common material for electric arc furnace. Spray mass, it is also commonly basic material. Patching mass, plastic mass, coating mass, and motor. Motor is big jointing powder material. And this is a general flow chart how to produce monolithic refractories. It is raw material. First we do preparation raw material, then crushing, grinding, sieving, milling, and it is aggregates, mainly for aggregates preparation. And after that we add binder and additives, and then we do mix in mixer machine. Different type of mixer is there: countercurrent mixer, drum mixer, ribbon mixer. So many mixers are there, and ultimately we make it in powder form and packed in 25 or 50 kg in packet. And next, raw material. So when we design refractory product, so we consider all these features like this: purity, chemical composition, density, abrasion resistance, slag effect, metal effect, corrosion resistance, thermal shock resistance, porosity, refractoriness, granulometry. All these are important. Few important raw materials already I have told: quartz, quartzite, calcined bauxite. It is very common raw material. Fused alumina. Two types of fused alumina there. One is brown fused alumina, and high purity material is white fused alumina. Next, tabular alumina. It is the best high purity raw material, resist to thermal shock especially. Magnesite, chromite, zircon, so many. And all these materials has high fusion point. Next, how we design product. It is mainly aggregates, principal raw materials, then binders. Common binders is hydraulic or chemical, cement binder or clay binder. Additives, flocculants, deflocculants, so many additives are there. Carbon is also a very good additive, and it is used for specific use, and that gives finished product. So when we design monolithic refractory, we consider surface temperature, surface environment condition, type of materials to be handled, thermal mechanical stress, and thermal shock behavior. Next, quality. So many quality parameters are there. We followed. First, granulometry. It is very important. According to desired, we design the granulometry. If we need high density product, accordingly we design the granulometry. If we need less high porosity material, lightweight material, then accordingly we design the granulometry. There is no term proper granulometry, because it depends on your desired density, loose body packing density. Next, cold crushing strength at different temperature, and it is load bearing strength, because it is very important how strength your product having. It is also very important. And PCE, pyrometric cone equivalent, and it indicates the softening point of the product, because when we use any product, that should be in safe side, because earlier I have used a term, no deformation, no softening will be there. Thermal conductivity is also important, because if thermal, it also depends how much I need because in cell, when refractory lining is there, the heat will transfer through the refractory mass. It will come at the end of the cell. If outside temperature is high, then it will be problem to handle. So our object will be to reduce temperature at the outside cell. So there will be 1 or 2 layer of refractory, where at the cell side we can use insulating castable or insulating bricks. PLC is also important. How much your deformation is coming, that is also important at the high temperature. Thermal shock resistance at the environment, if there is temperature rise or down frequently, then there is a important parameter, thermal shock resistance. Chemical properties we normally follow for neutral product, high alumina product, alumina, MgO, silica, zircon, iron, all these are oxides we measure, and alkali, carbon content, and VM also. Product installation. Regarding this, generally we use monolithic refractories or any refractory in clean and furnace, blast furnace, induction furnace, arc furnace, coke oven, alumina plant, cement plant, so on. But you should know the difference between clean and furnace. In clean, we generally fire product, calcine the raw material in clean. There is no melting, but in furnace there is a melting process. Any product which we need, we can melt, like a steel. In steel preparation we do in furnace because there is a melting process. Okay, it is clear what is clean and furnace. Next, application method. Casting, ramming, gunning, all these are the process already I have told. So during application we have to keep in mind the following points. One point, surface should be clean, because if there is not properly cleaned, then the layer of castable will not spread out or will not attach with that surface. So it is need to clean the surface properly, and if there is any impurities, that can also affect your refractory lining. Suitability of framework, suitable equipments availability, it is very common through which you will apply the product. Placement method and procedure, smooth finishing of lining surface, it is also important, because if the surface is not smooth, then it will obstruct the flow of the metal or any item, so that will erode the refractory lining, and that will reduce our shelf life of the lining. And control drying and firing, it is very important, so I am not going in details, but as we use water in castables, so that water should be removed in a proper way, otherwise it will make crack and the lining will damage. So slow heating is the basic concept, and we have to remove the water carefully. So in refractory field, so many refractory producers are there. Some of them, my company Shatabdi, Monolithics, TRL Kurosaki, Yumi, Vesuvius, RHI, Calris, Mython, IFGL, so many big players are there. They are doing very well and giving support in the refractory field. And market potentiality of refractories, just I have a short idea. In 2022-23, by tonnage it was around 16 lakhs and business volume 10,000 crores. Gradually it is increasing. In the year 24-25, it has come 25 lakhs ton, that is 15,000 crores. and 2030 it is estimated 40 lakhs tons, it will come almost 25,000 crore. My company's products, so many products are there. First, conventional castable according to alumina content, 45 to 95% alumina content. It is conventional castable. Next, low cement castable, that is also 45 to 90%. Next, insulating castable, these are types. It has classified on the depending on BD. Normally in insulating castable, BD is low. Here it is 1 means 1.1 gram per cc BD, and here is 1.3 gram per cc. Next, mortar, gunning mass, all these are products there. It is basic, mainly basic, ramming mass, gunning mass. Here is nozzle filling component. It is a product. It is used as filler material in ladle nozzle or in Tandis nozzle. It is a filler material. Before we discharge the metal, it is being poured and then it is released, fall down, and then metal come out. It is also silica base, chromide base, zircon base. High roller mortar, they may be air setting or heat setting. Blast furnace, for blast furnace area, it is all special refractory monolithics. First, I have shown zero cement castable. It is a new generation castable. Alumina silicon carbide carbon based castable. Next, alumina silicon carbide blast furnace trap mass. It is tar bonded or resin bonded. Now, high performance ramming mass is resin bonded material. And next, taphole clay. It is a special product, a common product for blast furnace taphole use. There are so many blast furnace in India, mini blast furnace or big blast, large scale blast furnace. Large scale blast furnace is at cell units, and also Tata, Jindal, they having all large blast furnace. But now in Indian market, so many mini blast furnace is there. In Durgapur zone, in Kharagpur zone, Resmi, Balaji, so many. So they have mini blast furnace. Samsel is also there. And there are some few products like casting powder, ladle top covering bottom covering compound. Ladle top covering compound, it is used as insulation to reduce heat loss. And bottom cleaning compound, it is used in ladle bottom to prevent slag generation, slag stickiness, to resist slag jamming. And then mold coating, it is also a graphite based product so that metal cannot stick in mold. And cocoment patching mass, spray mass, gunning mass, and synthetic slags. Synthetic slags, it is being used for refining the steel. So many customers are there, Tata, Shell, few are, I have presented here few, but so many steel plant are there. This slide is very important. Opportunity. What is our opportunity? One is business opportunity, what we are doing. The monolithic refractory is a mixture of different inputs. So it is a subject where regular R&D works is need to develop quality refractory. Challenges has come to use indigenous material more than even 100% to design quality product at low cost. use of secondary material are also challenging to meet the quality. Yes. Now, first point is Make in India thought, because we are dependent on outsourcing for raw materials. So that we have to reduce, and that is a big challenge to us. And I have developed so many products which is totally based on indigenous material. There is no outside material, and it has helped to reduce our cost, and also I am meeting the performance also. So it is very natural, customer always demand quality products at low cost. It is basic concept, they always demand at low price best material. So there is always, there need always R&D work. Steel production gradually increasing, what I have shown, and demanding more quality product to reduce consumption. Yes, consumption is also a matter. In past, consumption was almost 15 kg per ton of hot metal, but it has reduced almost 5 to 6 kg per ton of hot metal. So gradually the development is going on to reduce refractory consumption. And sustainability. So sir was talking regarding sustainability. So sustainability is a very, the term is very important to us to run any industry. So I think sustainability is not a single word. It's simply, it's depend proper knowledge management, because it is like this. You have to develop good quality product as per market need. That is also a point. And not only your knowledge, but you have to put that in proper way. In proper way you have to manage, because only having the formulation, that is not the end. You have to design, you have to produce that product, you have to execute that product, and your business management, your company management should be like that, so that it will run properly and it will sustain you for a long time. And student, for you, your opportunity. I think after complete your academy, first you should take service opportunity. You have to take service opportunity, because you have to gather sufficient knowledge. And sufficient knowledge means, say, when you are going to a company, they will give you in production or in sales or in market, anywhere. But you should keep in mind, I have to learn the complete process, complete way, because raw material purchasing and at the end of the marketing, all should have your good knowledge, so that you can in future you can set up a manufacturing plant yourself. And there is also so many opportunities, because you can trading also. So many raw materials are there, and in a huge quantity we are using, say bauxite, it needs cancellation. In Porbandar you go, there are so many plants are there, they are only doing calcination bauxite and supplying us. So there is a scope trading and supplying finished products also. We are manufacturing product and we are selling that product with a margin, say 20%, 25%. But globally, if you know the market, you can sell that product even 100% with margin. So that is your credit. So before that, you have to know that market. So there is a lot of scope. You have to learn, you have to gather your knowledge, and you imply that. And after all, if you can set a plant and also you can come in business, your identity will be very strong. So you will be an employer, and I will expect from you in future you will come out through your business as a employer, and you will serve your society with your progress. Thank you all. This is my presentation. I think you will get a concept in your future also.
I am telling you all students, how many students from class fourth year, how many students, raise your hand in fourth year? Only one, others have rest. So you are completing your academic area. So I will speak with our professors. So I invite you all to come to my plants at Borjora nearby Durgapur. It is only 200 kilometers from here. So I invite you all to come to my plants, and you will get a concept on monoliths refractory. So it is my invitation for you all.
Thank you so much, sir, for such a wonderful session. I would now like to call upon our HOD, Dr. R.S. sir and Ruma ma'am to felicitate sir.
Wonderful introduction. So I'm just here as a part of Vesuvius, and today we will be discussing one of Vesuvius's most recent ventures in the field of casting fluxes, and basically we will take you through the principles of fluxes with a portion of the industrial applications, because you guys are just gonna be graduating and will be going to these. Some of you will be definitely going to some steel plants. So it's important for you to actually understand the principles and the basics of what the steel industry means. So the agenda will be to discuss briefly about the casting fluxes history in Vesuvius, the basic functionalities, our production units, how we are actually selecting our powders based on different steel chemistries and the dynamics, our recent introduction to the powder distribution mechanism, which is very good automation project which Vesuvius took, and lastly we will go through a sustainability drive specific to the mold powders. So Vesuvius, as you can see, entered this business with Foseco in 2008, and later took upon the charge of Metallurgica in 2012. Also, we are having a unit in Brazil known as Carbox, and finally in 2024, based on our experience with all the other plants all over the world, we started our own greenfield project in India, which is based in Vizag. So what is a casting flux? I definitely know people here don't often talk about this subject. So I will just like to take an understanding from the people around. How many of you are really aware of casting fluxes? What are they? Can raise your hand. Anybody? So see, this is something which is not very often talked about. So basically, casting flux is a mixture of raw materials, basically ceramic oxides, some pre-reacted synthetic minerals, and carbon. This product is basically can be produced in two ways. One is a fine powder form, and another is a granulated powder form, and this keeps a bifurcation, and later in my slides I will be talking about why we shifted from the initial journey was with fine powders and why we shifted to the granulated products. So the basic composition of this powder, you can see it's
broadly, distributed into network formers and network modifiers. And the basicity and the viscosity has a very important role in the heat transfer in the mold. We will discuss in the later slides. I will also discuss about where these things comes into picture. These are some basic raw materials which are used in the manufacturing of this product. You can see some sources of the minerals which are used, such as wollastonite, lime, quartz, fly ash, sodium carbonate, spar, and these all these interestingly in casting powder, all these minerals have their own usage. So I was talking about the basics area of our usage. As you can see in the magnified picture, you can see the tundish and the mold. So the covering, the red covering over the steel, which is marked in yellow, is where our products are used. So what is the why is mold powder used in continuous casting? It's an interesting question. Why can't we cast without a continuous caster without usage of this mold powder? The basic this is actually a question which people don't actually are very well versed with. The primary function of a mold powder is to give lubrication, to control the heat transfer in the mold and prevent reoxidation, thermal insulations, and also inclusion absorption. This is a section of mold which you can see the blue liquid layer is the slag which is formed from this casting powder. And how you can in the animation you can actually see how the casting powder flows into the channel. This is the mold and the steel shell which is solidifying, and how it is providing a constant lubrication layer. And why is this lubrication needed? Because without this, the steel shell will be sticking to the mold, and it's gonna lead to breakouts in the mold. So in this aspect, casting powder has a very important role while we are continuously casting. How are these made? As I introduced the terms fine production and granulated production. So these are a few machines and machineries used for mixing the raw materials, the inputs, and to make a homogenized powder. This is basically used for the fabrication of the fine powders. And as we go to the next slide, this is a setup which is used for making granular powders. And what is the benefits of granular powders is that fine powders have been in usage for a long time, but the problem with fine powders has been wastage due to dust generation, lesser homogeneity, lesser flowability. These hollow spheres are basically helpful in maintaining a very good flowability, no patch formations, and good thermal insulations with homogeneity. And the best part is this granulation can go on in a very continuous process, unlike the previous method, which is basically a batch process. So Our production units, as I was discussing, is all over the world. We have a unit in USA, we have in Brazil, we have in Mulham, which caters to the largest amount of our powder production, and the new project which has come up in Vizag, India. And also we are having a R&D setup in Gla, which is in Belgium. I will just, so this is a basic schematic diagram of how these granulated products are made. First, the recipe, the batching is done for the raw materials. The recipes are then and feeded into a system which is having rotors, and where the mixing is done with water. So we have a very homogeneous slurry which is then pumped through these slurries, the pumping machines, which goes through a slurry sleeve to a spray tower which is having lances, and is having in the top portion you will have a burning unit, which basically takes out the water from the granules or the slurry mix which is going up. So the powder particles will go just up. Here the moisture will be taken out, and it will just fall due to gravity to a collection unit where there are vents for cooling, and this finally the FG will be shifted to a packing unit. So in this process, quality is one of the the most important thing which Vesuvius has always been focusing upon. So we have a lot of checks which we perform, starting from the raw materials to the slurry to the FGs. We continuously keep on checking our products so that we have a consistency in our product, and we when we enter the market, people should not talk about inconsistencies. I think consistency is one of the things which Vesuvius Fluxus divisions is the key focus for Vesuvius Fluxus division. So as I was discussing, the entry control, the process control, the exit controls, everything is checked, monitored, data are tracked, data are used for further analyses and for further optimizations, and this process is being very religiously followed. So this is a quick snap of our equipments through which we are measuring all the key aspects, the key parameters which are important for our casting flux generation. Basically, each and every step there are we are having very high specific products which or equipments which are which gives us very precise control over our finished goods. So for casting powder selection, the steel the steel melt, the solidification nature of the steel inside a casting mold is a very important thing. Without the proper sound knowledge of how the steel is behaving inside the mold, you cannot formulate a good recipe which will both cater to the productivity plus the quality. So steel is broadly classified into four broad groups: the ultra low carbon, the low carbon, the medium carbon, and the high carbon. this basically this division is done with respect to how the product or the steel behaves inside the mold. You know, the shrinkage factors, the hot strength of that steel inside the mold, and some main issues are also highlighted. That is like in IF grades, there is a very ultra low carbon, so carbon pickup should be minimized with, and also non-metallic inclusions. Some of the IF grades are very critical about this non-metallic inclusions in the final cast product. And similarly for all the grades, there are some parameters which we have to keep in mind while we are formulating a casting powder. So that we are able to, we are able to cater to the customer's precise requests. About somebody is coming with a request that we are having some cracks. So what is the crack? Where is it forming? Every small details are very important when we are formulating a casting powder. This is typically a graph which shows how with the carbon content of the steel, the shrinkage happens inside a mold. So you can see the very high shrinkage coefficient for some grades which fall in the range of 0.08 to 0.18, 0.2, where the depression tendency in the mold is a very critical factor, and which influences the quality of the end product. This level of precision is required for formulating a casting powder, so that we can cater to this kind of heavily shrinking grades inside the mold and give a good output. So these are some typical recipes we designed as per our the net shape which is desired for slab, for thin slab, for bloom. Everything has a different. You can see all are having a different chemistry, and the logics are very precise about why this kind of, why the C by S ratio is 1.2, why is it 1, why the carbon content of this slab is less, but you can see higher in mold, in bloom casting. All the viscosity of the powder, the melting point, everything has a very key role while we formulate casting powders for different shapes like slab, thin slabs, and blooms. So the properties which we look upon are the viscosity, the basicity, the heat transfer, the crystallization of the slag film, the melting point, the melting range, the melting rate of the powder. All these are kept in mind while we are designing some powder for our customers. So this is a typical viscosity measurement unit which we are having in our plant in Mulam, which is used for the precise viscosity measurement. We generate a curve like this, which gives us the precise, the infinite viscosity point, which also we are referring to as the crystallization point. So these precise measurements are very important for us to understand how this powder will behave inside the mold, where the temperatures are almost like 1100 to 1200 degrees, and the liquid film at 1300 degrees. How and how fast the material will melt, how fast it will form into crystals, how fast the viscosity will change. Everything has an impact. Other than that, as I was discussing about the basicity aspect, everything has an importance. Why acidic slag is used in some kind of steel grades, why basic slags are used. basic slags generally are forming higher crystalline structures inside the mold, which is typically used for grades, as I was mentioning, the peritectic grades, which are very prone to cracks and depressions. This kind of basic slags are formulated for those kind of grades. So you can see a difference in the slag film. For this is basically a slag which is having basicity less than 1. It looks at like a typical glass structure. While when you see a crystalline slag, you will see lots of pores and cracks and crystals. And the significance is very aptly shown in this second picture, where you can see how the steel is shrinkage is happening, and the heat is this is basically the slag film, how the heat is being diverted back and excess heat transfer is being restricted by this casting powder. While when you are having a homogeneous film, how well the heat is getting transferred. These low carbon grades, which are basically very ferritic in nature and are very soft inside the mold, you need a good solid layer to release the heat outside. Otherwise, this shell thickness will not be apt enough to have a good strength, and this can lead to breakouts. So this is also a curve which shows how with the transition from glassy phase to crystalline phase, the risk changes. The heat transfer, you can see as we go from glassy to crystalline, is dropping, while the friction inside the mold is going up. So the criticality while we are formulating some powder has to have in mind this heat transfer, friction, cracks, sticking breakouts. So every steel the steel chemistry with different kinds of microalloying going around, you need to have a very clear and understanding about how much we should have the crystalline fraction, so that we don't risk over frictions, sticker breakouts, and also how much should be optimum so that we don't have this cracks as well. You can see a slab which is having a crack, which this is ultimately a loss to the customer. Too much friction, too much material loss will be there while they are grinding and taking this crack out of the surface. Another key aspect is the melting rate. I was just talking about the carbon in the system. The melting rate is typically, the carbon is something which is very intimately in relation with the melting rate, which I will be discussing in the next slide. As you can see, different fractions of carbon, different sources of carbon, different sizes of carbon is having an impact in the melting time, which is a measure of the melting rate. You can see a different carbon source. The carbon source may be an amorphous one, maybe a graphite one, crystalline one, will have an impact on the melting rate of the powder. As you can see, this is a powder which is having zero or no carbon sources in it, versus a recipe with 3% versus a recipe with 6%. At similar time, you can see this has already started softening. This is almost now breaking up, and you can see completely solid powder here. So carbon has a very important role while in the aspect of the melting rate of the powder. The carbon basically is the one which is burning the at the beginning. So without the burning of the carbon, the system will not have enough heat to melt. At last, as Vesuvius uh, in the recent days have understood that technical solutions should come with a more holistic way to serve the customers. Until now, the casting powders have been fed to the mold by conventional manual distributions. Now we have a technology with us which is having a feeding system which is continuously feeding the mold with our casting powder. This is basically very important when it comes to the uniform constant distribution inside the mold. The powder bed, how much it is forming, how regulated it is, everything has an impact on the productivity and the quality of the end product. And this also is very beneficial in terms of reduction in powder consumption, powder wastage, and also sound in product quality. So I will just have a small video where we can see how exactly our powder distribution mechanism is working. We'll just start it. So this is basically the silo where the FG is being transferred and stored, from where the machine sucks the powder. So you can see everything is now automated. You start the machine. The granules from the silo will now start entering into the machine. Here there is a vibro feeder. This vibro feeder is very essential so that no clogging of the subsequent chambers happen due to agglomeration of the powder. This powder is now being transported to the feeder heads, which is placed directly over the caster, the mold floor, through which you see the steel layer you can see, and this is being continuously fed with casting powder. We have an ultrasonic sensor which is continuously measuring the distance between its head and the top portion of the powder bed, and as soon as this distance is changing, it will have a quick signal to get back to the original thickness of powder. So this technique is also coming with a package of data capturing. The data is being backhand is being captured, and meaningful informations are drawn out of it. How much is the powder bed changing with respect to the steel chemistry, the superheat, the casting speed, and based on this we are also based on the data we are also training our model to be more precise. So automation has been a very focus point for us, so that we are able to cater to the customers small very precise problems through our good solutions and automations. Lastly, we will also like to talk about our sustainability drive. As you were seeing, we are using fluorspar in our recipe. As if you recall, we had a slide where we were talking about the raw materials, and we saw fluorine everywhere. So why this fluorine is used in a casting powder, and why it is impacting our machine health, our health? Okay, so this thing is why it is so critical that we need to shift from fluorine. We will discuss in the later slides. So why is fluorine basically used? Fluorine is a fluxing agent. It's very important to lower the melting point of the powder, and it also very aggressively affects the viscosity. It's a very important network breaker which can drastically increase the viscosity of the powder. So while designing a powder, fluorine plays a very important role. Also, the lubrication aspect is gone. Then comes the one of the very critical point, the heat transfer. And how is this heat transfer related to the fluorine? So without fluorine, we will not have the formation of the crystalline phase, which is very important to control the heat transfer inside the mold. And what are the associated risks with this fluorine? As you can see, this fluorine in the mold powder is forming some very corrosive gases, silicon fluoride, hexafluoric acids, hydrofluoric acids, and this inhalation of this kind of gases is very detrimental. Also, this is having an impact on the machine health. We are all knowing that the casting is done, and the cooling is very much dependent upon the water distribution inside the casting machine. So while the water is getting in contact with this corrosive flux, the water's acidity is changing in leaps and bounds. Due to this acidity change, you can see the heavy amount of rusting and corrosion which has happened to the casting machine, and this is in turn a very big loss for the customers. Also, we have seen some benefit that with fluorine being removed, we are having a impact on the residual thickness of the SEN inside when after casting. So this is an added benefit which we are also monitoring with this development of fluxes without fluorine or lesser fluorine. So if you are replacing fluorine, so how are we able to have the same crystallinity, the same viscosity, the same heat transfer in the mold? This is a challenge, and as a substitute of this fluorine we are actually substituting this fluorine with sodium oxide, lithium oxides, but this also are having some own challenges, because Na2O is lower in cost. It is already existing in our recipe, so we have already have an experience, but limiting should be with up to in excess of 20% is not good. While lithium, as you all know, is a very high volatility in the cost of lithium is a question, along with the availability part, and boron as well is also having some risk related to health. So all these challenges are taken up, and we are formulating products keeping in mind all the challenges, and in our R&D we are preparing many recipes with different proportion of all these materials, and then we are checking all the structures with our advanced technologies and equipments, so that we are able to emulate the exact behavior with of the mole fluxes with fluorine in addition. So what are the benefits without fluorine? Reduction in the maintenance of the continuous casting machine. As I was showing in the pictures, the level of corrosion of the machine is a huge cost for the customers. You need to frequently change the segments, you have to maintain them, which bears a cost. Reduction in the water treatment, the acidity of the water which is used here in the spray cooling, mostly in the spray cooling area, the acidic water cannot be reused. So we need to treat the water so that the pH level of the water is maintained, the hardness of the water is maintained, so that the quality of our steel which is cast is not degraded. Improvement in the caster machine life, the sequence length, this is directly linked to the amount of reduction in the thickness of the ACN which we were seeing in the picture above. So as we are having a better thickness, we can increase our life of the product, and subsequently what happens is that we can cast more with a single product. So all these benefits are are being monitored, and these have yielded significant savings for our customers. So we have already had some trials in our all over the world, and some of them have been very successful, and we are already shifted from our traditional fluorine based casting powder to a no fluorine or a very low fluorine alternative. We have also started trying these products in India, and we are confident that we will in this year, by next year, we will be converting some of our products to almost no fluorine or low fluorine alternatives. So these are some things which I was discussing: the water pH, the SEN increase, some benchmarks which we have seen from our plant trials. SEN life has increased. So these are some these are a few sustainability projects which we as casting powder division has taken up, and we are confident to serve and cater to the customers' requirement in a more sustainable way. With this, I would like to end my presentation. And thank you for inviting us. Flux is, you know that casting, any casting machine has a casting speed, right? And when you are increasing casting speed of any machine, I will keep it simple so that you can understand. When you are increasing a speed while you are driving, what is happening? The tires with the road, you are having a higher friction, right? So what will you do to eliminate that factor? You will provide more lubrication. So the viscosity is a parameter which is critical about the how much lubrication you are providing. So if you are having higher friction, I was talking about the friction. When you are experiencing some friction inside the mold, your natural instinct would be to lower the viscosity of the powder. So I hope I could. Thank you. Yeah. See, slag entrapment, as this is an added benefit of the casting fluxes. Ultimately, if your steel is not clean, we don't have enough time for the flux to pick up. Okay, so unless it is a vertical caster, which are very less seen right now, so we will not have a very long time to pick that inclusion. What we generally try to do is to improve the fluxing property of our slag. How we do that? We introduce some kind of we increase the percentages of low melting oxides which we are talking about, the sodium oxides, the lithium oxides. It builds us a delta of liquid pool, and if you are picking up the inclusions, then also you will have some buffer to what will inclusions do. If it picks up the, if you are picking up solid inclusions in your liquid, what will it do? It will the fluidity or the viscosity of the powder will change. So what the basic criteria would be not how we can cater to the lubrication part. So for the lubrication part to cater, we are generally introducing some fluxing agents. We are introducing some sacrificial oxides which would not affect the key ingredients, as I was talking about the basicity, CaO by SiO2. If SiO2 is gone, your basicity will rise. So these kind of additions are small additions are done to cater to the inclusion part.
So with glassy flux powders,
yeah,
how does it cause a rapid heat transfer type of a problem? Because usually glassy phases have bad thermal conductivities. So how does it cause
basically your glassy phase, as the crystalline phases which are forming inside the mold, we'll see a lot of undulations and cracks. Okay, so the horizontal heat transfer is not getting a path, it will continuously deflect. So while it deflects, you cannot the steel shell or the copper mold will not get the heat to catch it out. While you are having a glassy uniform structure, the heat transfer will not have any other alternative path to travel. So the heat will travel horizontally, and you will take out the water inside the copper chamber will continuously take out the heat. Okay. Any more questions? Okay, thank you.
Shinha, sir, to please felicitate our esteemed speaker. Does allow us to connect and learn beyond geographical boundaries, doesn't it? Our next speaker will be joining us virtually and bringing over 3 decades of experience in refractory technology and industrial ceramics. Currently serving as Deputy Managing Director at Foswell India Private Limited, we are delighted to have Mr. Deepankar Banerjee sir join us virtually for his talk on online refractory health assessment, inspection and repair of refractory linings. May we request our technical team to kindly assist with the virtual setup while we welcome sir with a huge round of applause.
Thanks to the organizers of this TARANGA'26 conference to invite me to make this presentation and this talk. I wanted to be there personally, but unfortunately, actually I have to come for a urgent meeting in Vizag today. So I have to connect online from our site office inside Vizag. So there may be some issues related to connectivity sometimes. So please excuse me for that. I am using the site Wi-Fi here. So I think and also my regards to all the delegates present, all the dignitaries there, fellow speakers, and also the present students, past students of GCECT, and also members of Indian Ceramics Society and also the Indian Ceramics Society student chapter of GCECT. So, I selected a topic for this. I share my screen first. So, I have a presentation to go through. So, let me see whether the screen is clearly visible to you or not. So, just let me know when you can see the screen. I am putting it on presentation mode. Just put this on the side. So, is the screen visible now?
Yes, sir.
Okay, the presentation is there, right? You can see it.
Yes, sir.
Okay, so I selected a topic which is a slightly different type of topic related to a branch of refractory technology which is becoming pretty popular nowadays and also getting more and more relevant. The topic is online refractory health assessment, inspection and online repair of refractory lines. Traditionally, if you see, if you go to any process industry, normal refractory maintenance happens during a planned or unplanned shutdown. When the vessel is shut down, the furnace is shut down, and we take the temperature down. People go inside and do refractory maintenance. But currently, there are several technologies getting developed and also available commercially, where these refractory maintenances can be done online without shutting down the furnace. And also, as a sort of a part of that, we can do health assessment or condition monitoring of the refractory, do some inspections also online without shutting down the furnace. In a running furnace. So this presentation will cover some technologies which are available today for online refractory health assessment, inspection and repair of refractory lines, which may be of interest to you, and then I briefly give you a gist of this technology so that in future if you have interest, you want to know more, you can get in touch with me so we can discuss further. So just a minute. So going forward, this is my second slide. So basically today, let me use a laser pointer also. I think, is the pointer visible there?
Yes, sir. Yes, sir.
Okay. See today, there are few technologies which the company where I work today, we use a lot. I mean, it is one of the services which we provide currently. So I will talk more about those two technologies. One of them is called high temperature endoscope and landscope. Endoscopy and landscope. This endoscope is a common term which you have heard in medical science, right? So in industrial endoscopy is also similar, where we insert a high temperature camera or probe inside the furnace, and it can be pretty long. There are endoscopes today available which are maybe the common ones which we use are maybe starting from 1.2 meter long to up to 5, 6, 7, 8 meters long, and then they have special cooling arrangements inside them to be able to withstand the temperatures. We have an engineering team which continuously works on these design on these endoscopes and landscopes. So this is basically for inside inspection in a running furnace, and today endoscopes are used for taking live pictures of refractory condition inside furnaces in many processes. We have in coke ovens, in blast furnaces, in pellet plants, in non-ferrous metals, in torpedo. There are different applications for doing an endoscopic inspection. I will show you some images. The second technology is thermal imaging, which is pretty common. It's also called infrared thermography, where you use an IR camera to take an image from the outside. So the difference is the first one is done by putting the probe inside the furnace, and this takes an image of the thermal profile of the furnace shell from outside, but which gives some indication about the health of the refractory inside. In addition to that, there are several other technologies today for online health assessment of refractory or refractory condition of a vessel. One of the predominant one is laser scanning. I will also talk briefly about that. Laser scanning is also commonly done today in converters and ladles in steel melt shop and also in coke ovens. And then there are few other technologies which I will not cover today because these are specialized technologies. I personally do not have experience about these technologies. But these are also today commonly available, like acoustic emission. AE technology is also a very specialized technology for understanding the risk to the furnace lining to failure, and also for assessment of the remaining refractory thickness inside a vessel. This is commonly used in hearth of blast furnaces, and there is a company in Canada called Hatch. They are specialized in acoustic emission technology, where AE sensors are put on the furnace shell, and you can detect special waves which emanate from defects in the refractory lining, and then that can analyze and give you a report on the refractory code. So acoustic emission is a specialized technology which is used for online assessment. Then there are other technologies like AUE, ultrasonic pulse velocity, magnetic systems, electromagnetic radar, and fiber optics. These are specialized technologies. And I mean, there is a very good technical paper by Hatch, which was published. I have a copy of that. I can share with some of the people there in the Indian Ceramics Society. You can then go through that. That gives a very detailed description about these bottom 5-6 technologies which are mentioned after laser scanning. So, which will not form part of technology, but I just wanted to list down available technologies today for online inspection of high temperature vessels. So let's get into endoscope part of it. Now, this slide, the third slide, it gives you this is a photo of an industrial endoscope. You know, they can vary in length. There is basically a box, and it can also be connected to a laptop camera to see. I will show you some images. You get live feed from inside the furnace. And then we can see, you can see an image. This is basically above the regenerator level, inclined zone of a coke oven heating wall. So you can see inside, we can see a very clear view, and this is at high temperature, running coke oven. Then we can get blast furnace checkers pictures, you can see here. And different type of images can be captured with an industrial endoscope. And as I mentioned, they can get pretty deep inside the furnace. Glass furnace is also another industry where a lot of endoscopy inspection is done. Glass furnaces, I mean, glass melting furnaces. We are also possible does the company where we work. We also do a lot of inspection in glass furnaces with an industrial endoscope, which are very long endoscopes, can be 7-8 meters long. We call them landscope. So endoscope and landscope terms are used interchangeably. So I will show you some examples of some endoscope images now. So this is an endoscope image from the basal main of a blast furnace. So you can see very clearly brick joints can be seen. We can know from where refractory has fallen, what are the joints, if there is here some bricks have come out, or if there is a hole, or everything can be seen pretty very clear detail. So this is a basal main image, endoscopic image. We can do an inspection inside and this is at an operating temperature. This is at 1200 degrees centigrade plus. So these cameras are designed to operate at high temperatures without any problem, and give a live feed outside. You can take still images with some of the modern equipment. We can capture videos. This is a division wall of the blast furnace. We can see there is a gap in the refractory lining in the division wall of the. This is the division wall of the stove, blast furnace stove. So very clear detail is seen, and we can also then plan for repair. The purpose of all these inspections is to assess. For example, customers like there are some customers today, they have periodic inspection plan. They call us. We go do an inspection, give them a report. That may not lead to a repair immediately, but beforehand, like a doctor does do some diagnostic test, that there is a weak spot developing somewhere and we need to be prepared. So it will not come as a surprise. Because these defects cannot be seen from outside. You cannot assess. I mean, particularly a division wall will not manifest into anything outside the furnace. You will not be able to assess without seeing inside. So this is another part of portion, and this is an image which we have taken after hot repair. I will come to this, how this hot repair is done slightly later. So by endoscopy, we also can see before and after repair images, whether the refractory repair which has been done in hot conditions sustains or it is not sustained. So that is also one of the benefits of this type of assessment. This is an image from a pelletization furnace, which is also a very, very common industrial furnace currently in all integrated steel plants. Every big steel plant today has have multiple pelletization furnaces, which are very long, like sort of a tunnel tube type of principle. They are called straight grate induration machines, where the bed of pellet is moving here. This is the pellet bed, and there are multiple burners on both sides of the wall which fire into the thing. This is the roof. So we can do online assessment of pelletization furnaces also, where you can see there is a refractory falling in this side. Some roof refractory has fallen somewhere. So we can plan repairs based on that. Instead of being reactive when the plant shuts down, getting inside and seeing where the damage is, people can plan whether to do an online repair or to plan for an offline repair. I mean, where the furnace is being taken down, if there is a major damage, they may need to plan a shutdown. But these images give a very good insight as to how much repair is to be planned, what repair is to be planned. Like here, you can see there's a corner, there is some problem, failure in the refractory in this joint. Yeah. So these images give very clear picture about that. This is also taken with a water-cooled endoscope camera. Same pelletization, but you can see a lot of refractory has fallen in this portion. So we know, we can, from this image, we can assess the quantity of refractory required, what sort of technology we need to adopt for repair. That can be analyzed, decided based on these reports. So this is again some pellet plant burner port inspection images using endoscope. And this is also some repair planning for pellet plants. I'll come to that. Maybe I'll come back to this later. Now this is also an endoscope image of a pelletization furnace where the castable, you can see from the roof, bricks have fallen. You can see that a lot of bricks have fallen and fallen. So very clear images are available. This is a pellet plant download cover. Also, we can do inspection. So these probes can be inserted through different holes in the furnace, portholes, or sometimes, if required, we can create holes by special tools for putting probes. If there is not a hole is not available, then we can create probes for putting these probes in. This is an example of an endoscopy in a copper furnace. It's a copper smelting, flash smelting furnace. So we have images of an endoscopy which has been done recently in a copper flash smelting furnace where we wanted to plan repairs. So this has been done in a copper furnace. So there are several examples. So, once you have got a gist of this endoscopic inspection, there is another technology which I think many of you may be aware, which is called thermal imaging, which is basically infrared thermography done with an infrared camera, where, and this is done from the outside. So it gives you a thermal profile of any type of furnace. It can be coke oven, it can be any industrial furnace where there is a metal shell outside, non-metal shell outside. It gives you a thermal temperature profile of the furnace through a color coding. If it's, and we can set the color coding, you know where the temperatures have shot up, and from that we can do an sort of a what we call proper sort of a logical conclusion or analysis or assessment of how much refractory is remaining inside. Because we know the there are thermal calculation models available where we know that if there is a temperature inside is certain and there is a certain refractory profile, we can calculate the actual shell temperature that should come in the shell outside. And if the shell temperature is higher than that, we can also calculate and find get an idea of how much refractory is remaining inside. So thermography images are good indicators of showing whether a hotspot is imminent or the temperature profile is normal, above normal. So it gives you an idea of what is the condition of the refractory inside. This is also a very common tool used nowadays. So there are different models of thermal imaging cameras available today, from very specialized to small handheld ones. So we can choose and we can choose the model equipment and then create reports as and when necessary. This is also an important ongoing assessment tool for refractory lines. Third image which I mentioned is a laser scanning. Now, laser scanning is also a very interesting area of online health assessment of refractory lines. A very common application for laser light scanning is steel melt shop, ladles and converters. My presentation will not cover today because that's a subject which I used to deal in my previous company. When I was working in Vesuvius, we had a company within the group called Process Metrics, and we used to do laser scanning of converters and ladles. And Vesuvius is one of the specialized companies doing that. Mintech Ferrotron is another company globally, and these are the two major ones to having technologies of laser scanning for steel melt shops. And you can get to their websites, Vesuvius website or the Ferrotron website, and they have a section where you can see how this there. So there are both mobile units and as well as mounted units. For converter, there are mounted units and there are mobile units. For ladles, they basically these units are basically fixed to a jeep crane sort of system over the ladle repair stand, where after every tap, a laser scanner comes, highly specialized, developed by these companies, and then it can very quickly take a scan of the refractory lining inside and then compare it with the original initial lining profile and tell what is the exact refractory contour inside. It's a very scientific method, highly advanced, and very commonly used in the industry nowadays. All major steel producers today have laser scanners installed in their steel melt shops. So you can get into the websites and have some further insight if you are interested on the subject of these two companies. But the image that you are seeing on the screen right now is something which Possible does. I mean, we do laser scanning in coconuts. So there is a hardware there is a scanner equipment which is put on the cocoon bench. This is a cocoon platform, and you can see the cocoons here. These are vertical slotted ovens with recovery type large ovens which are present in all integrated steel fronts, and we can actually shoot laser beams through both sides of the ovens, and these can be then analyzed using specialized software specially made for cocoon analysis. Because cocoa oven and ladle converter, the geometries are drastically different. It's a cocoa ovens are narrow, rectangular chambers, very tall, very long, but width is very low. So the laser, the software is designed based on specialized targeted for cocoa analysis, and then it can give a highly detailed profile of the refractory, bulging, narrowing of the walls, and also where there is any depression in the wall, in the silica heating wall somewhere. Based on this, then we can plan further corrective action, maintenance, preventive maintenance action, or whatever action is required can be planned. So laser scanning is today another very important technology for online health assessment of refractory linings in different vessels. Steel melt shop is very common. Coke oven is also picking up now because coke ovens are getting older, and then people want to know what are the conditions. In fact, very recently we did some laser scanning of ovens in Tata Steel Jamshedpur in the coke oven battery number 10 and 11. So this is also one technology. So I think this basically gives an overview of the technologies available for assessment. Now, what do we do with this assessment? We have a plan repair, right? Now, am I clear up to this point? Anybody who is there, if there are any questions at this point, or we want to take some questions at the end, what do you want? Question at the end, right? Okay, keep. Right. So till now, what I presented, I think I tried to give you a gist of some of the technologies available for online health assessment. Now, briefly, because the time is short, I think maybe about 10 minutes more I will try to finish. Now I will talk about what do we do with this assessment. So the main purpose is that first to know about how the refractory is inside, so that we have peace of mind, we know, and we can plan for maintenance activity. Now maintenance can be of two types. Normally, people can plan based on this. The furnace operators can plan that how much material will be required for their next shutdown, which zone is to be repaired. So proactive planning can be done. And second is a more popular method nowadays, slowly becoming more and more popular, is if the repair is of not a scale which warrants a shutdown, Then today there are various methods available for online repair, refractory repair in hot condition of the furnace. The main two industries where hot repair was invented was glass and cocoa, because silica bricks, which are main lining materials for cocoa and construction and glass tank furnaces, cannot be cooled down. And it's a very tricky subject to cool down at silica refractory, and the heating up is also has to be very slow. So silica refractories need to be in high temperature. Like a cocoa oven, when it is commissioned, it operates for years together. They are not shut down unless and until it is absolutely necessary. So repair of these furnaces are predominantly done when the refractory is still hot, above 600, 700 degrees centigrade. So ceramic welding is a process which was invented by Fosbel. This company where I work for, that they invented this technology about 40 years back in Europe, and then this has become one of the major technologies for hot repair of silica brick linings in cocoa ovens and glass furnaces. Basically, in ceramic welding, what happens is you can read about it. A lot of literature is available in our website and some things. Predominantly, it is a method where refractories are welded. So it's not a gunning, it's not a superficial coating. It's basically where the substrate refractory which is damaged. On that, we send in a refractory powder of compatible material. Like if you are welding silica bricks, the powder is also made of silica refractory. Goes into a stream of oxygen at high temperature, impinges on the damaged portion, and then there is an exothermic reaction. There is some fuel inside this powder, which ignites in the oxygen and has an exothermic reaction which melts both the base refractory and the powder, and they stick together. So this is what is the fundamental principle of ceramic welding. That's why it's called ceramic welding, where two ceramic materials weld together, and then any small joints or gaps can be seen. So, so you can see a ceramic welding happening in a cocoa oven, which is still hot. I mean, the coke has been pushed out, the furnace, the oven is hot, and we are welding from outside. And these repairs, nobody gets inside the furnace. It's all done from outside. The lance goes inside, and the repair happens, and we can do the repair from outside. So there are some processes involved. The surface has to be prepared to remove loose particles before done. We do it through a process with a special surface preparation machine and material, and then the actual welding takes place. And then there are different repair materials, like for silica bricks we have silica welding material, for alumina bricks we have alumina welding material, for basic bricks there is basic alumina welding material. So different compositions of ceramic welding products are available. You can see some ceramic welding happening through long water cooled lance. Deep inside the oven, the lance has to go carrying the powder and oxygen at a which has to be water cooled and with special supporting systems. Otherwise, a cocoa oven inside, the middle of the oven will be at more than 1200, 1300 degrees centigrade temperature. So the repair happens in that temperature. So there needs to be a special lance arrangements which we provide. So this is a deep oven welding using water lance. This is cocoa oven sole welding. The sole is damaged. Again, very long lance goes inside, and then there is a welding happening. You can see the exothermic reaction here. So these are some images of ceramic welding in cocoa oven. But ceramic welding is not restricted to cocoa oven, right? Any type of industrial furnace where a refractory has to be repaired in hot condition, welding can be done. So I will give you an example today now. This is again a hole in a cocoa oven wall which has been patched with refractory zero expansion silica bricks and then welded over. You can see it has been covered with ceramic welding in here. This is an example of cocoa oven wall damage before repair and after ceramic welding repair. You see the damages are all welded together. We give a weld coat on top of which, where the welding mass has become fused with the refractory. It is a single mass now, it's not a coating. It has become part and parcel of the line. And you can see the furnace is still hot inside. So these are some examples of ceramic welding done in cocoa oven walls. This is a video I will play. Let me see whether the video plays well or not. Right, just a minute. Just give me a minute. I will try to play the video. I think it should play. Is it playing? the video? You can see this is a basal mill ceramic welding done from outside. Blast furnace basal mill. This lens is carrying the ceramic welding powder and oxygen. We will not be exactly able to see that space, but these are complex processes to happen, and we can do it, and after the repair is done, we will send an endoscope and take an image to see whether that area has been properly welded or not. The right side is also a stove refractory. This is a blast furnace stove dome, and there is a ceramic welding happening. The lance has gone inside. You can see it's hot. I mean, flames are coming. So the person standing will have personal protective equipment to protect against heat. And this lance has gone inside and welding. And this is an example of a combination of endoscopy and ceramic welding. See, some process vessels you need to see live during the repair. I will give you an example. I will play this video. You can see this is a burner port which is still firing. This burner port where the arrow cursor is, the flame is on. The pellet bucket is moving here, and this burner you can see in the corner this welding is going on. And the welder who is doing the welding is seeing in his laptop placed in front of him through an endoscopic video camera placed on the other side of the burner port. We have put a camera from one side of the port, taking an image, and the opposite burner port, a welder is welding from outside and seeing in his laptop screen where the welding is happening. In this corner, the welding is happening. You can see the weld mass welding the refractory here, and it is seeing live during the repair, so the welder can maneuver his lance by seeing this image. So this is a combination of this endoscopy and as well as ceramic welding combined, seen in a live picture. And the ceramic welding person who is doing the repair is seeing this live on his laptop screen placed next to him. So I think I have talked enough about welding. Then I will quickly talk about one more technology of hot repair before I conclude. It is called hot gunning. Like gunning and shot fitting, many of you would have heard. It is a predominant technology for again cold repair, cold shutdown. But today there are modern gunning materials available for hot gunning also. I mean, you can gun certain applications, do a repair by gunning in hot condition. For example, coke oven also. There are major damages, like you can see, this is a coke oven wall badly damaged. This cannot be fixed by welding. Ceramic welding is too, I mean, it's basically a preventive maintenance technique, but this is beyond preventive maintenance. This is now breakdown maintenance or sort of remedial maintenance stage, where ceramic welding will not be effective, and we need to have a very fast bulk repair method, where we can today repair from outside the furnace by a hot gunning method, so by specialized materials, delivery techniques, where large damages can be fixed in hot condition by special gunning delivery methods. We have this technology called fast gun FSA, which is for coke oven wall repair technology, which is a combination of material and also the equipment. So you can see a video of a coke oven wall being hot gunned. You can see the right side one. You can see the furnace is hot, but we are building this gunning, the refractory lining in hot condition. Otherwise, this coke oven would have to be taken for a very long empty oven, and we have to do a brick repair, which is very, very time consuming. And unsafe also, because hot masons have to get inside the furnace. Here the entire job is being done from outside. And there is a big hole. You can see there is a big hole in the refractory lining here. So which is now being filled with gunning. So this is a hot repair technology, like ceramic welding. Anyway, I will not, and there is a finishing. A person is finishing continuously because the surface, the wall has to be flat. So as soon as the gunning is happening, continuously another person is finishing this lining, but from outside, not from inside. And we also use scissor lifts. As you can see, there are we can use scissor lifts, which you can see from the left-hand video, where the person is standing on a lift, electrically operated lift, from outside and doing this welding. So there are different. This is another technology of hot repair. So I think this is all I wanted to quickly share, that some assessment tools and some sort of what I would call some hot repair technologies today which are available to continuously monitor as well as repair furnaces without the need to shut them. And this is a very big incentive for the furnace operators. Today, nobody wants to shut down their furnaces. Like a pellet plant, a shutdown can cost crores in any process industry. So, if there is a possibility of doing a repair online, today there is a lot of preference for that, and that is where we specialize. I also specialize in online repairs. So that's what I wanted to give you a gist about. So that's all. I think I will conclude now, and if there are any questions, we can discuss, or I am also available. My number is there with the college. If you are anybody of you are interested to discuss any specific subject, I can come. I can talk and maybe give you further inputs. But in this time, this is what I could cover. So thank you.
A really informative session. We got to learn a lot. Sir, I have a question. Like in the ceramic weld mixtures, you said that a refractory material is included along with fuel, and that reacts with oxygen to produce the heat. So, sir, usually what kind of a fuel would be used? Like, would it be something organic, or would it be like metallic powder or something?
No, these are metallic powders. Yeah. And we manufacture these powders. I mean, these are today manufactured in different parts of the world. Our plant is located in Mysore, in India, where we make these ceramic welding materials for application. But a very important part of the ceramic welding technology is not only the material but also the machine, which we develop ourselves. I mean, our machines are made by Fosbel. I mean, we make our own ceramic welding machines, and the lunch delivery systems, because the lunch is very important. How they are cooled, what is the cooling system, the design of the lunch, because they need to travel long distance inside hot furnaces, and trained personnel. So these are three important components of the technology. It is the material, it is the equipment, the design of the equipment, the safety features of the equipment, because sometimes oxygen can backflow and there can be the oxygen. So there has to be certain safety features we call system reaction eliminator, SRE, so which are inbuilt in our machines. And also third component is very experienced welders to operate these machines. So these three are the important components of this technology. So if there are no further questions, I think we can conclude, and then if any one of you have anything later on, you can maybe send across some query to me through the student chapter of InCerS Ceramic Society, and I try to answer by email, or I can call and discuss. Yeah? Okay.
Interactive segment, we would like to invite all our esteemed speakers to kindly join us on the stage.
আমাকে বলা হয়েছে বাংলায় কথা বলতে, তো বাংলায় বলতে হবে, এবং কোশ্চেন বাংলাতেও জিজ্ঞেস করতে পারো।
Hello, good evening, sir. My name is Shomoli Mondal, and I am a third year student from Ceramic Technology Department. So my question is that refractory raw materials plays a crucial role in refractory manufacturing. So my question is that what are the future challenges for the refractory raw materials availability?
Refractory raw materials কি আছে first of all?
Actually, it varies from refractory to refractory. Like for silica, we use quartz. For aluminum varies actually.
First of all, if you যদি categorize করা যায়, two kind of raw material. One is natural occurring raw material, and another one is synthetic raw material, right? Okay, এখন natural occurring raw material কে যদি তুমি bifurcate করো, then acidic, neutral, basic, right? তিনটে ক্যাটাগরি আছে। এখন যদি দেখা যায় তুমি যে চ্যালেঞ্জটা বলছো ওটা কি ইন্ডিয়া অনলি ইন্ডিয়া স্পেসিফিক না গ্লোবাল?
গ্লোবাল।
ওকে, তো গ্লোবালি যদি বলা যায় তাহলে অ্যালুমিনা, যদি আমরা মেন র মেটেরিয়াল কি মানে একটা হচ্ছে লোয়ার এন্ডে যেতে গেলে ক্যালসাইন মানে ক্লে, হ্যাঁ, নন প্লাস্টিক ক্লে যেটা আমরা ক্যালসাইন করে নিই, ঠিক আছে, এনাফ অ্যাভেলেবেল। তুমি যদি আমাদের ইন্ডিয়াতেও আছে, আমরা বাইরেও আছে, কোনো অসুবিধে নেই। এখানে একটা প্রপার্টি ক্রিটিক্যাল যেটা সব ক্লেতে আসে না, দ্যাট ইজ কার্বন মনোক্সাইড ডিসইন্টিগ্রেশন। এবং সেই প্রপার্টিটা আসে কিসের জন্যে? তার মেন কন্ট্রিবিউটার হচ্ছে এগেন ইট ইজ ক্লে অর মেবি র মেটেরিয়াল, বিট ক্লে অর বিট মোলাইট বা অন্য ডায়াসফোর অ্যান্ডালুসাইড, যাই হোক। তো বেসিক্যালি তার মধ্যে কি ইম্পিউরিটিস আছে? মোস্টলি আয়রন, ফ্রি আয়রন বিকজ অফ কার্বনিল কম্পাউন্ড ফর্মেশন উইথ কার্বন মনোক্সাইড, আর নাহলে অ্যালকালি। ওকে, তো চ্যামট বা ক্লে এই টাইপের র মেটেরিয়ালের কোনো অ্যাভেলেবিলিটি ইস্যু নেই, ওকে, আমাদের তো জানা নেই। এবং র ক্লে যেটা প্লাস্টিক ক্লে ইন্ডিয়াতে অ্যাবান্ডেন্টলি অ্যাভেলেবেল। আমাদের ক্ষেত্রে একটাই হচ্ছে যেটা সুপার প্লাস্টিক ক্লে বেন্টোনাইট টাইপের মেটেরিয়াল, আমাদের সোর্স অনেক হাই আয়রন, তো সেটা বেনিফিসিয়েশন কিছু করে এবং অন্যান্য ইন্ডাস্ট্রিতে ইউজ হয়, সেটা নেওয়া যেতে পারে। দেন ক্লের ওপরের দিকে ব্যাপারটা হচ্ছে যে নেক্সট ক্যাটাগরি হচ্ছে কায়নাইট, ঠিক আছে। এবং কায়নাইট যদি তুমি দেখো র মেটেরিয়ালের দিক থেকে, ইন্ডিয়াতে কায়নাইট বলে ট্রু কায়নাইট পাওয়াটা রিয়েলি ডিফিকাল্ট, বিকজ যদি তুমি মিনারোলজি দেখো, এবং মিনারোলজিতেই ধরা যাবে এক্সপানশন। নর্মালি আমরা কাইনেটকে ক্যারেক্টারিস্টিক্স করি কি, আমরা ফায়ার করে এক্সপানশন দেখি, মুলাইট হয়, বাল্ক ডেন্সিটি চেঞ্জ হয়, এক্সপানশন হয়, ভলিউম বাড়ে, রাইট। কিন্তু সেটা কোয়ার্জের থেকেও হতে পারে। এবং অনেক কাইনাইট আমরা পাই যেটা যদি মিনারোলজি দেখি ইট ইজ কোয়ার্জ, দো উই আর গেটিং এক্সপানশন বাট ইটস নট ট্রু কাইনাইট, রাইট। সো ট্রু কাইনাইট কিছু সাউথের সোর্স আছে, সেখান থেকে কিছুটা আসে, বাট দ্যাট ইজ অলসো হ্যাভিং হাই আয়রন। এবং তোমাকে যদি কাইনাইট লো আয়রন করতে হয় তাহলে ইম্পোর্ট করা হয়, এবং সি মিনারেলস ইউএস এখান থেকে কাইনাইট কিছুটা আসে। দেন কামস অ্যান্ডালুসাইড। অ্যান্ডালুসাইড আমাদের এখানে নেই এবং গ্লোবালিও খুব রেস্ট্রিক্টেড জায়গায় পাওয়া যায়, মোস্টলি সাউথ আফ্রিকার সোর্স থেকে অ্যান্ডালুসাইড আসে, ঠিক আছে। এবং অ্যান্ডালুসাইডে কিছু স্পেশাল প্রপার্টি আছে যার জন্য ইম্পোর্ট করে, গ্লোবালি সেখান থেকে ইম্পোর্ট করা হয়। গ্লোবালি অ্যান্ডালুসাইড মোস্টলি আফ্রিকান, সাউথ আফ্রিকান কান্ট্রিজ থেকেই আসে। ডায়াসফোর এর ওপরে যেটা হচ্ছে মোস্টলি পাওয়া যায় না, ওটাকে আর আমরা এখন ভাবিও না। দেন পয়েন্টটা হচ্ছে যে ন্যাচারাল অকারিং আমি বলছি। দেন হচ্ছে যে তোমার নেক্সট হচ্ছে বক্সাইট। তো ইন্ডিয়ান বক্সাইট যেটা হচ্ছে, আমি যদি ক্যালসাইন করি, কেন বক্সাইট তো র ইউজ করা যায় না রিফ্র্যাক্টরিতে, যদি আমি ক্যালসাইন করি তাহলে কী ধরনের অ্যালুমিনা পাবে? আমরা যে ইন্ডিয়ান বক্সাইট পাই, ইন্ডিয়ান বক্সাইটের এখন মোটামুটি 78 থেকে নিয়ে তোমার ইভেন 76, তোমার কিছুটা মধ্যপ্রদেশের রেঞ্জে কিছু বক্সাইট আছে যেগুলোকে ক্যালসাইন করে 76, 77 আয়রন পাবে উইথ হাই টাইটেনিয়াম, টাইটেনিয়াম অক্সাইড কিছু বেশি থাকে। আর যদি তুমি অ্যালুমিনা দেখো ইট উইল বি 76 to 82%, ওকে। বাট এখানে ডিপোজিট ওয়াইজ ইম্পিউরিটি ভ্যারি করে। গুজরাট রিজিয়নে যদি যাওয়া যায় তাহলে ক্যালসিয়াম অক্সাইড অনেক বেশি থাকে, টু দ্য টিউন অফ সে 1.5 to 2.5, এবং ক্যালসিয়াম অক্সাইড আমাদের জন্য ডেট্রিমেন্টাল, রাইট। এছাড়া যদি তুমি মধ্যপ্রদেশের দিকে দাও তাহলে আয়রন টাইটেনিয়া বেশি থাকে, এবং সেটাও তোমার ব্রোকাইট বা ওই ধরনের ফেস ফর্মেশন থাকে, যেটাও অ্যাজ সাচ লো আয়রনে টায়ালাইট ইজ এ গুড ইফেক্টিভ র মেটেরিয়াল, দ্যাট ইজ অ্যালুমিনিয়াম টাইটানেট। বাট যখন তুমি আয়রন বা ওই অ্যাপ্লিকেশন এনভায়রনমেন্টে আসো তখন কিন্তু সেটাও একটা চ্যালেঞ্জ হয়ে যায়। তো ভালো কোয়ালিটি বক্সাইট বলতে গ্লোবালি আমরা যেটা ইম্পোর্ট করি, চাইনিজ বক্সাইট আছে যেগুলোতে আয়রন কন্টেন্ট মানে আয়রন অক্সাইড কন্টেন্ট মোটামুটি 1.82 এর মধ্যে রাখা যায়, লাইম মোটামুটি 1-এর তলাতেই থাকে, অ্যান্ড অ্যালুমিনা 85, 86, 88 মোটামুটি পাওয়া যায়। আর একটা হচ্ছে তোমার গুয়ানা সোর্সে যে বক্সাইটটা আসে, দ্যাট ইজ হ্যাভিং ডিফারেন্ট নেচার। গুয়ানা বক্সাইট ইজ মুলিটিক নেচার, আর ওখানে তোমার অ্যালুমিনা ইভেন ইউ ক্যান গো আপ টু 89% অলসো, আয়রন কন্টেন্ট ম্যাক্সিমাম 1%। তো এগুলো এখন অ্যাভেলেবেল, এগুলোতেও প্রবলেম নেই। তো সেরকম চ্যালেঞ্জ বলতে অনলি তোমার মানে ট্রান্সপোর্ট লজিস্টিক is going to মানে এখন প্রেজেন্টলি একটা বড় তোমার চ্যালেঞ্জ বিকজ অফ ইউ নো দ্যাট মিডল ইস্ট ক্রাইসিস অ্যান্ড আদার থিংস। সিনথেটিক র মেটেরিয়াল যদি বলা যায় তাহলে ইন্ডিয়াতে আমাদের সিনথেটিক র মেটেরিয়াল মানে আমরা পাই যে আমরা সিনথেটিক মোলাইটও কিছু পাই লোকাল অ্যাভেলেবেল, আমরা সিনথেটিক কিছুটা ব্রাউন ফিউজড অ্যালুমিনা, হোয়াইট ফিউজড অ্যালুমিনা, হোয়াইট ট্যাবুলা সবগুলি তোমার ইন্ডিয়াতে অ্যাভেলেবেল, রাইট। আমাদের মেজর প্রবলেম হচ্ছে ম্যাগনেসাইট, এবং ম্যাগনেসাইট মাইনিং পারসে সেরকম হয় না, এবং আমরা ডিপেন্ডেন্ট মোস্টলি চাইনিজ সোর্সের ওপরে, নাহলে তার্কিতেও ম্যাগনেসাইট থাকে, আর নাহলে ব্রাজিল, দিস থ্রি, অ্যান্ড কিছুটা অস্ট্রেলিয়াতেও আছে, কিউম্যাক কিছুটা অস্ট্রেলিয়ান সোর্সও আছে। তো ম্যাগনেসাইট আমরা ইন্ডিয়াতে যদি বলা যায় অ্যান্ড গ্লোবালি অ্যাভেলেবল অ্যাট এ কস্ট, অ্যান্ড ইন্ডিয়া পারসে উই আর হেভিলি ডিপেন্ডেন্ট অন ইম্পোর্ট, ওকে। অ্যান্ড ফিউজ ম্যাগনেসাইট বলো, সিন্টার ম্যাগনেসাইট বলো, আমাদের ইন্ডিয়াতে নিজেদের কিছু সেরকম নেই। অ্যালুমিনা, ক্যালসাইন্ড অ্যালুমিনা, দিস ইজ অলসো সিনথেটিক মেটেরিয়াল যেটা আমরা ইউজ করি, এবং ক্যালসাইন্ড অ্যালুমিনাও আমাদের কাছে আছে, হিন্ডালকো সোর্স আছে, এবং ইম্পোর্ট করেও আমরা নেওয়া হয়। চাইনিজ অ্যালুমিনাও অনেক কিছু আসে, অনেক চাইনিজ অ্যালুমিনা সোর্সও আসে, তো দ্যাট ইজ অলসো অ্যাভেলেবেল। তো আমার মনে হয় র মেটেরিয়াল অ্যাভেলেবেল, অনলি থিং প্রসেসিংয়ের টাইম বা ট্রান্সপোর্ট টাইম বা লজিস্টিকের কস্ট, এইটা একটা চ্যালেঞ্জ, যার ফলে তোমার ওভারঅল একটা কমার্শিয়াল ইম্প্যাক্ট বেশি থাকে। আর ন্যাচারাল অকারিং র মেটেরিয়ালের মধ্যে আমাদের এখানে ম্যাগনেসাইট নেই, দ্যাট ইজ অলসো একটা চ্যালেঞ্জ, মানে আছে কিন্তু আমরা এক্সপ্লোর করি না, বা মাইনিং কিছু কনস্ট্যান্ট আছে, আর বক্সাইটের কোয়ালিটি ডিটেরিয়েশন হচ্ছে। তো মেবি এটাই আমি তোমাদের বলতে পারি, আর যদি কিছু তোমার কোশ্চেন থাকে জিজ্ঞেস করতে পারো।
থ্যাংক ইউ।
Good evening, everyone. My name is Akash. I am a third year student of Civil Technology Department. Sir, my question is that how is the recent gas crisis affecting on the refractory industry? Sir, যেমন আমরা যে এখন শুনেছি ডিজাইনার যে গ্লাস প্যান্ট আছে ওরা নাকি ফুয়েল কনজাম্পশন কমানোর জন্য সোলার গ্লাস এরকম টাইপের গ্লাস ইনভেন্ট করছে। সো রিফ্র্যাক্টরি ইন্ডাস্ট্রি থেকে ফুয়েল কনজাম্পশন কমানোর জন্য কী করা যেতে পারে, বা এই যে গ্যাস ক্রাইসিস এটা কী করে এফেক্ট করছে?
রিফ্র্যাক্টরি ইন্ডাস্ট্রিতে সোলার অনেক আগে থেকেই এসছে, যেমন ক্যালোরিজের প্লান্টের মধ্যে কাটনিতে আমরা সোলার ইউজ করি টু দ্য টিউন অফ 40%-এর মতো আমরা ওখানে ইউজ করি, এবং এটা সাস্টেনেবিলিটি বা তোমার এনভায়রনমেন্টাল ফুটপ্রিন্ট বা কার্বন ফুটপ্রিন্টের সাথে ডিপেন্ড করে, ঠিক আছে। বা ইন্ডিয়াতে এত ভালো সামার থাকে, সুতরাং সোলার, উইন্ড এনার্জি, মানে এই ধরনের এনার্জি সোর্স অনেক বেশি অ্যাভেলেবেল। আর কামিং ব্যাক টু এই যে ক্রাইসিস, মিডল ইস্ট ক্রাইসিস, তাতে গ্যাসের ওপরে খুব এফেক্ট আছে। তোমরাও দেখতে পাচ্ছ যে কোনো গ্যাস স্টেশনে লম্বা লাইন পড়ে। লিকুইড ফুয়েল চ্যালেঞ্জ আছে, দাম বাড়ানো, মানে দাম বেড়েছে, আরও বাড়বে আশা করা যায়, প্রাইসটা বাড়বে, কেননা আমাদের কিছু ইম্পোর্ট করা হতো বা এখান থেকেও কিছু এক্সপোর্ট হয়। বাট আমার মনে হয় যেখানে আমরা সাস্টেনেবল ইয়ের জন্য, যেখানে আমরা গ্যাস বেস মানে আমাদের ফুয়েল সিস্টেম ছিল, ক্যালোরিজেরও কিছু প্লান্টে আছে, সেখানে ফর দ্য টাইম বিং ডিফিকাল্টি আছে, সেখানে অল্টারনেট ফুয়েলের দিকে আমাদের যেতে হচ্ছে, যেমন অয়েল বেস আমরা যেটাকে করতে চাইতাম না। ইট হ্যাজ সাম এনভায়রনমেন্টাল এফেক্ট, গ্যাসের মতো ক্লিন নয়, বাট যখন গ্যাসের এই অবস্থা তখন ফর দ্য টাইম বিং এইভাবেই করা হচ্ছে। আর একটা জিনিস হচ্ছে গ্যাসে তোমার মিনিস্ট্রির থেকে কিছু আমাদের যেগুলো বেসিক্যালি আমাদের কোল তো মোটামুটি ডিগ্রেড বা এই ধরনের কোল, ওইখান থেকে আমার মনে হয় মিনিস্ট্রি অফ মাইন্সের থেকে ওখান থেকে কিছু গ্যাসিফিকেশন ইউনিট চালু করা হচ্ছে, মানে যেটা কিনা ওই মানে ইম্পিওর কোল থেকে সেটাকে গ্যাসিফাই করে কার্বন মনোক্সাইড, হাইড্রোজেন, সিন গ্যাস এইটাকে দিয়ে, এবং এই ধরনের গ্যাসকে যদি সাপ্লাই করা যায় ইন্ডাস্ট্রিতে। তো চ্যালেঞ্জ আছে, গ্যাস ইজ এ চ্যালেঞ্জ, বাট দেয়ার আর সাম মিটিগেশন দ্যাট উইল হ্যাপেন ইন দ্য মেবি within a few years. So for the time being you have to go on liquid fuel or maybe solar, other things. এলপিজি তো এখন প্রচণ্ড কস্টলি, কারণ এলপিজি তো এখন কস্ট অনেক বেড়ে গেছে। কস্ট এফেক্টিভ মানে আগের থেকে তো এটারও দাম বাড়বে, বিকজ পেট্রোল বাড়ছে, ডিজেল বাড়ছে, সবই ফুয়েলের দাম বাড়ছে, সুতরাং দাম সবেরই বাড়বে। কস্ট এফেক্টিভ বলতে এলপিজি পাওয়াই যাচ্ছে না, সব জায়গাতেই রেশনিং হয়েছে, ঘরের ডোমেস্টিক ফুয়েলও রেশনিং আছে, ইন্ডাস্ট্রিতেও প্রায় 70-80% রেশনিং করে রাখা হয়েছে। সুতরাং এখন তো তোমাকে চালাতে হবে, বিকজ কাস্টমারকে তো অর্ডার এক্সিকিউট করতে হবে। কস্ট এফেক্টিভ আজকের দিনে হবে না, এলপিজি রেসপেক্টে হবে, কিন্তু ওভারঅল আগে যদি তুমি কস্ট যা ছিল আর এখন দেখো, তাহলে কিন্তু তোমার কাছে কস্ট এফেক্টিভ হবে না। ইট উইল বি অ্যাট ইনক্রিজ কস্ট, বাট ইউ হ্যাভ টু সাপ্লাই, বিকজ ইন্ডাস্ট্রি তো থেমে থাকবে না, তাতে সাপ্লাই করতেই হবে।
থ্যাংক ইউ সো মাচ স্যার।
সব কোশ্চেন ওদিক থেকেই আসছে, আগে থেকে সব তৈরি আছে মনে হচ্ছে, ওদিক থেকে কোশ্চেন আসছে না।
গুড ইভিনিং স্যার।
গুড ইভিনিং।
আমার নাম প্রেরণ ঘোষ, তো আমি ফার্স্ট ইয়ার স্টুডেন্ট। তো আমাদের রিফ্র্যাক্টিভ ইন্ডাস্ট্রিতে কাজ করার জন্য এখন যে কী কী বিষয়ের উপর ফোকাস করতে হবে, স্ট্রং করতে হবে কোন কোন বিষয়?
ফার্স্ট অফ অল তুমি রিফ্র্যাক্টিভে থাকবে, আর ইউ শিওর? না, এখন ওপেনিং অনেক আছে, রিফ্র্যাক্টরি আর গ্লাস। তুমি আজকে সেমিনার নালে রিফ্র্যাক্টরি বা রিফ্র্যাক্টরি অ্যাপ্লিকেশনের উপরে হয়েছে, সিমিলারলি গ্লাস অলসো ভাস্ট লাইন। আমাকে সকালে কেউ আনতে এসেছিল, তো ও বললো যে আমি গ্লাসে থাকতে চাই। তো অনেক এরিয়া আছে, আর নট অনলি রিফ্র্যাক্টরি গ্লাস, ইউ হ্যাভ হোয়াইট ওয়্যার, আদার ইন্ডাস্ট্রিজ অলসো, মডার্ন সিরামিক। আর রিফ্র্যাক্টরিতে যদি থাকার ইন্টারেস্ট গ্রো করে, ফার্স্ট অফ অল আমি বলবো না থাকতে হলে, তোমার যদি ইন্টারেস্ট গ্রো করে, বিকজ তুমি থাকবে কি থাকবে না সেটা তোমার ওপরে। ফার্স্ট অফ অল ইউ উইল হ্যাভ টু ফিগার আউট ইউর ওন এরিয়া অফ ইন্টারেস্ট। যদি তোমার রিফ্র্যাক্টরিতে থাকার মনে হয়, তাহলে আমি বলবো রিফ্র্যাক্টরি র মেটেরিয়াল জিনিসটা ভালো করে প্রথমে, মানে ইউ হ্যাভ টু টেক কন্ট্রোল অন দ্য র মেটেরিয়াল, বিকজ রিফ্র্যাক্টরি ইফ ইউ সি 70-80% ডিপেন্ড অন দ্য র মেটেরিয়াল। এবং কামিং ডেজে এই যে র মেটেরিয়ালের ক্রাইসিস হচ্ছে, ইমপিওর হচ্ছে, অনেক ইম্পিউরিটির এফেক্ট থাকছে, কোন ইম্পিউরিটির এফেক্ট কীভাবে এটার মানে আমার এন্ড প্রোডাক্টে কি এফেক্ট করতে পারে। তো র মেটেরিয়াল, ইন ডেপথ নলেজ অ্যান্ড রিফ্র্যাক্টরি প্রপার্টিস, বেসিক প্রপার্টিস, এইগুলোর উপরে বেশি ফোকাস করা ভালো। এফেক্ট অন ইয়োর ইম্পিউরিটিস অন রিফ্র্যাক্টরি প্রপার্টিস, কোন অ্যাপ্লিকেশনে কোন ধরনের প্রপার্টি লাগবে, বা কোনো হাইব্রিড সিস্টেম, মেটাল রিফ্র্যাক্টরি কম্পোজিট কীরকম বিহেভিয়ার হবে, দ্যাট ইজ ফ্রম দ্য ম্যানুফ্যাকচারিং সাইড। বাট এই যে আমরা শুনলাম আজকে, এগুলো আমার মনে হয় তোমরা আগেও জেনেছো বা নেটের থ্রু দিয়ে অনেক খবর আছে। বেসিক্যালি সি ওয়ান ইজ ইয়োর প্রোডাক্ট, বাট আলটিমেট কাস্টমার স্যাটিসফ্যাকশান, যেটা কিনা সবাই আমরা তার জন্যই কাজ করি ইন্ডাস্ট্রিতে, করা উচিত পারসে, সেটা ডিপেন্ড করে 50% অন প্রোডাক্ট, ওকে। রেস্ট 50% ইট ইজ ডিভাইডেড বাই ইয়োর সার্ভিস or maybe that actual process condition, how they are using it. একটা সাইকেল, সিম্পল এক্সাম্পল, সাইকেল আমি এমন করেও চালাতে পারি যে সাইকেলটা খারাপ হয়ে যায়, এমন করে চালাতে পারি বছরের পর বছর সাইকেলটা চলতে থাকুক, ঠিক আছে। দ্যাট ডিপেন্ডস অন দ্য ইন্ডিভিজুয়াল, কে চালাচ্ছে সাইকেল, কীভাবে চালাচ্ছে, কতখানি ধাক্কা লাগছে, কীভাবে কী হচ্ছে, রাইট। তো প্রসেসের ব্যাপারটাও নলেজটা ধীরে ধীরে রাখতে হবে। তিনটে জিনিস মিলিয়ে টোটাল কাস্টমার স্যাটিসফ্যাকশান আসে 360 ডিগ্রি। ওয়ান ইজ প্রোডাক্ট কোয়ালিটি, রিফ্র্যাক্টরি প্রোডাক্ট কোয়ালিটি। সেকেন্ড ওয়ান ইজ বেসিক্যালি দ্য সার্ভিস, কীভাবে লাগাচ্ছ। কারণ আজকের দিনে যেটা দীপঙ্করও বলছিল যে কেউ ডাউন টাইম দিতে চায় না, তার মানে কি তোমাকে মিনিমাম টাইমে অপারেশন রিস্টার্ট করতে হবে, ঠিক আছে। তার ফলে কি দরকার, এবং মধ্যেখানে কোভিড হয়ে গিয়েছিল, কোভিড থেকে আমরা কি পেয়েছি, আমাদের ম্যান পাওয়ার অ্যাভেলেবিলিটি ইজ এন কনস্ট্যান্ট দেয়ার, ঠিক আছে। তার মানে লট অফ থিংস আর মেকানাইজড নাও। ওয়েল্ডিং দেখলাম, রিফ্র্যাক্টরিতে আমরা অনেক কিছু শর্টক্রিট বলে একটা আমাদের টার্মিনোলজি আছে, আমরা শর্টক্রিটিং করি। শর্টক্রিটিং করা মানে ইটস এ ফ্রম কংক্রিট, ব্যাপারটা এসছে। আমি গ্রাউন্ড ফ্লোরে মিক্সিং করব, মেটেরিয়াল লাগাবে 100 মিটার ওপরে, মনে করো সিমেন্ট প্লান্টের একদম সাইক্লোন টপ, সেখানে আমি ইনস্টল করব। পুরো জিনিসটা আমাকে ফ্লো করে নিয়ে যেতে হবে, জাস্ট ওখানে স্পটে গিয়ে জাস্ট ইনস্টল হবে উইদাউট এনি শাটারিং, ওকে। তো এই যে মেকানাইজড ওয়ে অফ ইনস্টলেশন, এটা নিয়েও নিজেদের স্টাডি করে দেখতে হবে, বা তোমার মনে করে যে স্ক্যানিং বা এই জিনিসটা হলো, আজকেও ওয়েল্ডিংয়ের কথাটা বললো যে মোস্টলি কোকোভেন বা এইসব সাইডে হয়, ওয়াই নট ইন আদার সেক্টরস? তোমার আজকে সকালে আমরা স্পঞ্জ আয়রনের কথা বলছিলাম, হাইলি ডিমান্ডিং রোটারি ক্লিন, কিন্তু আজকের দিনেও কোনো হট রিপেয়ারিংয়ে কোনো ব্যবস্থা নেই। স্পঞ্জ আয়রনে ক্লিন, রোটারি ক্লিন ডাউন করে, সেখান থেকেই তোমাকে রিপেয়ার করতে লাগে, ঠিক আছে? তো এটা প্রোডাকশন লস। এবং স্পঞ্জ আয়রন মানে অনেক, এটা হিউজ ডিম্যান্ড। তো আমার মনে হয় তোমার রিফ্র্যাক্টরিতে যদি ইন্টারেস্ট গ্রো করে, র মেটেরিয়ালের দিকে নিজে স্টাডি করার চেষ্টা করো, রিফ্র্যাক্টরি প্রপার্টির দিকে স্টাডি করার চেষ্টা করো, কী প্রপার্টি কীভাবে বিহেভ করছে, এবং মেকানাইজড অ্যাপ্লিকেশানে কীভাবে তুমি চিন্তা করতে পারো, কীভাবে তুমি মানে কাস্টমারের হিসাবে, তুমি যদি কাস্টমার হও, তুমি যদি স্টিল প্ল্যান্ট চালাও, তুমি কি এক্সপেক্ট করবে, কতক্ষণ তুমি ডাউন টাইম দিতে চাইবে, গ্লাস প্ল্যান্টে গেলে তুমি কি এক্সপেক্ট করবে, কত পারফরমেন্স তোমার চাই, এই অ্যাঙ্গেল থেকে ভাবার চেষ্টা করো, এবং দিলে অনেক কিছুই আসবে। কারণ যেমন কোভিড আসার আগে আমরা কি ভেবেছিলাম অনলাইন মিটিং এত হবে? সিচুয়েশান আমাদের বানিয়ে দিয়েছে, এখন তো সারাদিনই মিটিং চলছে, রাইট? তো আমার মনে হয় এইসব জিনিসগুলো ভাবা দরকার। ঠিক, আর বলো। আচ্ছা, এদিকে এসছে এবার।
Good evening, sir.
Good evening.
Sir, আমার কোয়েশ্চেনটা একটু অন্যরকম, একটু টেকনিক্যাল, নন টেকনিক্যাল। যেটা হচ্ছে আজকে আমরা সবাই লাইক আর স্টুডেন্টস, we aspire to get good placement.
কোন ইয়ারে তুমি?
Sir, third year উঠলাম।
Okay.
We aspire to get good jobs, good packages, and eventually higher studies, and then probably to land in a prestigious position as yours. My question on the other hand is, if I personally want to build my own careers or build my own industry in these fields of along refractories or monolithics, as Ashish Kundu sir had alluded to talk on, what is the roadmap to get there, considering the fact that we do not have a background in family businesses and we are the first generation doing it? So, Ashki Calories is a 165-year-old company, but for me, if I have to start...
Calories 1,600 million euro company.
So, Ashki 165 years old company.
Okay.
So, Ashki যদি আমাকে স্টার্ট করতে হয়, then what is the roadmap, sir?
বাট মনে হয় আমি ঠিক লোক নই এটার অ্যান্সার করার, কারণ আশিস বেটার বলতে পারতো, আমি তো কোনোদিন ইন্ডাস্ট্রি চালু করিনি।
আমি ওনাকে জিজ্ঞেস করেছিলাম, ওনার সাথে আমার কথা হয়েছে, বাট আপনি যেহেতু এত মানে এক্সপার্টসদের মাঝখানে
না, আমার যেটুকু লিমিটেড এক্সপিরিয়েন্স, আমার সবসময় টেকনিক্যাল লাইনের সাথেই আমি কাজ করে গেছি, বি প্রোডাকশন, কোয়ালিটি কন্ট্রোল, ডেভেলপমেন্ট আর সার্ভিসেস। হ্যাঁ, আমার কিছু মানে অপরচুনিটি হয়েছে গ্লোবালি বিভিন্ন লোকের সাথে কানেক্ট করার, বা স্টিল আই এম কানেক্টেড। তো এখানে বেসিক্যালি একটা হচ্ছে নিজের ইচ্ছাশক্তির একটা মেন ব্যাপার। যদি তোমার এখন থেকে, যেমন করে আশিস শুরু করেছে, দেয়ার ওয়াজ এ টার্নিং পয়েন্ট। ওর যখন কেরো রাজেন্দ্র বা কেয়ার যখন অসুবিধে হলো, তো ওই রকম কোনো একটা ট্রিগার যদি আসে যেখানে তোমাকে সাডেনলি চিন্তা করে চেঞ্জ করতে হবে, এবং তোমার যদি সে অ্যাম্বিশন থাকে যে আমাকে করতে হবে এরকম ব্যাপার, তো সেখান থেকে একটা চালু করতে পারো। এবং তার আগে যদি তুমি যে জিনিসটা নিয়েই বিজনেস করতে চাও, যদি তুমি টোটাল সাইকেলটা একটু বুঝে নিতে পারো, যেমন কী ধরনের, মানে যদি মনে করো পার্সেল রিফ্যাক্টরি, বাট তুমি বিজনেস করতে গেলে রিফ্যাক্টরি ছেড়ে অন্য লাইনেও করতে পারো, তো তার ইনপুট থেকে নিয়ে আউটপুট, টোটাল যে ভ্যালু চেনটা আছে, এই ভ্যালু চেনের কোনটা ক্রিটিক্যাল কন্ট্রিবিউটার, এবং কিভাবে সেখানে তুমি অ্যাজ এ এন্টারপ্রেনিউর কি তুমি ভ্যালু এডিশন করতে পারবে, এবং আলটিমেটলি তুমি যে অ্যাজ এ আউটপুট যেটা তুমি মার্কেটে তোমার কোম্পানি যেটা ডেলিভার করবে, সেখানেও তুমি ভ্যালু এডিশন কী করবে। বিকজ আলটিমেটলি মার্কেটে সাস্টেন করতে গেলে আমাদের কিছু ডিফারেন্সিয়েটার নিয়েই আসতে। ক্যালোরিজ আমরা অ্যাজ এ কোম্পানি যেটা বারবারই চিন্তা করি যে আমরা সাধারণ ওই প্রাইসে আমরা করতে পারবো না, বিকজ উই ইনভেস্ট in our manpower pool, we invest in our technology, so there is some inbuilt, you can say, overhead in the system. Having said that, এটা তো সবসময় থাকবে, বাট কাস্টমারের কাছে গিয়ে আমরা কি ডেলিভার করলে কাস্টমার ক্যালোরিজকে প্রেফার্ড আমরা সব সেক্টরে নেই, নাও উই আর পেনিট্রেটিং ইন স্টিল, ওকে, ইন ইন্ডিয়া পারসে। বাট আগেও যদি আমরা বলি, আমরা মোটামুটি মনোলিথিকে ক্যালোরিজ ইন্ডিয়াতে দেয়ার ওয়াজ এ differentiator, knowing fully well price will be higher than your regular one, but then for some critical thing normally people still refer to calories and then try to interact with the calories. তো এইভাবে একটা তোমাকে ইমেজ তোমার সকল যা তুমি কোম্পানি যে লাইনেই করুক অ্যাজ এ ডিফারেন্সিয়েটার কিছু তো আমাকে তৈরি করতে হবে, বি ইট ডেলিভারি, বি ইট কস্ট, বি ইট সাম টেকনিক্যাল অ্যাডভান্টেজ, এনিথিং, অর মেবি টেকনিক্যাল সলিউশন প্রোভাইডিং এবিলিটি। আমার মনে হয় এই ডিফারেন্সিয়েশনটা ক্রিয়েট করা দরকার, এবং যে লাইনে তুমি বিজনেস করতে চাও সেই লাইনের টোটাল ইনপুট টু আউটপুট পুরো ভ্যালু চেন প্রপোজিশন যেটা আছে প্রত্যেকটা জায়গাতেই তোমাকে ইনডেপথ নলেজ রাখতে হবে, কিটার থেকে কি হতে পারে, কোনটা ক্রিটিক্যাল স্টেপ, এবং যাতে কিনা তোমার প্রবলেমটা লিমিটেড থাকে। বিকজ দুম করে একটা সার্ভিস থেকে নিয়ে এন্টারপ্রেনিউরশিপে দের ইজ এ লট অফ চ্যালেঞ্জ, বিকজ রিস্ক টেকিং এবিলিটি একটা বড় জিনিস, এবং নট অনলি টেকনিক্যাল, সেখানে তোমাকে তোমার ম্যানেজারিয়াল স্কিলটাও ভাবতে হবে, বা তোমার কন্ট্যাক্টস, তোমার কোলাবোরেশন, যারা কিনা তোমাকে হেল্প করবে। আলটিমেটলি বুককে পড়ে একটা লেভেল অবধি হয়, তারপরে তো ইন্টারাকশন থেকেই লোকে শিখতে পারে, জানতে পারে। তো এইসব জিনিসগুলো ধীরে ধীরে তোমাকে কমিউনিকেশন চ্যালেঞ্জ, অল দোজ থিংস ইউ নিড টু লুক ইনটু। এবং আজকের দিনে অনেক আছে তোমার এন্টারপ্রেনিউরশিপের জন্য অনেক কিছু কোর্স, বা অনেক প্রফেশনাল এ ধরনের ম্যানেজমেন্ট প্রোগ্রামেও কিছু কোর্স আছে, তুমি চিন্তা করে দেখতে পারো যদি তোমার সেই দিকে ন্যাক থাকে। তারপরে আশিসের মতো লোকের সাথে ইন্টারাক্ট করতে থাকো, আরও আছে নিশ্চয়ই এরকম লোক, ডেফিনেটলি দে উইল হেল্প, বাট আই এম নট দ্য রাইট পারসন টু অ্যান্সার দিস কোয়েশ্চেন। থ্যাংক ইউ। ইয়েস স্যার।
Good evening, sir.
Good evening.
I am Avitra Sharkar, second year ceramic technology. Sir, এখন যে কারেন্ট সিচুয়েশন অফ দ্য ওয়ার্ল্ড, সেখানে আমাদের কী কী ইনোভেটিভ প্রজেক্টে কাজ করা উচিত যাতে আমরা মানে কস্ট এফেক্টিভনেস হোক বা ইন্ডাস্ট্রি ডেভেলপমেন্ট হোক, সেগুলোতে কী কী প্রজেক্ট এখন মানে কী প্রজেক্ট যেগুলোতে আমাদের কাজ করা উচিত এখন?
দেখো, একটা বড় ইম্পর্টেন্ট জায়গা হচ্ছে যে যদি তুমি সেকেন্ডারি র মেটেরিয়ালের উপর কিছু কাজ করতে পারো, সাস্টেনেবিলিটি। সেকেন্ডারি র মেটেরিয়াল মানে প্রত্যেকটা প্রসেস থেকে কিছু তো লাইনিং মেটেরিয়াল করে, আমি রিফ্র্যাক্টরির জন্যই বলছি, বিকজ আমি গ্লাস বা ওই সেক্টর আমি টাচ করছি না ফর দ্য টাইম, বিকজ আই এম নট নলেজেবল দেয়ার। রিফ্র্যাক্টরি যদি বলো তাহলে এগেন কস্ট ওয়াইজ 70 to 80% is a raw material cost. Now raw material availability and also your cost both is a challenge there. Okay, one way to mitigate যেটা কিনা আমরা যদি এটাকে কিছুটা রিপ্লেস করতে পারি উইথ সেকেন্ডারি র মেটেরিয়াল। সেকেন্ডারি র মেটেরিয়াল মানে যেগুলো আমাদের লাইনিং থেকে, যেমন স্টিল প্লান্টের যেটা লাইনিং মেটেরিয়াল যখন ডিসম্যান্টেল হচ্ছে, রাইট, সিমেন্ট প্লান্টের লাইনিং মেটেরিয়াল ডিসম্যান্টেল হচ্ছে, সিরামিক ইন্ডাস্ট্রিজ কিছু লাইনিং মেটেরিয়াল আসছে। তো এই যে সেকেন্ডারি মেটেরিয়ালের ব্যাপারটা হচ্ছে, যেটা কিনা রিক্লেম মেটেরিয়াল, সেকেন্ডারি মেটেরিয়াল বলা হয়, আজকের দিনে কিন্তু এখানে অনেকটা কাজ করার স্কোপ আছে। নর্মালি কি করা হয়, আমরা মেজর ইনগ্রেডিয়েন্টস দেখেই আমরা চলে যাই, যেমন অ্যালুমিনা সিলিকেট মেটেরিয়াল, অ্যালুমিনা 50%, সিলিকা 20%, তো এটা এইভাবে ইউজ করা যাবে, কিন্তু সেটা নয়। এর মধ্যে যে মাইনর ইম্পিউরিটিসগুলো আছে, যেমন অ্যালকালি, আজকে যদি সিমেন্ট প্লান্টের ওয়েস্ট হয়, সিমেন্ট প্লান্টে তুমি দেখবে লট অফ অল্টারনেট ফুয়েল ইউজ করে। সিমেন্ট প্লান্ট বলতে আমি রোটারি কেন অ্যান্ড দেন পোর্টল্যান্ড সিমেন্টের কথা বলছি। ওখানে ইট ইজ বিং নাও প্রডিউসড অ্যাজ এ ইনসিনেটর। ইনসিনেটরে কী হয় যে আমাদের ওয়েস্টগুলোকে জ্বালানো হয়, অ্যাশটাকে তো ফেলা হয়, বাট সিমেন্ট প্লান্টে অ্যাশটাও ফেলে না, ওই অ্যাশটাও ক্লিঙ্কারের সাথে চলে আসে। কিন্তু এই যে ওয়েস্টগুলো জ্বালায় তাতে কি থাকে, সালফার থাকে, ক্লোরাইড থাকে, অ্যালকালি থাকে। তুমি সিমেন্ট প্লান্টের ওয়েস্ট মেটেরিয়াল দেখবে বিভিন্ন লোকেশানে, ডিপেন্ডিং আপন দ্য এরিয়া, অনেক ডিপোজিট ওর ওপরে হতে থাকে, কোনোটা অ্যালকালি রিচ, কোনোটা সালফেট রিচ, ডিপেন্ডিং আপন দ্য অপারেটিং সিচুয়েশন, এসআর রেশিও, আদার থিংস দেয়ার। তো এই যে সেকেন্ডারি র মেটেরিয়াল অনলি অ্যালুমিনা সিলিকা ধরলে হবে না, ওর যে সেকেন্ডারি যে ইম্পিউরিটিসগুলো আছে সেগুলোকেও আমাকে স্টাডি করে দেখতে হবে এবং তার কি এফেক্ট হতে পারে এবং যেটা কিনা তোমাকে রিফ্র্যাক্টরিতে ইউজ করতে হেল্প করবে। যদি সেই ইম্পিউরিটি কন্ট্রোল করা যায় তবে তোমার রিফ্র্যাক্টরিতে ইউজ হবে, নাহলে ডিজাস্টার্স হবে। এমনও কেস আছে এরকম র মেটেরিয়াল নেওয়া হয়েছে কাস্টেবলসের ক্ষেত্রে, জল দেওয়া হয়েছে, মেটেরিয়াল ফ্লো হয় না, ঠিক আছে, মানে প্লেসমেন্টই করা যায় না। কারণটা হচ্ছে এই ইম্পিউরিটিসগুলো। তো ওয়ান ওয়ে হচ্ছে এই যে সেকেন্ডারি র মেটেরিয়ালের খুব ইম্পর্টেন্স আছে, দরকার আছে আজকের দিনে, তাকে ক্রিটিক্যালি স্টাডি করাটা খুব ইম্পর্টেন্ট জিনিস এবং কোন র মেটেরিয়ালটা কী ধরনের ইম্পিউরিটি থাকতে পারে, কীভাবে বেনিফিশিয়েট করা যায়, কীভাবে ভ্যালু এডিশন করা যায় এবং কোথায় তাকে ইউজ করা যায়, সেটা একটা স্টাডি আমার মনে হয় র মেটেরিয়ালের বেসিসে করলে অনেকটা ভালো জিনিস আসতে পারে। এবং বাকি তোমার মানে তুমি বলতে চাইছিলে মিডল ইস্ট ক্রাইসিসের জন্য কীভাবে মিটিগেশন করা, তো আমার মনে হয় এইটাই একটা বড় ব্যাপার। আর তো মনে হয় স্টুডেন্ট হিসাবে র মেটেরিয়াল দিকটাই বেশি স্টাডি করাটা দরকার আমার মনে হয়। হ্যাঁ, তোমার মাইক কোথায়, নাহলে এটা নিয়ে বলো তো।
অ্যাকচুয়ালি স্যার আমরা দেখি যে কাস্টেবলের ক্ষেত্রে মানে এটা একটা খুব গ্রোয়িং মার্কেট এবং প্রত্যেকটা কোম্পানি কাস্টেবলকে নিয়ে ভাবছে। আমার কোশ্চেন হচ্ছে ইন ফিউচারে কি কাস্টেবল রিফ্র্যাক্টরিকে রিপ্লেস করতে পারবে? কারণ আমরা এখন দেখি না বিল্ডিং যেগুলো হয় 3D প্রিন্টিং দিয়ে বিভিন্ন ধরনের বিল্ডিং হচ্ছে, সেম টাইপের 3D প্রিন্টিং দিয়ে কাস্টেবল দিয়ে কি আমরা কোনো ল্যাডেলের ইন্টারলাইনিং বা ইত্যাদি কিছু করতে পারি?
না, কাস্টেবল অলরেডি ল্যাডেলে ইউজ হচ্ছে, স্টিল হট মেটাল ল্যাডেলে তো ইউজ হয়েছে, ক্যালরিজ ইন্ডিয়াতেই করেছে। হট মেটাল ল্যাডেলে তোমার টেম্পারেচার বেশি নয়, অ্যারাউন্ড 1400 1450 এই ধরনের টেম্পারেচার থাকে। ওখানে বেসিক্যালি তুমি সিমেন্ট ফ্রি, আমরা শর্টকিট করেছি। শর্টকিট মানে ওই যেটাকে বললাম মেকানাইজড ওয়ে, তুমি পুরো জিনিসটা মিক্সচারে বানিয়ে পাম্প করে নিয়ে যাও এবং পুরো ল্যাডেলটাকে তুমি মানে গান করে পুরো লাগিয়ে দাও, ঠিক আছে। হট মেটাল ল্যাডেলে তো এটা ইজি, এটা কোনো অতটা অসুবিধা নেই। চ্যালেঞ্জ হচ্ছে স্টিল ল্যাডেলে। স্টিল ল্যাডেলের ক্ষেত্রে মেটাল জোন বটম তো কাস্টেবল দিয়ে রেডি শেপ মানে প্রিকাস্ট বানিয়ে ইনস্টল করা হয়। মেটাল জোন অলরেডি আছে, ইউরোপে অনেক অ্যাপ্লিকেশান আছে, জাপানে চলে, ইন্ডিয়াতে এতটা ইউজ নেই। কারণ হচ্ছে এখানে একটা কমার্শিয়াল রিজন আছে। বেসিক্যালি যারা আল্ট্রা লো কার্বন স্টিল বানায়, কার্বন পিক আপ যাদের কাছে খুব ইম্পর্টেন্ট হয় বা সুপার হিটটা যাদের কাছে খুব ইম্পর্টেন্ট হয়, সুপার হিট মানে যতখানি বেশি টেম্পারেচার তোমাকে রাখতে হবে টু কাস্ট ইট, তো যদি সেই কম টেম্পারেচারে সুপার হিট রাখতে চাও, কম গ্যাপ মানে হিট ডিসিপেশন কন্ট্রোল করতে চাও, সেই ধরনের জায়গাতে লোকে মনোলিথিক লাইনিংয়ের কথা ভাবে। কিন্তু ইন্ডিয়াতে সেই ধরনের ব্যাপার এলেও সেখানে অ্যালুমিনিয়াম স্পিনেল ব্রিক চলে এসছে অলরেডি, ঠিক আছে। কিন্তু কাস্টেবল অলরেডি গ্লোবালি অনলি স্ল্যাগ জোন ছাড়া মোটামুটি গ্লোবালি কাস্টেবল ইজ এ সলিউশন। এবং কাস্টেবলে আরেকটা জিনিস হচ্ছে কি এন্ডলেস রিপেয়ার, মানে তুমি ওই কাস্টেবলটার ওপরেই যদি স্ল্যাগ বা কিছু ইনফিল্ট্রেশন হলো ওটাকে চিপ অফ করে ওরই ওপরে তুমি রিপেয়ার করে চালাতে থাকো। মেবি ইউ ক্যান গো আপ টু সে পার্মানেন্ট লাইনিংয়ের লাইফ যেমন মনে করো সে 700 হিট 800 হিট, ইউ ক্যান টেক দ্যাট অ্যামাউন্ট অফ ইয়ে, তাতে ওভারঅল মানে কস্ট অফ প্রোডাকশন তোমার কমতে থাকে অ্যাজ ইউ ইনক্রিজ দ্য ক্যাম্পেন লাইফ। তো এটা অলরেডি দেয়ার, নাথিং নিউ, এটা হবে হচ্ছে ডিপেন্ডিং আপন দ্য কাস্টমার রিকোয়ারমেন্ট, কাস্টমার চয়েস। যদি কাস্টমার কীভাবে কী চায় তার হিসাবে এটা হচ্ছে, এটাতে কোনো অসুবিধে মনে হয় নেই। স্ল্যাগ জোনে যদি করতে চাও, স্ল্যাগ জোনে করোশনটা ক্রিটিক্যাল এবং সেখানে আরও কাজ করার স্কোপ আছে, করে দেখতে হবে।
কিন্তু মানে আপনি যেটা বললেন ওটার জন্য কস্ট কম,
কোনটায় কস্ট কমবে? যদি তুমি মনে করো আজকের দিনে 150 হিট তুমি একটা লেভেল থেকে নিচ্ছ রানিং লাইফ, ঠিক আছে। আমাদের নর্মাল সিকোয়েন্স কী হয়, আমরা যদি 150 হিট লাইফ হয় আমরা ইন বিটুইন 70-75 স্ল্যাগ জোন বের করে দিই, মানে একটা টোটাল ল্যাডেল লাইফের মধ্যে দুবার স্ল্যাগ জোন যায়, যেহেতু মোস্ট ক্রিটিক্যাল তোমার ওয়্যার হয়। মেটাল জোন ফুল 150 যাবে, স্ল্যাগ জোন 75-এর পর ডিসকার্ড, এগেন 75 ফ্রেশ হিট দিয়ে তুমি চালালে, ঠিক আছে। যখন তুমি কাস্টেবল দিয়ে লাইনিং করবে তখন এটাকে 150-তে রেস্ট্রিক্ট করলে তাহলে কিন্তু কস্ট ইকোনমি পাওয়া যায় না। এটা দেখা গেছে ব্রেক ইভেন করে, যদি মনে করো 600, 650, 700 এইরকম লাইফ যায়, তাতে কি হবে, তোমার ডিসম্যান্টেল করতে হচ্ছে না, অনেকটা ডেব্রিস জেনারেশন কম হচ্ছে, ইট ইজ গুড ফর দ্য এনভায়রনমেন্ট। সেকেন্ডলি ওভারঅল যখন তুমি ক্যাম্পেন বাড়াচ্ছ, ওই তো কাস্টেবলের কস্টটা ডিস্ট্রিবিউট হয়ে যাচ্ছে। কারণটা হচ্ছে ম্যাগনেসিয়া কার্বন ব্রিকের যদি তুমি কস্ট দেখো, ঠিক আছে, তার থেকে কিন্তু কাস্টেবলের পার টন কস্ট বেশি, এটা হবেই। অ্যালুমিনিয়াম স্পিনেলের কস্ট, কারণ সিনথেটিক মেটেরিয়াল স্পিনেল তুমি দিচ্ছ, অ্যালুমিনিয়াম স্পিনেলের কস্ট বেশি। প্রথমবারে একবারে চালিয়ে তুমি জাস্টিফাই করতে পারবে না, যদি এটাকে তুমি এন্ডলেস লাইনিং কনসেপ্টে এক্সটেন্ড করতে পারো, দেন অনলি, অ্যান্ড দেন ইফ স্টিল প্ল্যান্ট ওয়ান্স, ওদের আল্ট্রা লো কার্বন লাগবে, লো সুপার হিট লাগবে, হিট লস কম, বিকজ যদি কার্বন কন্টেনিং লেভেলে যে হিট লস হবে, অ্যালুমিনিয়াম স্পিনেলের লেভেলে অনেক হিট লস কম হবে, তো দে উইল হ্যাভ সেভিং ইফ দে আর, বিকজ দেয়ার আর সাম স্টিল প্ল্যান্ট ইন ইউরোপ যেখানে কিনা এই জিনিসটা হচ্ছে, আমরা কিছু কাজ করছি ওখানে, তো ওরা ওই জিনিসটা যে আমরা এনার্জি এফিসিয়েন্সি বাড়াতে চাই, অলরেডি দে আর ইউজিং, আমরা যদি কিছু দিতে পারি দে উইল ট্রাই দেয়ার। তো এই কনসেপ্টে চিন্তা করতে হবে, ঠিক আছে। তোমার ব্রিককে কাস্টেবল রিপ্লেস তো করেইছে, আগে তোমার অ্যালুমিনিয়াম প্লান্টে পুরো ব্রিক ছিল, এখন মেজরিটি অ্যালুমিনিয়াম প্লান্ট কাস্টেবলস হয়েছে। বিকজ কী হয়েছে, কাস্টেবলের সুবিধা হচ্ছে কি, আমি কাস্টেবল পার্সে আমি বলছি যে কোনো মনোলিথিক, তোমার নাম্বার অফ জয়েন্টস তো কমে যাচ্ছে, দেন এনি জয়েন্টস ইজ প্রোন টু ইয়োর করোশন অর এনি অ্যাটাক। If you are minimizing joints, then you have better with respect to corrosion behavior, theoretically. But there is a compromise with respect to flexibility. Any joints, again, good for your flexibility, mechanical flexibility. So there we have to see, castability কিভাবে flexibility বাড়ানো যায়. There are cases where you can do that, and there are solutions also.
যেখানে ধরুন আমরা কার্বন ব্লক ইউজ করি রিফ্লেক্টিভ, ওখানে কাস্টেবলিজম আমরা কি ইউজ করতে পারি রিপ্লেসে?
কার্বন ব্লকের এটা পেটেন্টেড জিনিস, ওকে অ্যাপেল টু অ্যাপেল রিপ্লেসমেন্ট হবে না, তবে আমরা যে জিনিসটা করেছি সেটা হচ্ছে মিনি ব্লাস্ট ফার্নেসের ক্ষেত্রে, যেমন 40 টন এই ধরনের ফার্নেসের ক্ষেত্রে আমরা ওখানে অ্যালুমিনিয়াম সিলিকন কার্বাইড কার্বন কাস্টেবল দিয়েছি শর্টকিট করে, এবং সেই জিনিস চলেছে, মানে 7-8টা জায়গায় করা হয়েছে, ইটস এ প্রুভেন সলিউশন। অ্যান্ড রিসেন্টলি উই হ্যাভ ডান ইট উইথ জেল বন্ডেড অলসো, বিকজ ব্লাস্ট ফার্নেসের মধ্যে একটু লাইন দেওয়াটাও অতটা ভালো নয়, কারণটা হচ্ছে তোমার স্ল্যাগ কেমিস্ট্রি হচ্ছে টুয়ার্ডস অ্যাসিডিক, ঠিক আছে, তো সেখানে কোলাইডাল সিলিকা বন্ডেড ইজ বেটার ওয়ান। তো রিসেন্টলি ডলবিতেও করা হয়েছে, তো নট হার্ড, ইজ বেসিক্যালি কিউআর এরিয়া, তো ইট ইজ পারফর্মিং এবং আছে, দেয়ার ইজ সলিউশন, বাট দেন ইট উইল নট বি ইকুইভ্যালেন্ট টু ইউর কার্বন ব্লক, বিকজ কার্বন ব্লকের লাইফ মোটামুটি যদি ফার্নেসে মনে করো সে 1.5-2 সাল পায়, এগুলো দিয়ে মোটামুটি 6-8 মাস, অ্যান্ড তারপরে তোমাকে আরেকবার ইয়ে করতে হবে।
আমার কোশ্চেন হলো যে ইফেক্টিভ অনেক ওয়ার্ক ইউজ হয়, সেই ওয়ার্কগুলো ইনক্লুড থাকে, সেই ইনক্লুডগুলো অনেক কীভাবে আমরা ইউজ করি, মানে ইনক্লুডগুলোকে লেস করে ইউজ করি না ওয়ার্ডে ডাইরেক্ট ইউজ করি, এমন শর্ট আউট করা যায়
না, এটাই আমি ওর সাথে বলছিলাম যে এটাতে যেটা বেসিক্যালি আমাদের উইক পয়েন্ট অ্যাজ এ ক্যালোরিজ, উই আর নট ডুইং মাচ অন র মেটেরিয়াল, বাট এটা গ্লোবালি যেটা করা হয় ইটস এ টোটালি মানে মেটেরিয়াল লিফট করে ওখান থেকে তোমাকে বেসিক্যালি চিপ অফ করা, ওয়াশ করা, তোমাকে যা কিছু করতে হবে ক্রাশিং গ্রাইন্ডিংয়ের আগে করতে হবে। বেসিক্যালি ক্রাশিং গ্রাইন্ডিংয়ে গ্রেডিং হয়ে গেলে তুমি ডিফারেন্সিয়েট করতে পারবে না, বেসিক্যালি স্মল গ্রেনস ওখান থেকে ডিফারেন্সিয়েট করা যায় না। যা হয় যে তোমার ওখানে ইউজড মেটেরিয়াল যেটা এলো ওখানে যদি সারফেস ডিপোজিশন থাকে ওটাকে চিপ অফ করে দিতে হয়, বা কিছু ওয়াশ করার হলো, ওয়াটার সলিউবল ইম্পিউরিটি হলো চলে যাবে বা কমে যাবে, রাইট, তারপরে তুমি ক্রাশ করলে, বা তুমি সেই সময় একটা কেমিস্ট্রি করতে পারো। এখন তোমাকে মাইক্রো এক্সআরএফও আছে, মাইক্রো এক্সআরএফে তুমি জাস্ট 3-4 ইঞ্চির টুকরো দিয়েও তুমি ক্যান হ্যাভ এ কেমিস্ট্রি দেয়ার, তো ইউ ক্যান হ্যাভ এন আইডিয়া কি ওই ওয়ার্কিং ফেসে কী ধরনের ইম্পিউরিটি ডিস্ট্রিবিউশন আছে। কিন্তু এটা করা দরকার, যার জন্যই আমাকে বলছিলাম এই ধরনের স্টাডি খুব এসেন্সিয়াল, যে identify the reclaim or maybe the waste stuff, and then what may be the potential impurities, এবং কিভাবে ওটাকে বেনিফিশিয়েশন বা সেগ্রিগেশন করা যায়, অ্যান্ড দেন ফাইনালি ভ্যালুয়েটেড সলিউশন কীভাবে ওটার থেকে জেনারেট করা যায়। তো এই জিনিসটা কাজ করা দরকার এবং সেটা আগের দিনে আরও বেশি ইম্পর্টেন্ট হবে যত র মেটেরিয়ালের তোমার কস্ট বাড়ছে বা ইয়ে হবে।
বলছিলাম যে আমাদের কার্বন ব্ল্যাক ইউজ করি, সেটা তো ম্যাক্সিমাম টেম্পারেচার টেম্পারিং করা হয়, টেম্পারিং আর কি 230 ডিগ্রি সেন্টিগ্রেড। ওটা তো স্যার পরে যখন স্টিমেটিংয়ে ইউজ হয় তখন তো ওটা প্রায় আরও অনেক 60 ডিগ্রি সেন্টিগ্রেড টেম্পারেচার পার হয়ে যায়। স্যার ওটা কী করে সম্ভব, মানে যখন সিন্টারিংয়ের সময় যখন আমরা কার্বন ব্লকটাকে সিলেক্ট করতে পারি না, সেটা অক্সাইড হয়ে যায়, অক্সাইড হয়ে যায় বলে, কিন্তু ওখানে কী করে আমরা ইউজ করতে পারছি?
মানে তুমি কি কার্বন ব্লকের ম্যানুফ্যাকচারিং বলতে চাইছো?
ম্যানুফ্যাকচারিংয়ের সময় তো কার্বন ব্লককে টেম্পারিং বা কিভাবে করা হয়?
আমি এই প্রসেসটা জানি না, কারণ এটা কার্বন ব্ল্যাক বেসিক্যালি ইন্ডিয়াতে আমরা বানাই না, আমার জানা নেই কেউ বানায় বলে, এবং এটা গ্লোবালি ইট ইজ পেটেন্টেড টেকনোলজি। এটা খুব একটা ওপেন টু নট অল। তো কিভাবে ওরা বানায় কি করে এক্স্যাক্টলি আমার জানা নেই। ম্যাগনেসিয়া কার্বন ঠিক আছে, অ্যালুমিনা কার্বন ঠিক আছে, অ্যালুমিনা ম্যাগনেসিয়া কার্বন ঠিক আছে, বাট কার্বন ব্ল্যাক ইজ টোটালি ডিফারেন্ট। সবাই বানায় না, এক দুটো সাপ্লায়ারই বোধহয় আছে।
আমরা দেখি কাস্টমারের ক্ষেত্রে যে যখন অ্যাপ্লিকেশন হচ্ছে যে এআই এনেবল কিছু কিছু রোবট সিস্টেম দিয়ে অ্যাপ্লাই করা যায়, তো ফর কাস্টমার অ্যাপ্লিকেশন সিস্টেম ইজ ইট পসিবল টু রিপ্লেসমেন্ট অফ ম্যান পাওয়ার?
Not replacement of manpower, reduction of the manpower, that is possible, because I will give an example that আমরা যেটা করি আর কি, ব্লাস্ট ফার্নেস স্ট্যাকে তোমার যদি রিপেয়ার করতে হয়, তো স্ট্যাকের ওখানে তো লোক দুম করে নামানো সম্ভব নয়, বিকজ ব্লাস্ট ফার্নেসে সবসময় কিছু না কিছু মল্টেন মেটেরিয়াল বটমে থাকে, যেটাকে আমরা চার বলি, ঠিক আছে। অলওয়েজ তুমি যদি দেখো ব্লাস্ট ফার্নেসের ভেতরে যখন ডাউন হয়েছে ব্লাস্ট ফার্নেস, তখনও ওখানে মানে আগুনের ওই হলকা ওটা দেখা যায়, ঠিক আছে, 1000 অ্যারাউন্ড ওই টেম্পারেচার থাকে। আমরা কি করি, ওর ওপরে কিছু ওয়েস্ট ফেলে দিই, যাতে কিনা চারটার থেকে হিটটা রেডিয়েট হয়ে শরীরে কম আসে, ঠিক আছে। এবং তারপরে কি করা হয়, ওই রোবোটিক আমরা ওই ক্যামেরা যেরকম কথা হচ্ছিল ওইখান দিয়ে আমরা পুশ করে দিই, দিয়ে উইদিন দ্য স্ট্যাক আমরা লোকেট করে নিই কোন কোন জায়গায় কীভাবে রিপেয়ার করা হয়, বা টোটাল প্রোফাইলিংও করে নেওয়া হয় স্ক্যানিং করে স্ট্যাকে। এবং তারপরে আমরা শর্টকিট করি, যেমন তোমার ওই গ্রাউন্ড ফ্লোরে মিক্সচার রাখি, দিয়ে ওই মেটেরিয়ালটা পুরো পাম্প করে গিয়ে এবং রোবটের থ্রু দিয়ে তোমার ভেতরে গিয়ে ওটা একটা স্প্রে করতে থাকে, রোবোটিক স্প্রে, এবং নিচে থেকে করতে 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 ধীরে ধীরে ওটা ওপরের দিকে ওঠে। এবং আফটার দ্যাট এগেন উইল ডু এ প্রোফাইলিং, স্ক্যানিংয়ের থ্রু দিয়ে প্রোফাইলিং করা হয়। তাহলে বিফোর আফটার তুমি যদি ডিফারেন্স করো কতখানি বিল্ড আপ হলো তুমি জানতে পারবে। কারণ এটা খুব ক্রিটিক্যাল এই কারণ হচ্ছে কি, ব্লাস্ট ফার্নেস যখন তুমি রিপেয়ারিংয়ের পরে যখন তুমি অপারেশনে নেবে, তখন কি করবে, তুমি কোক ঢালবে, এবং তখন তোমার ধীরে ধীরে প্রথমে তো কোক আসবে, কোকের বেডটা তো বিল্ড আপ হবে, তারপরে তোমাকে ডোলোমাইট, আয়রন ওর এগুলোকে ফিল করবে, ঠিক আছে। কিন্তু তখন যদি কোকটার থেকে ধীরে ধীরে মেটালটা যদি না পার্কোলেট করে, তাহলে কী হয়, ডিস্ট্রিবিউশনটা খুব আনইভেন হয়ে যায়। ওরা তখন বলে ফার্নেস হ্যাং হয়ে গেছে। বেসিক্যালি তুমি যদি ব্লাস্ট ফার্নেসের মানে প্রসেস এগেন তুমি দেখো অপারেশন, সেখানে তোমার ওই ধরনের জিনিসগুলো খুব ক্রিটিক্যাল। সুতরাং ইনসাইড প্রোফাইল কি হিসাবে ব্লাস্ট ফার্নেস ছিল, রিভ্যাম্প করে তোমাকে সেম প্রোফাইলে দিতে হবে, এবং তার জন্য এটা খুব ইম্পর্টেন্ট, প্রোফাইলিং, রোবোটিক রিপেয়ার। এবং আগে ভিসিবিএসও করতো, এখন ক্যালারিজ অনেক বিগার ওয়েতে করে, এটা তো করা হয় রোবোটিক রিপেয়ার, ঠিক আছে। ওইখান থেকে কোনো কোশ্চেন এলো না, ওরা নিজেদের মধ্যে ডিসকাস করছে।
Well, that was a very informative session. Nice interactions and a lot of information that it's possible that it made our heads hurt. Well, thank you, sir, for this really interactive and nice session, and I'm happy that we were given this opportunity to interact with you. Thank you, sir.
As we move ahead, we would also like to take a moment to acknowledge and celebrate the contribution of our former core members, whose dedication and efforts have played an important role in shaping our journey of InCerS student chapter of GCECT. Unfortunately, all our former core members could not be present with us today, but we are truly delighted to have a few of them among us this evening.
During this session, we will also be served refreshments, so I please request everyone to calmly sit down and keep the beverages coupon in their hands when the refreshments would be served.
May I first invite Mr. Intikhab Alam Khan, former chairperson of InCerS student chapter of GCCT, to kindly come forward and address the gathering.
না এখন আর কিছু বলছি
Hello. First of all, a very good evening. My name is Intikhab Alam Khan. I am a pass out of CT25 batch and currently employed with TARANGA'26. So, I was the first chairperson of this society. So, this society is not just one day's work. We went through a total of 3 years work between different colleges, managing 30 people. Here now we have more than 60, 70, hundreds of students in the student chapter. But to open a student chapter, we were not getting 30 people. We had to struggle from years to years so that people would take membership. And we finally, during the last year, last 5 months, basically 8th semester, we were finally able to open this chapter. So, first of all, I would like to congratulate all the previous and present core members of the society for a wonderful TARANGA'26. So, congratulations to all of you. Next, it feels a little emotional basically to stand on the same ground where I stood last year, but not same. The only thing different is this tag which says delegate instead of core member. So, further in the coming years also I would get to have this opportunity. So, this Taranga is one of my favorite things to do. I just landed in Kolkata today in the 10 a.m. and just in 1 hour I came to college, because this is one of the things I am personally connected to, and I would want that feeling to be with me till the end. And maybe, who knows, in some future years I will be able to give a lecture here on some topic based on refractory. So, that will also be a moment to cherish. Other than that, it was a great, wonderful evening. I had a lot of opportunities to interact with people, enjoy your company, and it felt good to be away from the harsh environment of the plant into an AC room. That's something different, which Abir would know how it is in the plant. Abir? So, once again, thank you all of you for this wonderful opportunity, and I hope the present and the former, and I wish the former or the later, all of the core committees to work together and take this chapter to great heights and take that consecutive Best Excellence Award year after year. Thank you.
For those valuable experiences and words of encouragement. Now I'd like to invite Mr. Abir Mondolda, former treasurer of InCerS SC GCCT, to kindly come forward and share a few words.
Good evening, everyone. It feels good to be back here. You know, I was thinking, I was standing here last year, so it's emotional, right? So I was hosting the events, quizzes and all last year. Now I'm just sitting there, I'm participating and enjoying whatever the juniors have cooked up for this day. It was great. I feel very proud of my juniors that they are continuing our legacy. Hope to get the Best Student Chapter Award again I would feel very proud for that too. I'd also ask the juniors, the upcoming office members that are going to be, to please continue this legacy, and may our student chapter be the best for all the time. Thank you GCCD for giving me this opportunity to come up on this stage and share my experience. Thank you.
Thank you, Abhita, for those really emotional words and your continued support towards the chapter.
So now, after a day filled with learnings, insightful discussion and inspiring interaction, it is now time to add colors, rhythm and celebration to the evening.
Because every memorable event deserves moments of joy, expression and creativity.
We now begin the cultural program and invite everyone to sit back, relax and enjoy the performances prepared especially for today.
To begin our cultural segment, we have a graceful dance performance that beautifully celebrates joy and harmony.
Please welcome Ms. Shishita Das for a solo dance performance on Anando Loke Mongola Loke.
Let us encourage her with a huge round of applause. Touching hearts and expressing emotions beyond words. Up next, we have a soulful musical performance by Miss Shivangi Saha, who will present Tumi Robe Nirobe. Please welcome her with a round of applause.
Thank you, Shibangi, for such a melodious performance. And to conclude our cultural program, we have an exciting final performance prepared for all of you. Please welcome Ms. Rahini Ghosh and Ms. Sohini Kundudi for a special duo performance. Let's cheer them with a huge round of applause.
হৃদয়ে মন্দ্রিল ডমর গুরু গুরু ঘন মেঘের ভুরু কুটিল কুঞ্চিত হলো রোমাঞ্চিত বন বনান্তর দুলিল চঞ্চল বক্ষ হিন্দোলে মিলন স্বপ্নে সে কোন তিথিরে হৃদয়ে মন্দ্রিল ডমর গুরু গুরু ঘন মেঘের ভুরু কুটিল কুঞ্চিত হলো রোমাঞ্চিত বন বনান্তর দুলিল চঞ্চল বক্ষ হিন্দোলে মিলন স্বপ্নে সে কোন তিথিরে
Let us once again give a huge round of applause to all of our performers for making this evening even more memorable.
As we move towards the concluding segment of Taranga'26, we now arrive at a moment of celebration and recognition.
Throughout the year, our chapter organized various competitions that witnessed enthusiastic participation, creativity, and talent from students. It is now time to recognize and appreciate the efforts and achievements of our winners.
I would now like to invite Ruma ma'am to come up on stage and the previous office bearers to come up on the stage for the valedictory session. Getting our former chairperson. I would now like to invite Abir Mondolda to receive felicitment from Ruma ma'am. Give a huge round of applause for him.
অনেকগুলো ইভেন্টও আছে, নাম ধরবো, তাড়াতাড়ি চলে আসবে সবাই। ওকে, ফার্স্ট হচ্ছে ইস ফটোগ্রাফি কম্পিটিশন, ফার্স্ট সোহিনী সরকার। ড্রয়িং কম্পিটিশনে ফার্স্ট সেকেন্ড থার্ড রেডি থাক। ড্রয়িং কম্পিটিশনে ফার্স্ট অনিল কুমার দে। সেকেন্ড রচনা দে, থার্ড সৌম্যদীপ মণ্ডল। এসে রাইটিং কম্পিটিশন দে, রেডি।
থার্ড মণ্ডল, সৌম্যদীপ মণ্ডল।
এসে রাইটিং ফার্স্ট সঞ্চয়ন সেনগুপ্ত।
প্ল্যান দর্শক হাততালি দিয়ে দাও।
সেকেন্ড শিবাঙ্গী শাহ।
একটা হাসি হাসি।
আমরা একটা কুইজ কম্পিটিশন করিয়েছিলাম ফার্স্ট ইয়ারদের মধ্যে। ফার্স্ট হয়েছিল আরমান, সেকেন্ড শুভ্রনীল দত্ত, থার্ড রূপম মন্ডল। আরমান আসেনি, সেকেন্ড শুভ্রনীল। কালচারাল পারফরমেন্সের ফার্স্টে শীর্ষে দেওয়া স্টেজে
শিবাঙ্গী। এদিকে এদিকে।
রাহিনী আর সোহিনী।
নেক্সট শিবাঙ্গী। নেক্সট রাহিনী and সোহিনী। একটা জোরে হাততালি হোক তাদের ওয়ান্ডারফুল পারফরমেন্সের জন্য।
ভলেন্টিয়ার্সের বিভিন্ন দারুণ সবাই এফর্ট দিয়েছে, এক করে ডাকবে, তারপরে চলে আসিস। ফার্স্ট সুপ্রিয়া সিরিন চৌধুরী নেই। সেকেন্ড শ্রদ্ধা ঘোষ, ফার্স্ট ইয়ার। শুভ্রনীল দত্ত, অরিত্র কর, তৃষা নস্কর, সঞ্জিতা পাল, অনিকেত কুরকাই, প্রিয়ান ঘোষ, সুদীপ্ত মণ্ডল।
নেক্সট থ্যাংক ইউ পুরো ভলেন্টিয়ারকে। পুরো ইভেন্ট জুড়ে ওরা যা কাজ করেছে গত দুদিন, ইটস কোনো কথা হবে না। এই যে আমার সামনে কিছু ভলেন্টিয়ার বসে আছে, এই যে রূপম ব্যানারটা টাঙিয়েছে, দুদিকে দুটো তরঙ্গ, এত কিছু খাওয়ালাম তারপরেও লাগবে।
সেকেন্ড ইয়ার প্রতীক, জয়দেব, দেবাঞ্জন বণিক, অনিল কুমার দে, সুপর্ণ গাইতি, সুশোভন নিন্দা, সিরিল পিয়াস, তানিয়া রয়, অঞ্চিতা সুব্বা, রুদ্রনীল মণ্ডল, শিবাঙ্গী সাহা, শান্তা, সোহিনী, শীর্ষদীপ, অনুভব, অঙ্কন, সানিয়া পারভিন হোসেন।
All the volunteers, please come on stage. I will request Integ Abda and Avida also join on the stage. The big man, the ex-treasurer, Avida on the stage.
অমজ্যোতি ছাত্রা, সৌমজিৎ সরকার।
Sivangi. Fast, Sivangi.
কেউ বেরোস না প্লিজ।
Chalo, next. Thank you all the volunteers. Thank you. And especially Srijit. Extra thanks. Next. অনুভব আজ অনেক খেটেছে, অনুভবের জন্য একটা জোরে হাততালিও।
অরিজিৎ মাহাতো, সৃজিত ঘোষ, পল্লবী রয়।
Srijit, please come on the stage. Pallavi.
আকাশ।
Next.
প্রীতম।
Next. Pallavi, Akash,
চয়ন।
আজকে আজকে আকাশ কলেজ স্ট্রিট থেকে ব্যাম্বু ট্রি এই এত গরমে না আকাশ হলে অনেক করেছে। তুই কি কোচি ছাড়া আসবি না?
ভাস্কর আর চয়ন।
নেক্সট another frame.
পল্লবী পল্লবী কোথায়? পল্লবী
and Somodhi Mondol.
অলিম্পিয়াতে এত পরিশ্রমের জন্য আমরা আজকে ব্যাকগ্রাউন্ডেই আমরা দাঁড়িয়ে আছি। থ্যাংক ইউ সবাইকে। 2-3 দিন ধরে অক্লান্ত পরিশ্রমে আমরা এই ইভেন্ট নামিয়েছি। থ্যাংক ইউ। 3 দিন।
and volunteer lead রিয়াঙ্কা দাসের জন্য একটা জোরে হাততালি।
আমাদের ইন্ডিয়ান সিরামিক সোসাইটি স্টুডেন্ট চ্যাপ্টার অফ GCECT অনেকগুলো ভালো ভালো উইং আছে, যার জন্য আমরা এতটা পপুলারিটি পেয়েছি। এডিটোরিয়াল বোর্ড, পিআর টিম, ডিজাইন টিম, তাদের মেম্বার, লিড, কো-লিড সবাই খুব ভালো কাজ করেছে এবং ইভেন অনেক সেকেন্ড ইয়ার তো খুব ভালো রেসপন্স করেছিল, যতটা আমি ফিডব্যাক নিয়েছি। তাদেরকে আমি আমাদের কোর টিম, আমাদের প্রেজেন্ট কোর টিম, তাদের কনসিডার করতে চাই। এক এক করে নাম বলবো, চলে আসবো। ফার্স্টে মেম্বারদের, ওকে। ডিজাইন টিম সায়ন্না,
সায়ন্না সিরসোদি, next Piyagi and Somoji. First Shivangi, then Somoji, and after that we come.
এডিটোরিয়াল বোর্ডটা রেডি থাকো, ওকে। কমিক্স অঙ্কিত নন্দী, অনিল কুমার দে, অঞ্জিতা সুব্বা, সৌরাশিস দে।
মানে জোরে হাততালি হোক।
অঙ্কিত নন্দী, অনিল কুমার দে, অঞ্জিতা সুব্বা, সৌরাশিস দে।
আমাদের অর্ণবদা, অর্ণবদার সেই পিআর টিম, যেটা নিজের মতো করে মানে খুব সুন্দরভাবে গড়ে তুলেছিল এবং সুন্দরভাবে কমিউনিকেশন সুন্দর করে আজ এমনি এখানে প্রস্তুত করেছে তাদেরকে।
নেক্সট মিমস আকাশ দত্ত, অঙ্কিত দাস, প্রীতম দে, মেম্বার।
নেক্সট
নেক্সট মেটেরিয়াল স্পটলাইট সৌমদীপ মণ্ডল, সোহিনী সরকার, অঙ্কিত নন্দী, সঞ্চান সেনগুপ্ত।
This is our editorial team plus the research minds যারা পুরো memes গুলো বানায় আর সবটা দেখে know your metals and materials যাদের থাকে। হাত তালি রে ভাই, আর এনার্জি নেই বুঝতে পারছি স্টিল।
Guys, smile. Guys. Okay, thank you. Everyone, please collect your refreshment from the outdoor.